Right. Good morning, my dear students. Today, another lesson, moving charges and magnetism. Today, let us discuss this lesson. And so, already in the theory about the Biot-Savart's law, you know that. So, how to produce the magnetic field by a current carrying conductor. By using the Biot-Savart's law, we can derive magnetic field due to a circular coil and magnetic field due to a straight wire. And the most of problems in the objective are coming from the circular coil and straight conductor, and sometimes the combination of magnetic field due to combination of circular coil and current carrying conductor which is straight line. So first of all, let us go for the circular conductor, then after let us go for the straight conductor. Now for example, magnetic field due to circular conductor, I am taking that. So this is one circular conductor. So the radius of the circular conductor, for example, let me take that is a capital R, I am taking that. And in this circular coil, some amount of the current, that current is capital I is flowing. So from the center, if you draw a one line perpendicular to the plane of the coil, so this is called as the axis from the center O to the any point P. So now the distance I am taking that x. X is the distance of a point P on the axis of the circular conductor. Now at this point we want to find out magnetic field. So what is the magnitude of the magnetic field? That magnitude of the magnetic field is given by B is equal to mu naught by 4 pi into 2 pi. So I r square by x square plus r square whole power 3 by 2. So this is the expression for magnitude of the magnetic field produced by a current flowing in a circular wire of radius r at a distance x on its axis from the center. So B is equal to mu naught by 4 pi. So 2 pi I r square by x square plus r square whole power 3 by 2. So here the mu naught by 4 pi value how much? Mu naught by 4 pi is equal to 1 into 10 power minus 7, so Henry per meter, right? No, therefore now this is the mu naught by 4 pi value, 1 into 10 power minus 7 Henry per meter, that's value. While solving the problem we can substitute this one. But here, so if the point P is at the center, generally if the point, this point if you take at the center, now what you can get now? So here, at center if you want magnetic field, so x is equal to 0, you can substitute, because when this point P is taken to the center of the coil, therefore x becomes 0. Therefore when x is equal to 0, you substitute there, so you can get the answer. At the center I am representing the B naught. B naught is equal to mu naught by 4 pi, so 2 pi, so I by x cube, right? No, this is the magnetic field, x square you will get, that is the mu naught by 4 pi 2 pi I by x square, because once you see therefore when you this is the r square you can get, that r you can get. Therefore now B is equal to, once you substitute there, so x is equal to 0. If you substitute x is equal to 0, here r square cancel, r cube is there, r square r, therefore now what? So B naught is equal to mu naught by 4 pi 2 pi I by r, where r is the radius, I is the current. Therefore here we can say two important points are magnetic field due to a current, circular current is directly proportional to I, and magnetic field due to circular current or circular wire is inversely proportional to radius, right? No, so B is inversely proportional to radius and B is inversely directly proportional to current passes to the conductor. This is I am talking about magnetic field at the center, that is equal to what? Mu naught by 4 pi 2 pi I by r. So in the problems due to the circular conductor, so 70% of the problems are based on the magnetic field at the center only. B is equal to mu naught by 4 pi 2 pi I by r. And sometimes here I have taken only single turn of the coil, means here I have taken only one turn. Sometimes they may give the 2 turns and sometimes they may give the 3 tons, sometimes give the 4 tons, 5 tons like that. So if there are the n tons, the magnetic field due to the magnetic field, so due to the circular wire, so at any point on axis for n tons is given by Bn is equal to n into B. That's it. Therefore, this value just you multiply with n, so you can get so for n number of the tons, Bn is equal to n into B, and if you substitute there, you can get the answer. That is what? That is equal to mu naught by 4 pi, so 2 pi n I r square by so x square plus r square whole power 3 by 2 is the answer. And if you take at the center, just you multiply with the n, so you can get the answer what? Now the magnetic field due to so n number of the circular turns is given by so mu naught by 4 pi into 2 pi n into I by r. Therefore, these expressions are only for the singleton, but instead of the singleton, if they will give the multiple number of the turns in the question, therefore now just the given expression you have to multiply n, that's it, okay. Therefore, at the center what mu naught by 4 pi 2 pi n I by r, that is the magnetic field due to point at the center for n number of the turns. N number of the turns. Therefore, now here, so this is the magnetic field due to circular conductor. Next, one more point is there. For example, if the point P is very far away, if the point P is very far away, means what? Far away point. Now, next point for far away point. Far away means what? Far away means so x value greater than r. When x value greater than r, therefore now you can say x square plus r square, so nearly equal to what? That is equal to what? That is equal to x square only. Why? Because you see x value is very greater. Therefore, whenever you compare the x value with r value is very small from the denominator only, not from the numerator. From the denominator, so we can eliminate what? This r value. Therefore, now r square is equal to 0. Therefore, x square. Therefore, if you substitute there and solve it, we can get the answer. So B is equal to mu naught by 4 pi, so into what? That is equal to so 2 pi I by so that is the so here what we get x square means what? 2 pi, so I r square by so x cube. You can get the answer after simplification. So nothing here r square is equal to 0, and this part becomes 0 means what? Here one square cancel, here x cube is there, remaining numerator is as it is 2 pi I r square by x cube. Therefore, this is the magnetic field. Due to a circular curve, when the point P is very far away from the center, or the distance of the point from the center is much greater than the radius. For example, if you take x is equal to 1 meter and the radius is equal to 1 centimeter, compare with 1 meter, 1 centimeter is negligible. Therefore, now you can say B is equal to mu naught by 4 pi 2 pi I r square by x cube. This is the second point, third point for the magnetic field due to circular curve. And here one more important point. So if this equation, if you compare with and we know that if you take a bar magnet, for example, I am taking that this is one bar magnet, and so on the bar magnet, from the center, if you take at a distance x, so at this point the magnetic field is given by B is equal to mu naught by 4 pi, so 2m by x cube. This capital M is called magnetic moment of the bar magnet. Therefore, this is the magnetic field due to bar magnet on its axis at a distance x from the center of the magnet, and capital M is called as the magnetic moment. That is different, and this is different. That is due to bar magnet, this is due to a circular conductor. And if you compare both of them, this point P also we have taken on the axial line, nothing but axis, but so in that case what? Mu naught by 4 pi 2m by x cube. If you compare with in place of the m, who is there, so in place of the m, therefore now here one more important point is that magnetic moment So any coil, any current coil or any current conductor is given by what? Just you compare them. In place of the mu naught by 4 pi, here mu naught by 4 pi is there. In place of the x cube and x cube is there, and in place of the 2 is there, but in place of the m is there, pi I r square is there. Therefore, now I am taking that. So m is equal to pi r square into I m, right or not? But so what is the pi r square? Pi r square indicating the area of this circle. Therefore, now also you can say A into capital I, where A is the area of the given coil and I is the current passes through the conductor. And what is this A area? I is what current, but here for how many turns I have taken? Only for single turn. But if you take multiple number of the turns, magnetic moment is given by, that is equal to N into I into A. Therefore, this is the formula for the magnetic moment due to A. So, any coil. Here, this formula actually we have derived from the circular conductor, but this is not only applicable for the circular coil. You can use for the square coil, you can use for the rectangular coil, you can use any loop of any shape. The only thing is that N is number of turns, I is the current, A is the area of the loop or that coil. Right now, this formula actually we have derived from the circular conductor or circular coil. But so here what? Here this is not only applicable for the circular coil, it is applicable for all types of the coil. For the square coil means what? Square closed loop. For the rectangular loop, and for any other shape you can use, no problem. M is equal to N into I into A, where N is the number of turns, I is the current, A is the area of that particular given coil. Therefore, these are the expressions for the circular conductor. And one more important point is that sometimes they will give like that, the ratio between magnetic field at any point on the axis, and magnetic field at the center. Now the ratio between magnetic field at the center already I am representing with B naught, magnetic field at any point on the axis I am taking that B, and after simplification you will get that 1 plus x square by r square whole power 3 by 2, and this is a very very important expression. Many times they are asking the question from this relation also. Means what? For example, they will give the radius and they will give the distance x, after x is equal to 2, 3, 4. So what is the magnetic field? They will give like that. So be careful. B naught by B is equal to 1 plus x square by r square whole power 3 by 2. That is the relation between, or the ratio between, magnetic field at the center to the point, magnetic field at any point on the axis of the circular wire. B naught by B is equal to 1 plus x square by r square whole power 3 by 2. And so here one more important point, last one in this discussion of concept. So that is, for example, this is a single conductor we have taken, single circular coil we have taken, but sometimes they will take like that. So two coils like this. Right now what? This is the first coil and this is the second coil, and the first coil plane it is like this, and the second coil plane is like this. The angle between them, for example, if you take the theta, if you take the angle between them is theta, therefore now what? This is so now this is the current I1 I am taking that, this is the current I2 I am taking that. Now the magnetic field, the resultant magnetic field, because magnetic field is not a scalar, magnetic field is a vector, therefore so this current I1 produces a magnetic field B1 in the first circular loop, and this current I2 produces a magnetic field B2 in the second circular coil. Now the resultant magnetic field is given by B is equal to under root of, so what I am taking that, so B1 square plus B2 square plus 2B1 B2 cos theta. So this is the resultant magnetic field when two circular coils are so concentrated at a single point, when theta is the angle between them. So if both are in the same plane, if both are in the same plane means what? So currents are in the same direction. For example, like this I am taking that. This is the first circular wire and this is second circular wire. In this current is I1, in this current is I2. Currents are traveling in the same direction, and so what? That is both are in the same plane. In such case, theta is equal to 0, cos 0 is equal to 1. After simplification, you can get that the resultant magnetic field is equal to B1 plus B2 only. And if theta is equal to 90 means what? So one coil is vertical, one coil is horizontal. Now the angle between between them is 90. Cos 90 is equal to 0. This total part becomes 0. Remaining is only under root of b1 square plus b2 square. And if both are in opposite direction, means what? Both are in the same plane, but I1, I2 both are in the same opposite direction, then the magnetic field is b1 separation b2 amma. What is the meaning of separation? So if b1 is greater than b2, we have to take b1 minus b2. If b2 is greater than b1, we have to take b2 minus b1. Therefore, this is a small introduction about it. And sometimes, last one, so for any arc, for any circular arc, so field at the center, magnetic field at the center they will ask. Okay, now means what? For example, now I am checking that this is one circular coil, but I am not taking the total circular coil. I am taking some arc like this, means this arc makes some angle, right? Now this arc, therefore in this some amount of the current is coming, that current is I. Now at the center, if it is a full circle, what is the magnetic field at the center? Magnetic field at the center is given by mu naught by 4 pi, so 2 pi I by n into I by r. Of course, you can take for the single turn better. Therefore, b naught is equal to mu naught by 4 pi 2 pi I by r. Correct? When if the circle is full, but here the wire starts here and ending here, so this is not there, therefore this is missing. At this case, they will ask what is the magnetic field at the center. So tell me, Amma, here for the full circle, what we have taken? For the full circle, we have taken angle 2 pi. So when for the full circle, if you take the angle 2 pi, and here, so what? This angle, how much? This angle, if you take the theta, then the magnetic field due to any arc at the center is given by b theta is equal to mu naught by, so 4 pi, that is equal to theta I by r. Just nothing. In place of the 2 pi, you substitute the theta, that's it, okay. But one thing is, here the theta must be in radians. Theta must be in radians. We should not keep the theta in degrees, because whenever theta is single, means what? If it is sin theta, cos theta, tan theta, yes, you can substitute theta is in degrees or radians, that is not a matter. But when the theta is out of any trigonometric function, so here what is that? So besides of the theta, sin, cos not there. Therefore now what? Only theta is present. So in any expression, if the theta is a single function, therefore you have to take the theta must and should be radians. Therefore now what? So this is the last formula for that one. Okay. Now let us discuss so some problems related to circular coil. So now, first of all, I am taking that. So here what I am taking that, this is and one more important point is direction. Direction I will say. Now first of all, what I am taking that, so this is the radius I am taking that is the r. The current passes in this one, for example, I am taking that. Now another circular wire I am taking that, this is the another circular wire. So for this one, the radius, for example, I am taking that 2r, and so now the current I am taking that, in this case also the current is I only. So in this the current is I, in this also current is I, and in this the radius is 2r, in this the radius is r. Therefore now what? So at the center, what is the net magnetic field I am asking? Just now I have given when two coils are in the same plane with the directions of current in the same direction, therefore what is the magnetic field? B is equal to B1 plus B2, you can take it. But so what is the direction? So there are the two conditions are there for the direction. For example, now if you take the right hand curl rule, right hand thumb rule or right hand curl rule, for example, if you take this curl of the finger, means what? If the current is traveling, so in the direction of the curl, then the thumb opened out gives what? Direction of magnetic field. Okay. See, for example, now what? Current is traveling. There are the two symbols to represent the current. For example, you see here I am taking what? This is one circular coil. Current is traveling like this. That current is I. Now at the center, I want the magnetic field magnitude. Already you know that. At the center, the magnitude of the magnetic field how much? Mu naught by 4 pi 2 pi I by r for the full circle. Now I want the direction. So keep the curl of the fingers. This 4 combination fingers is called as the curl of the fingers. So keep the curl of the fingers in the direction of the current. Yes. So I am keeping the curl of the fingers in the direction of the current. Now thumb opened out. When you open the thumb is out of the plane of the board. Correct? So the thumb is out of the plane of the board. Therefore now in this case the magnetic field symbol is so like this you can represent just one dot you take it. This is the so what direction of magnetic field, that is means what? So out of the plane of the paper, right? Now if the current is this is what so current is anti-clockwise. For example, if the current is in a clockwise direction, for example, now I am taking that this is the direction of the current. Now in this also same point you take it. Now what if you take like this, therefore now current is traveling like this, therefore current is in the direction of the curl of the finger. Now what? This is the thumb, therefore thumb is into the plane of the paper. Therefore now what? So these are the directions. So the direction of magnetic field due to any circular wire can be found by using the so right hand thumb rule. The curl of the fingers gives the direction of the current. The thumb direction at that point gives the so direction of magnetic field at that point only. Now in this case what I want, what is the net magnetic field I want? Net magnetic field value is equal to how much? Now first of all let's go for the first conductor at the center. Now at the center magnetic field due to the first conductor formula mu naught by 4 pi so 2 pi I by r I am taking that. This is the magnetic field due to the first conductor. What is the direction? Now if you take the direction like this, therefore now what? Here I am taking that. So this is the so out of the plane means what? Into out of the plane of the paper. Therefore now you can take like this amount. Next magnetic field due to the second conductor mu naught by 4 pi so 2 pi in place of the I we can take what? That is a 2I by what? R in place of the R we can take what? That is the so now that is I only na? Yes, this is the I, but in place of the radius that is what? Double of the first one. Therefore now 2R I have taken. Currents are the same, beta numerator is the same and this is the 2R. Therefore now what? This is also direction same because now you see now in this direction current is traveling, the thumb is outside, therefore now both are in the same direction. When both are in the same direction we have to add them. Therefore now the net magnetic field is given by B is equal to B1 plus B2. B is equal to B1 plus B2. Now, so B is equal to B1 plus B2. What will you get, Nana? Now you can get here that is equal to, so here, so B1 is equal to how much now? Mu naught by 4 pi. Here what is the common here? So 2 pi I by r is common. Therefore here only 2 is there. Therefore now what? So mu naught by 4 pi 2 pi I bar r is the common 1 plus 1 by 2. Therefore because here this becomes, if you take the common from this so 1 by it is a 1, it is a 1 by 2 that is equal to 3 by 2 you can get. Therefore now mu naught by 4 pi 6 pi because 2 into 1 2 plus 1 is equal to 3, 3 2 is a 6 pi I by so 2r you can get. Therefore now so from this so 2 1s are 2 3s are finally what? That is equal to mu naught by 4 pi so 3 pi I by r. This is the net magnetic field. That net magnetic field is also out of the plane of the board. Therefore this is the answer for that. Okay na? Now so let's go. Now in this case only, for example here this is the I, this is the I, this is the radius r1 this is the radius r2. But now the condition in the second case, in the second outer ring the current is so in traveling in reverse direction. Currents in the first conductor is I traveling in the so anti-clockwise. Current in the outer circular coil is so clockwise direction. Currents are the same but radius are the different. Now they will ask what is the so net magnetic field in this direction. So otherwise you can take better. So what 2R only let us take because for then after I will take. So what is the meaning of it? This is the R and this is the 2R. Here also same to same expression. There is no change in the expression, but this is correct. But this is what? This is the into the plane of the paper. because now what, the current is traveling, so in this direction, that is into the plane of the paper. Therefore now what, when both are in opposite direction, so which one is the bigger amma? So 2 pi I by r is bigger than the, so 2 pi I by 2r, because here in the denominator 2 is extra. Therefore now we can confirm what, b1 greater than b2. Therefore when both are in the opposite direction, we have to subtract them, and to subtract either b1 greater or b2 greater, first of all we have to check it. Therefore here b1 value greater than b2 value. Therefore in that case, now the net magnetic field is given by is equal to b1 minus b2. Just now we have discussed for the opposite case, either b1 separation b2 or b2 separation b1. Therefore b1 minus b2, that is equal to mu naught by 4 pi 2 pi I by r is the common. Here 1 minus r will get, so 1 minus 2 will get. So 1 minus 2 means 1 by 2. Now here you are getting that net magnetic field after simplification, mu naught by 4 pi is equal to pi I by r, because 1 minus 1 by 2 becomes 1 by 2, 1 by 2, 2 get cancelled, pi I. Then they will ask what is the direction of this one? What is the direction of this net magnetic field, they will ask beta. So now what here, between these two, which one is the greater? Which one is the greater? So outer means what, the magnetic field B1 is greater. Therefore if the two magnetic fields or two vectors are so opposite direction, in that which one is the bigger magnitude, the direction of resultant also in the same direction of a bigger one. Therefore now what, the net magnetic field is also acting out of the plane of the board in this case. Therefore this is the second one. Now here one more in the same question, one more is if this is the radius r1, this is the radius r2, this is the radius r2, I am taking that. If net magnetic field at the center is equal to 0, question enama, if net magnetic field at the center is equal to 0, then they will ask what is the ratio between r1 and r2 beta. So what is the ratio between r1 and r2, they will ask that. Okay na? Otherwise if they take the current is I, then you can take this current is how much, 2I. Right? Now we have to find out what is the ratio of radius so that the net magnetic field is equal to 0. Therefore in such case what we can take now again, so the current, the magnetic field due to the first one, what I am taking that, so B1 is equal to, so mu naught by 4 pi, that is that 2 pi I by, so R1 I am taking that. So this is what, this is out of the plane of the paper, and the second magnetic field B2 is equal to mu naught by 4 pi, so 2 pi, so that is how much, that is a 2I I am taking that by what, that is the R2. Because the current in the outer circular ring is so 2I, therefore now in place of the I am replacing 2I, therefore now this is what, into the plane of the paper. Again what, both are in the opposite direction. When both are in the opposite direction, so I am taking what, net magnetic field, so B1 minus B2 I am taking that. I don't know B1 greater or B2 greater or, because so here what I am taking that, so B1 minus B2 I have taken. Therefore in this case they said what, to get the net magnetic field the center is equal to 0, that means what, B1 minus B2. Therefore now you can say what, B1 minus B2 is equal to 0, that means what, so B1 is equal to B2. When B1 is equal to B2, write the values, mu naught by 4 pi, so 2 pi I by R1 is equal to mu naught by 4 pi 2 pi into 2I by, so R2. Now here mu naught by 4 pi, mu naught by 4 pi cancel, and 2 pi I, so 2 pi I cancel. Therefore what is the remaining? Now 1 by R1 is equal to what? That is equal to 2 by R2. Therefore R2 by R1 is equal to estimado, that is equal to 2 by 1. Therefore 2 is to 1. Therefore means what? So to get the net magnetic at the center is equal to 0, the radius also should be how much? The radius also should be equal to double of the radius of the first one. Then so the net magnetic at the center is equal to 0. And one more, to get the net magnetic field is equal to 0, compulsory the two currents must and should be opposite in direction. When two currents are in opposite direction, then and only then the magnetic fields are in opposite direction. So then and only then there is a chance to get a magnetic field at the center is equal to 0. Otherwise if currents are in the same direction, magnetic fields are in the same direction. Now you can take B1 plus B2. Therefore, in that case, both will be added, not subtracted. Therefore, when both will be added vectorially, the net resultant vector is not becomes 0. So be careful that one. This is so one model. Next. Now, here one more question is, this is one coil, this is one coil. Now, the radius I am taking that for example R. Now, at a distance, now at the center the magnetic field is given by B naught. At the center the magnetic field they will give that B naught. So, they will ask that at a distance of the 3R, what is the magnetic field? At this point B is equal to how much? So, radius of the circular coil R I have given. Now, at a distance 3R from the center, what is the magnitude of the magnetic field? For that condition, we have given one relation. What is that? Now, that relation is given by, so B is equal to formula what? So, B naught by B is equal to 1 plus x square by R square whole power 3 by 2 we have given. Once you check it, I have given this relation. So, at the center of the given circular coil of current I, the magnetic field is B naught at the center. Now, at a distance x is equal to 3R, now they have given, so what is the magnitude of the magnetic field? So, use this formula, B naught by B is equal to 1 plus x square by R square whole power 3 by 2. Now, here B naught is B naught only, B only, 1 plus x is equal to how much now? That is equal to 3R whole square, nothing but what? 9R square by, so R square, this R square cancel, so whole power 3 by 2. So 9 plus 1, 10, so what? 10, so 3 by 2. Therefore, now here B naught by, so B is equal to, so 10 power 3 by 2, and this one what you want, so B is equal to B naught by 10 power 3 by 2, you can get it. Okay, na? B is equal to what? B naught by, so 10 power 3 by 2. So, therefore, this is the answer like this. Next, one more. Here, for a longer points, for a very far points, at a distance, for very far points, for far points, at a distance x is equal to 2 meters, the magnetic field is given by, so B1 is equal to 2 Tesla or 4 Tesla, let us take that. Then at a distance x is equal to, so 8 meters, so what is the, so magnetic field how much? That is the magnetic field. Far points. For far points means what condition I have given? For x greater than R. What is the magnetic field? Now the magnetic field is given by, so B is equal to mu naught by 4 pi, so what? 2 pi, so I R square by x cube. Here I am not talking about the current, I am not talking about the radius, because the current in the circle is circular wire is constant, the radius is also constant. But what is the difference here? Only, so x value is different. Therefore, now you can say, so what? B is inversely proportional to x cube, and from this you can say what? That is B2 by B1 is equal to x1 by x2 whole power 3. So, whole power 3, because you see B2 by B1 is equal to x1 by x2, that is what? So, inversely proportional. When you take the inversely proportional, now what? B2 by, so B1 value how much? 4 is equal to x1 value, x is equal to 2, and x2 is equal to how much now? x2 is equal to, that is equal to 8. So, whole power 3, I am taking that. Therefore, now, so you can get what? B2 by, so 4 is equal to, this is a 1 by 4 whole power 3, because see this one 2 ones are 2 4s are, so 4 3. Therefore, now, so B2 value how much? B2 value is equal to 4 by 4 cube. That is nothing but, so what? That is B2 is equal to, so 1 by 16 Tesla. Because 4 by 4 square will get, the 1 by 4 square you will get, therefore that is a 16. So 1 by 16 Tesla, that is the magnetic field at a distance what? That is equal to 8 meter. So this is one of the models. Next, Now, so in one coil, in one circular coil, the number of turns N1 is equal to 100 and the current in the cycle is equal to, for example, 2 ampere. The radius of the coil is equal to, for example, I am taking that it is a, so that is a 10 centimeter. 10 centimeter. So this is for one coil. So now for another coil, the number of turns I am taking, that is N2 is equal to, that is equal to 200 and current I2 is equal to 1 ampere and the radius R2 is equal to I have given what, 5 centimeter. Now what is the ratio of magnetic field at the center? What is the ratio of magnetic fields at the center of the two coils? For the first coil, the information given, and for the second coil, this is the information. Now the ratio of magnetic field, so E is given by B1 by B2 is equal to. So before going to that, so magnetic field at the center is given B0 is equal to mu naught by 4 pi, so 2 pi I by R we have given, and if it is the n terms, then we can take what, n is the multiply. Therefore here mu naught by 4 pi 2 pi all constant. Therefore what, so by taking that only you can take that what I1 n1 by r1 into, it goes upside ulta because b2 is in the denominator, therefore r2 by I2 into N2, this is the ratio. Therefore, if you substitute there, you can get the answers. So, I1 is equal to how much now? It is equal to 2 into N1 is equal to how much now? 100, and the radius of the first one how much? That is a 10, not need to convert into meters because centimeter cancel in the ratio. So, into R2, so R2 is equal to how much I have taken 5, I2 is equal to how much? That is 1 and N2 is equal to, that is 200. Therefore now what? So this is the 200, this is the 200 cancel. Therefore now what? That is the 1 by 2, 5 1s are, 5 2s are. Therefore B1 by B2 is equal to 1 by 2. That you can write, so B1 is to B2 is equal to 1 is to 2. That's it. So this is the small model problem for the circular conductor. Let's go for the straight conductor. Magnetic field due to straight conductors. Right. So now next point is the magnetic field due to a straight conductor. Let me take, this is one straight conductor, and the current passes in this conductor. For example, I am taking that, and so here I want at this point the magnetic field I want. Now the perpendicular distance of the point, so from the circle, from the straight wire I am taking that R. Now, so the first end means the top end makes an angle, that angle for example alpha I am taking that, the lower end makes an angle theta with a line, that angle I am taking that, is so beta I am taking that. So R is the perpendicular distance of the point P from the wire, and at the point B we have to find out the magnetic field. Now for this case, now so if you take this point is x, this point is the x, and this point is the y, and this point is the x. Therefore now the magnetic field at any point P is given by B is equal to mu naught by 4 pi I by R into sine alpha plus sine beta. This is the formula, general formula for any point. So magnetic field due to a straight conductor wire carrying a current I as shown in the figure. Now in this case some special points are there. So what is that? If the point P is exactly bisector, means what? For example, I am taking that this is the point is exactly in the middle. If the point is exactly in the middle, means what? This is, if you take the total length of the wire is L nana. If you take the total length of the wire, now this point is exactly bisecting this angle. Therefore now what? So if it is exactly off, this becomes alpha, and this also becomes what, alpha. Therefore if the point P is exactly in the middle of the wire, therefore now you can say what? So here alpha and beta both are the same, sin alpha plus sin alpha. Therefore now for that case, now the magnetic field is given by mu naught by 4 pi into what? I by R into 2 sin alpha. Yakandre sin alpha plus sin alpha, because when the point P is exactly in the middle, therefore alpha and beta both are equal. When both are equal, in place of the beta you can take what, sin alpha. Sin alpha plus sin alpha is equal to 2 sin alpha, right? Now, so here this is the first point. Second point is that, for example, now, so if this point is exactly opposite to one end, for example, this wire I am taking that. Now, this point P is exactly at one end I am taking. This is the point P. This is the distance R. Now, so what? This is the alpha. This is the alpha. In this case, what? Beta is equal to 0. Because the bottom end is so equivalent to the point P. Therefore, now beta is equal to 0. Beta is not there. So, what is the angle beta? Angle made by the second end with respect to the point. Therefore, here this point P is exactly opposite to the second end. Therefore, beta is equal to 0. When it is there, therefore, in that case, B is equal to mu naught by 4 pi into I by R. So, sin alpha only. Sin beta is equal to 0, sin 0, 0. Therefore, once again you say what? It is a sin alpha only. Therefore, in this case, so this is one is a point. Next, for example, if the wire is infinite wire. So, what is the meaning of the infinite? Means what? For example, now here I am taking that. So, this end where it is present we don't know. This end where it is present we don't know. This is plus infinity. This is minus infinity. Means what? If the wire is very, very, very longer, actually we can't take infinite wires in general. So, what is the meaning of infinite wire? So, compare with the distance small r. Compare with the distance r. So, what? The length of the wire is much greater. In that case, we can consider, so this wire is the longer wire or infinite wire. For the infinite wire, if you take point anything, right now I am taking what? From the wire at point P at a distance r. Now, I want the magnetic field. Therefore, now what? Where is this point? So, actually, if the end is closes here, therefore we can take like this. Therefore, idu eno angle alpha. But this end is going upside, therefore now we have to rise like this, rise like this, rise like this, rise like this, rise like this. When you rise like this, now at a particular point it becomes what, alpha is equal to 90. Because you see, first of all it is closing here. Now this is the angle. Now you see this end is going, Therefore now what? Our hand also rising like this. Now if this end is going to the infinity, our hand is going straight. Therefore now what? So here this angle so becomes alpha is equal to 90 degrees and this angle beta is equal to also 90 degrees. Alpha and beta both are 90 degrees and sin 90 plus sin 90. Therefore sin 91 and sin 91, 1 plus 1 is equal to 2. Therefore, in such case means what? For infinite wire, so the magnetic field is given by B is equal to mu naught by 4 pi, so 2I by R. Therefore, this is the very important formula. So, like in case of the circular conductor, the formula for magnetic field at the center is most important, and in this case the magnetic field due to infinite wire is very important. B is equal to mu naught by 4 pi 2 I by R, and there what we got? B naught is equal to mu naught by 4 pi 2 pi come extra 2 pi I by R there. So here R is the distance, there capital R is the radius. That is the only difference. Next, for example, if the wire is semi-infinite, what is the meaning of semi-infinite? One end is at infinity. One end is at infinity, but another end is close to point of measurement. Therefore, now here what? So, this is the current I. So, one end is at infinity means what? This is alpha is equal to 90. There is no doubt, but here beta is equal to what? 0. This is called what? A semi-infinite wire. Means only one end is at infinity, but other end is in front of. So as therefore exactly the point P is opposite to one end. In such case, so beta is equal to 0, but alpha is equal to 90. Once again, if you substitute there, sin 90 is equal to 1. 1 plus sin 0, 0. 1 plus 0 is 1. Therefore now what here I am taking that? For semi-infinite. For semi-infinite, so what? Alpha is equal to 90 and beta is equal to 0. Here what is that? Both are. So alpha and beta both are 90 degrees. In that case what? The magnetic field is given by B is equal to mu naught by 4 pi, just I by R only. Here 2I by R will come. Here I by R will come. Therefore this is the magnetic field due to what? That is the straight wire. So here this is the general point, the general formula. From this only, if the point is exactly in the middle, you will get that. If the point is exactly opposite, you will get like this, right? And here one important fact for these two cases is for the first 2 points, regarding these 2 points, sometimes they will give like this. Means what? So exactly here they won't give the alpha beta. Means the total length they will give like this. This is the point exactly midpoint. Therefore it becomes what? L by 2. This also becomes what? L by 2. Therefore here I want alpha. They will give the R value. So means what? Sometimes to confuse you, the length of the wire they will give and the point is exactly in the middle. Means what? Alpha they won't give. Then how to find out the alpha? So from this triangle, you see, this is the L by 2. This distance how much? This distance R. This is the alpha. This is the L by 2. I am taking that. Therefore sin alpha formula what? Sin alpha is equal to opposite side. Another L by 2 by. So hypotenuse. What is the hypotenuse? Under root of L by 2 whole square plus R square. So L by 2 or L square plus R square. Therefore by using that formula you find out the sin alpha you substitute there, you can get the answer. If they will give the direct angles, no problem. If they will give the direct angles, no problem. But if they will give, so only that lengths and distances, so you take the sin alpha is equal to L by 2 by, so under root of L by 2 whole square plus R square. Okay. So therefore this is the information related to the straight conductor, and the most important formulas, these two. So therefore these two are very, very important. What is that? First one is magnetic field due to infinite wire and magnetic field due to semi-infinite wire. Okay, na? These are the very, very important points related to the straight wire. And what is the direction of magnetic field due to produced by the straight conductor? Now, magnetic field due to straight conductor already we have discussed in the form of magnitude only. But what about the direction? For example, now I am taking that this is the magnetic field, this is the current passing through the wire, and so at a distance R I want magnetic field. Very simple. Now once again you have to go for the right hand thumb rule. So in case of the circular conductor, so what we have thought, so the curl of the fingers gives the direction of the current. Now the thumb opened out. When the thumb is opened out, the direction of the thumb gives the direction of magnetic field for circular conductor. Now in case of the straight conductor, it is just reverse. Means what? For example, if you take, so the thumb gives what? Direction of the current. Now the curl of the fingers gives what? So direction of the magnetic field. For example, now your current is passing like this. So hold your right hand thumb in the direction of the current. Yes, so I am holding the direction of the thumb in the direction of the current only. Now, so this distance R is there now. This distance R is nothing but the palm of the right hand. Therefore, this is the palm of the right hand. Therefore, at what point you want? At this point, I want a magnetic field direction. At that point, you curl the fingers. When you curl the fingers, it is entering into. Therefore, now what? At this point, the magnetic field direction is into the plane of the paper. Now, when you take the point on the left side, now once again you have to represent someone. So what? So direction of the thumb is upside. Yes, you are keeping. Therefore now what? So at this point, so I want the direction of magnetic field. See, thumb is in the direction of the current and the palm is, this palm, white part is in the direction of the distance. Now, so here if you open the curl, now the curl is showing towards you. Means what? Out of the plane of the, so both, therefore at this point the magnetic field direction is what? Out. That is the into. This is into the, at this point, so into the plane of the paper, at this point out of the plane of the paper. Now, some problems related to this straight conductor. Now I am giving that this is a one infinite straight conductor. and the current I am taking that for example, so that is I1 is equal to 2 amperes, and here one more infinite wire I am taking that, both are infinite wires, and the separation between them for example I am taking the 20 centimeter now. So I want, and the current I2 is equal to that I am giving that is equal to for example 4 ampere I am taking that. So at the center, what is the net magnetic field? I am asking that. So what is that between these two? At the center exactly. Center exactly means what? At the midpoint of the line joining this, I want what is the net magnetic field? Means at this point, first conductor produces the magnetic field. At the same point, second conductor also produces the magnetic field. Okay. First of all, let us calculate the magnitude. So they mentioned what both are the infinite. So for the first one, R1 is equal to how much now? First one, R1 is equal to 10 centimeter. For the second one also, distance how much? Because they say that distance between the two wires is equal to 20 centimeter. The center means R2 is equal to also 10 centimeter we have given. So both are the same. Therefore now first of all, here magnetic field due to the first conductor I am going that. So B1 is equal to mu naught by 4 pi, formula what that is equal to, so 2I1 by R1. Correct? Because it is infinite wire now, mu naught by 4 pi 2 I1 by R. So that is equal to mu naught by 4 pi value how much? Mu naught by 4 pi value what I told you, that is a 10 power minus 7 into, so 2 into, yes, I value how much now? I1 1 is, that is a 2 ampere, but distance how much? That is a R1 is equal to 10 centimeter. Therefore that you can say 10 into 10 power minus 2. Therefore finally you can get what? B1 is equal to 2 to the 4 into, this is a 10 into 10 power minus 2, 10 power minus 1, 10 power minus 1 goes upside, it is a 10 power minus 6 Tesla. Tesla is the SI unit of the magnetic field. And so the magnetic field value due to the first wire is over. Then what is this direction? Now at this point what? So the thumb is, so current is going upside, thumb I am keeping at this point. So curl the fingers, the fingers entering into, therefore this is into the plane of the board or into the plane of the paper. Next, magnetic field due to second wire. So B2 is equal to what now? Mu naught by 4 pi, that is equal to 2I2 by R2. 2I2 by R2. That is equal to given by mu naught by 4 pi. So 2 into, so I2. I2 value, I2 is equal to how much now? That is equal to 4 by R2 value how much now? 10 into 10 power minus 2. If you substitute the values, you can get the answer. That's what? So mu naught by 4 pi directly substitute. So that is a 10 power minus 7. Therefore B2 is equal to, so what you can get? So 2 4s are, again you are getting what? 8 into 10 power minus 6 Tesla. And so what is the direction? So what? Here the current is going upside. If you represent like this, that's wrong. Why? Because thumb is okay, but this point is not on the right side, point is on the left side. That's why we have to represent like this. Therefore now what? This is the wire. Now what? This is the thumb. Therefore now what? This is the direction. Now what? You can represent like this. Therefore now here this is out of the plane of the paper. That is what? Out of the plane of the paper means towards you. Therefore here see, this is into, this is out. So now what? Both are in the opposite direction. Just now we have discussed when magnetic fields are in opposite direction, either B1 minus B2 or B2 minus B1 we have to take. But here what? So B1 is into the plane of the paper with a smaller magnitude. So B2 is the out of the plane of the paper with a larger magnitude. Therefore both are in opposite direction. Now the net magnetic field is given by, so B2 minus B1, that is equal to what? 8 into 10 power minus 6 minus 4 into 10 power minus 6, finally 4 into 10 power minus 6 Tesla, and the direction is what? Out of the plane of the paper. Why? Because the dominant one, so which has the more magnitude, that direction is followed by the, so resultant vector. Therefore 4 into 10 power minus 6 Tesla. Right. Next. So in the same question, for example, now if the same question, here what I am taking, that I1 is equal to, that is a 2 ampere, and I2 is equal to 4 ampere I am taking that. 4 amperes I am taking, and that distance is the same, that is equal to 20 centimeter I am giving that. Now again at the center, what is the net magnetic field I am asking. At the center, what is the net magnetic field, how much? That is the case for that. Then how to find out? Same, this one magnitude is the same and direction also out into the plane of the board, and this is what here the current is reversed. Current is reversed means what? Now, so we have to come like this. Therefore, now we have to come like this. Therefore, now what? This is the thumb is down. Therefore, we have to keep thumb is yes, correct. Now, this is the distance. Now, again, it is into. Therefore, magnetic field due to first conductor is into. Magnetic field due to second conductor also into. Therefore, both are into direction. Means what? Both are into the plane of the paper. Therefore, now both are in the same direction. Just in the previous data, just we can add up them. When you add up, so 4 into 10 power minus 6 Tesla plus 8 into 10 power minus 6, so 8 plus 4 is equal to 12 into 10 power minus 6 Tesla is the correct answer for that. Therefore, check the directions of the current properly. If both are in the same direction, so at the center the magnetic field will be subtracted, but if both are in opposite direction, in between the conductors or current wires, the magnetic field will be added. Therefore, just to follow the directions properly, so you can get the answer very easily. Next, for example, some combination of the circular conductor and the straight conductor problems. Otherwise, before that, so let us discuss one problem here. So now what I am taking that? This is the infinite wire, and so what? This is also infinite. Here some current is coming like this. That current is I. This current is I, and so this is one circular. Let us draw the diagram. This is the infinite, and the current is I. The current is I. The current is I, and the current is I, like that I am taking that. Therefore, this is one circular patch. Therefore, now the radius I am taking that R. Now what? This is also radius I am taking that. Now at the center, what is the net magnetic field? I am asking that. This is the combination of so what? So straight and circular wires. Now tell me first of all, how many straight wires are there? Here there are the 2 straight wires are there. First one, this is the straight wire. But you know, this point is exactly opposite. One point, whenever a point is present on the axis of the straight conductor, if you take a point is here, now the magnetic field at any point along the axis of straight conductor is always equal to 0. Magnetic field due to a point which is present along the axis of straight conductor always equal to 0. Therefore, now what I want at this point, I want what is the net magnetic field. Means what? Magnetic field produced by the first conductor, magnetic field due to the circular conductor, magnetic field due to the straight conductor. I want the total, so magnetic field I want. But so here I am taking that. This is the first conductor, this is the second conductor, and this is the third conductor. Means what? So here to here, this is the circular arc, semicircular wire. There is a semicircular wire. Therefore, theta is equal to 180. 180 is equal to pi. Therefore, magnetic field due to first one, I am taking what? So B1 is equal to 0 because this point is exactly along the axis of the first conductor. Next, so what? Magnetic field due to the second wire is what? That is equal to B2 formula what? Mu naught by 4 pi. So theta I by R formula. But theta value is 2. Now the theta is equal to pi. Therefore, that is equal to mu naught by 4 pi. So pi I by R. That's it. And what is the direction that is this is a ladder? Otherwise, now only you can decide. What? So this is a conductor. This is circular conductor. Therefore, thumb is outside. I told the direction of the current you have to keep in the direction of the curl for the circular wire. Therefore, it is a current direction. Thumb is outside. Therefore, now what? This is the outside. I am taking it. Now, so last one. So magnetic field due to the third conductor. Let me take this is the third conductor. For the third conductor, how it is acting as? See, this is one end. from here to here, this is completely circular wire. But from this point to this, it is a infinite straight wire. So for the infinite straight wire, so this point is exactly one end opposite. When the point is exactly one end opposite, now we can take what that is a semi-infinite wire. Therefore, for the semi-infinite wire, now the formula what mu naught by 4 pi, that is what I by r only. Again, if you want to measure the direction, so what? So as I told you, so the thumb gives the direction of the current. Therefore, thumb is so in the direction of the current. Now the palm of the right hand is in the direction of the distance. Now once again we have to hold the curl of the remaining fingers. The remaining fingers also out of the plane of the board. Therefore, this is also out of the plane of the board. Therefore, what is the question here? The total net magnetic field at the center by giving this 3-conductor system. Therefore, now the net magnetic field is given by B is equal to B1 plus B2 plus B3. B1 is equal to 0. Therefore, now you can get mu naught by 4 pi, that is pi I by r plus mu naught by 4 pi, that is I by r. Therefore, here pi is extra. If you take the common, mu naught by 4 pi I by r, so into what? Pi plus 1 is the answer. And if they will ask the direction also, that is what? Out of the plane of the board, this one. Right. So this is the first model. Now the second point is that in this one small change. So now, for example, same question, little bit variation. Now here this is one wire, right. Now this is the radius r. Now this is the wire like this. This is the infinity, the current is I. So here the current is I, and here the current is I, here the current is I. Again at the center of the circular wire, so what is the magnetic field I want? And this point is exactly like this. Therefore, now what? This angle we have to find out. Now tell me here, so the current is what? I, this current is also I, this current is also I. First of all, let me take, this is the first wire, this is the second wire, and this is the third wire. I am taking that. Here the magnetic field due to the first wire, magnetic field due to the third wire, both are equal to 0, because so for the first wire the point is exactly so along the axis. Therefore, for the third wire also the point is along the axis. Therefore, here we can confirm magnetic field due to the first part of the wire and magnetic field due to the third wire is compulsory is equal to 0. The only thing is that magnetic field due to the circular wire or circular cross section of the given wire produces the magnetic field, and but the thing is what is the angle theta we want. Therefore, now what? Here 45 degrees is left over. So remaining angle how much now? That is equal to, so what? This is the theta is equal to 3 pi by 2, because 90 plus 90 plus 90. So 3 times of the pi by 2, that is what? 3 pi by 2. As I told you, when the angles are out of the triangle, out of any trigonometry function, theta must and should be expressed in terms of the radians. Therefore, magnetic field, so B1 is equal to B3 is equal to 0, but magnetic field due to circular arc is given by mu naught by 4 pi. How much more? That is a theta I by r. Therefore, B2 is equal to mu naught by 4 pi into theta value 3 pi by 2 into I by, so what that is the I by r. Therefore, finally what you can get? Magnetic field B2 is equal to mu naught by 4 pi into 3 pi I by 2r is the answer. If they will ask the direction, so again, so use the right hand thumb rule. That what? That is the, so what? Out of the plane of the paper. Here also out of the plane of the paper only will get the answer for this. Okay. So therefore, this is the magnetic field due to combination of circular and a straight wires. Thank you. Daily
Okay, ma. Good morning, all of you. Today, I am going to discuss about amines, amine chapter. So, yesterday, day before yesterday, what I discussed alloalkanes and alloarenes. Now, today I am going to discuss about amines, right? So, some of the reactions yesterday what you have discussed same like that. Today also we will discuss total everything I will cover most of the right. What are those physical properties, chemical properties and preparation methods, everything I will cover based on the reactions only, right. Observe now. So, first what you have to do every time, every one alloalkanes, alloarenes and amine chapter first page. So, they are related to medicinal chemistry, their chloroquine, chloroamphenicol, halothane. So, what are the use, what are the disadvantages, they are already there. And that alloalkane compulsory you have to read, that is called match the following. Then again polyhalogen compound, last ending alloalkanes, alloarene chapter, polyhalogen compound, last part is there, that is also you have to read. There also chance is there, they will ask the match the following type column. Like that, here also amine chapter is there. In this amine chapter starting also, one of the biological active compound that is called, what do you call, adrenaline and ephedrine. Adrenaline and ephedrine, those are called secondary amino group. This is one of the time they ask the question. Which of the following biological active compound contains the secondary amino group? That is called adrenaline and ephedrine. What is the use of this one? To increase the blood pressure, that is the one of the point. Second one what there now? Novocaine. What that? Second one is Novocaine. Novocaine is antihistamic drug. Antihistamic drug. Next one is antihistamic drug. Next one is what do you call, Benadryl. Benadryl is, 1 minute, I will write the questions instead of that. Secondary amino group, one is, second one is Novocaine, third one is Benadryl, fourth one is quaternary ammonium salts. Ammonium salt. So, secondary amine, that is called to increase the blood pressure, those are called ephedrine and adrenaline. Next one is Novocaine. Novocaine is anesthetic. Anesthetic in dentistry. Next one is Benadryl. Benadryl is antihistamic drug. Antihistaminic drug, where you have to use. So, antihistaminic drug. Next one is, it is containing the tertiary amine. Next, quaternary ammonium salts, where you have to use surfactants. This is the one of the time they ask the question, right. Match the following. Once you observe clearly, one is secondary amino group, that means biological active secondary amino group, those are called ephedrine and adrenaline. So, where you have to use to increase the blood pressure. Next one, Novocaine. So, Novocaine, where you have to use anesthetic in dentistry. Next one, Benadryl. Benadryl is a antihistamic drug, it is contained in the tertiary amino group. Next one, last one is quaternary ammonium salts. Quaternary ammonium salts you have to use as a surfactants. These are the four important. One of the time they ask the match the following type. Now, here also chance will be there. This one are alloalkanes, alloarenes. So, what do you call, last one polyhalogen compound or first starting. So, anyone they will ask. Next one, some important points I am going to discuss. Points means related to preparation methods, physical properties and chemical properties, right. I am taking this one, what do you call, nitrobenzene. Nitrobenzene 2, I need aminobenzene, that is called aniline, because this chapter is amine. So, nitrobenzene to aniline. So, what are the reagent we have to use? Then what happened from here to here? Removal of oxygen, addition of hydrogen, that is called what? Reduction. That means we have to use reducing agent. What are those? One is SN plus HCl, Other one is FeHCl, that means tin HCl, iron HCl, Ni plus H2 also you can use. So in these two, which one is the better one? Which one is the better one means very very important. Iron scrap, this is what? Fe plus HCl, this is called better method and preferable method for the formation of amino benzene, that is called aniline from nitrobenzene. Why this one? In this, Fe and HCl will react to form FeCl2. FeCl2 is on hydrolyze. Hydrolyze means adding of water. Just I am normal I am writing now, hydrolyze. Then what I can get? Fe and again it release the hydrogen chloride means HCl. That meaning here, what is the meaning here? In this case, HCl gas already I used, first starting material. Then after reaction, product is formed. After product, byproduct is HCl also formed. That means, that is the meaning. How much amount of HCl is used in starting material, then again that much amount of HCl is released. That meaning here, byproduct will not be there. That HCl is again reusing. Reusing, that is called recycling process. Recycling means HCl is not a byproduct. That means it is not having the byproduct. That means it is not having the byproduct means that is the what are the reaction, what are the product you are getting, that product is 100%. That means that reaction will give the good yield, and this is only preferable method for the formation of amino benzene, that is called aniline from nitrobenzene. This is called one of the redox reaction. Sorry, one of the reduction reaction, that means that is called reducing agent. From here it is what happened, reduction. Reduction means this is called oxidizing agent. This oxidizing agent means this is called what? Reducing agent. Right? Next one. Observe next one. This is I am taking now. This is very important. That is called chloroethane, also called ethyl chloride, reacting with ammonia. Then what is the product I can expect? What a product I can expect? This is one case. Again, CTH5Cl with ammonia, but this ammonia is excess here. Otherwise, C2H5Cl plus ammonia again, but here CTH5Cl is excess. Three cases are there, observe now. In the three cases, what are the product I can expect? CTH5Cl with ammonia, that means here no one is excess. No one is excess means this nitrogen containing how many hydrogen? The 3 hydrogen. The total 3 hydrogens replaced by 3 moles of alkyl halide. Then what I can get the product? C2H5, right? Tries N and otherwise quaternary C2H54 N plus Cl minus. That means how many moles we have to use? 4 moles of C2H5Cl you have to use. 4 moles. Actually, sir, 3 hydrogens are there, sir. So, the 3 hydrogens are replaced by 3 chloroethane means what you call alkyl halide. But here lone pair also there, that lone pair also replaced by other mole of C2H5Cl. That means how many mole total? 4 moles of C2H5Cl. That is called, what I am getting the product is quaternary ammonium salt. This is called quaternary ammonium salt. First one, what I can get? 1 hydrogen replaced, then I can get primary amine. 2 hydrogens also replaced, that is called secondary amine. Third one is tertiary amine. Last one is quaternary ammonium salt. That means 4. Now in case of this one, so CTH5Cl and NH3 excess. This means ammonia is excess, but here which one is CTH5Cl is only 1 mole. That means one of the hydrogen is replaced by chlorine. Then what I can get now? C2H5NH2. This is the product only now. Other than that, remaining product is not possible because ammonia is excess, not alkyl halide. If alkyl halide is excess, then what I can get? Alkyl halide excess, in this case, the answer product is C2H5 plus N plus Cl minus. This is called quaternary ammonium salt. Observe now clearly. Here no one is excess, then the product is quaternary ammonium salt. Here ammonia is excess, primary ammonia is the product. Here alkyl halide is excess, quaternary ammonium salt, because this one only replace. That means what happened? Here carbon halogen bond breaking by using ammonia. The cleavage of carbon halogen bond by using ammonia, that is called as ammonolysis. What do you call? Ammonolysis. This is called ammonolysis. In this Ammo analysis is a preparation of primary amine, secondary amine, tertiary amine, quaternary amine. We cannot prepare separately. We can get mixture of amines, primary, secondary, tertiary and quaternary. That's why which one is primary amine is which amount, then we can't say that mixture of product you will get it you. That's why it is a somewhat disadvantage. So, Ammo analysis is some of the disadvantage. Why? Because it is getting mixture of all amines, right. Next one, CH3 C double bond O NH2, what do you call this one? Amide. Otherwise, this aliphatic amide, this is called amide, C double bond O NH2, benzamide, using lithium aluminum hydride, otherwise sodium mercury, sodium amalgam ethanol, otherwise Ni in the presence of H2 means Hi in the presence, H2 in the presence of nickel. These all are called reducing agents. So, what is the product I can expect? Reducing agent means that is whatever reduction is happened. So, amide is converted to amine, that means CH3, C double bond converted to CH2, NH2. This is also same, CH2, NH2. What is the product? Amine. Which amine? Both are primary amines, right? Then what happened here? From this to this what happened? Removal of oxygen, addition of hydrogen is called reduction. Reduction means this is called oxidizing agent. Which is undergo reduction, that is called oxidizing agent. This oxidizing agent means this must be reducing agent. That means lithium aluminum hydride, sodium amalgam ethanol and again hydrogen in the presence of nickel. These are called reducing agent. This one is strong reducing agent. This also reducing, this also strong reducing agent. This somewhat mild reducing agent. So, these two are strong, that means it reduces all functional groups, except double bond. In case of this one, double bond also will reduce. Observe what I am saying. This one both are strong reducing agents. This is somewhat mild. This one means in these two, which one is very strong reducing agent? This one only. Nickel, H2 in the presence of nickel or palladium or platinum. Anyone you can use, that is called strong reducing agent. It will reduce all functional groups including double bond also. But in case of this one, it will not reduces double bond, except double bond, remaining all functional groups will be reduced. That means double bond will not be touched. Sometimes they will ask the question. So, lithium aluminate, one double bond is given. So, I will give one question to you, then we will get it you, right. Now, based on that, I am giving one question to you. Observe here. This is one of the question. One of the year they asked. Reacting with what? Lithium aluminum hydride followed by hydrolysis. This is the question they are given. So, what is the answer I can expect? Here what is there now? This is the reducing agent. Instead of this one I will give you, this also I will give you, which means nickel in the presence of H2 or H2 in the presence of nickel or palladium or platinum, right. This one I am giving, this one and this one both are reducing agent, that means strong reducing agent. This will reduce all functional groups I told, all functional groups except double bond, Here double bond is there, here ketone is there, this amide is there now. That means amide also will reduce, ketone also will reduce, but not double bond. So, answer is C double bond O, first one observe. This one chain, double, wait, here double bond like this. The C double bond O converted to what? CH2 NH2, right. This methyl as it is, double bond will not be reduced. This is ketone is converted to what? Alcohol. Aldehyde is the primary alcohol, ketone is the secondary alcohol. This is the product. In case of what? Lithium aluminum hydride. In case of nickel, hydrogen in the presence of nickel or hydrogen in the presence of palladium or platinum, then what will happen? This is converted to amine like this. This is converted to like this alcohol. This also converted to that is called this one double bond, that is the meaning CH2 double bond C, that means that is converted to CH3, that means double bond converted to single bond. That single bond you remove, then you have to add hydrogen, that means you will get CH3. When? In case of this one. In case of this one, you will get this one. That means double bond will not be touched. That is the difference between lithium aluminum hydride and what do you call hydrogen in the presence of nickel or palladium or platinum. Right. Next one. I am giving one question to you, some other question. Physical property related question. Physical property related question, amma. Right. N C4H9NH2. N means straight chain. Again C2H5 twice NH. Again third one C2H5N CH3 twice. Third one. Fourth one C2H5 CH CH3 twice. Last one N C4H9OH. These are the different compounds, right? What is the question here? Write the increasing or decreasing order of boiling point. Very, very important. Boiling point. Yesterday I told boiling point concept. Boiling point, first one, boiling point directly proportional to molecular mass, first point I told. In case of isomers, what I told, in case of isomers are there, boiling point depends upon carbon chain. Carbon chain increases, boiling point increases because of surface area increases. Branching increases, boiling point decreases because of surface area decreases. That I told yesterday. Now third point I didn't say, just I am reminding you, already you know. Third point, in case of different functional groups with comparable molecular mass, comparable molecular mass, you have to know. This is 73, this is 73, this is 73, this is 72, this is 74. These are the molecular mass. Molecular mass of different functional groups, that you should know. So how to know this? How to calculate C4H9 and NH2, that is called primary amine, this is called secondary amine, this is called tertiary amine, this is called alkane, that means hydrocarbon, this is called alcohol. These are the all different functional groups, primary, secondary, tertiary amines, hydrocarbon and alcohol is there. In these three, these all are 1, 2, 3, 4, 5 are the different are there now. All are in the different functional groups with comparable molecular mass. Comparable molecular mass means any two functional groups you will take, molecular mass is differ by 2 to 4 grams. Molecular mass is differ by 2 to 4 grams, that is called as comparable molecular mass. Now here most of the 73, 73, 73, here 72 and 74, from this to this 1 gram different, from this to this also 1 gram only different, that is called comparable molecular mass. Comparable molecular mass means nearly same. That time boiling point depends on 3 factors. One is hydrogen bond, second one is dipole-dipole interaction, third one is induced dipole. Induced dipole is called van der Waals force. These are the three. This is the order. First hydrogen bond, second one dipole, third one is what? Induced dipole. In this most of the, this is called alcohol, this is called amine. Alcohol and amine both will exhibit hydrogen bond. How? For example, I will take alcohol, general formula ROH. Again I will take ROH, that is called alcohol. This is alcohol, this is also alcohol. It is formed hydrogen bond because of in this alcohol oxygen is more electronegative, this hydrogen more electronegative is oxygen, it getting negative charge, partial negative charge, here also getting negative charge, here also getting positive charge. Then what happened? More electronegative element with hydrogen atom to form a hydrogen bond. So this hydrogen bond. So this hydrogen bond present between two polar molecule is called intermolecular hydrogen bond. So, in this case intermolecular hydrogen in case of alcohol. In case of amines, observe, this is called primary amine, this is called secondary amine, this is called tertiary amine, right? These three amines form hydrogen bond. Observe now, first hydrogen amines form hydrogen bond. Observe now, this amine R N H H H, this is called primary amine. Again I will take other amine, primary amine. Here more electronegative is nitrogen, getting negative, here positive. More electronegative is nitrogen, hydrogen is positive. Then what happened? More electronegative element with hydrogen to form a intermolecular hydrogen bond. So here also intermolecular hydrogen, here also intermolecular hydrogen bond. That means alcohol also form intermolecular hydrogen bond, primary amine also form intermolecular hydrogen bond. Okay, right? In these two, which one is more intermolecular hydrogen bond? In this case, alcohol is the more than amine. Why? Both are forming intermolecular hydrogen bond. Okay, correct only. But so hydrogen bond depends on electronegativity. Which one is electronegativity? Oxygen is the more electronegative than nitrogen. So oxygen is the more electronegative, means it is getting more polar compared to this. More polar means more hydrogen bond chance. That means more hydrogen bond strength compared to this. So alcohol is more hydrogen bond strength than amines. So in these two, which one highest now? First alcohol, next one is primary amine. Now secondary amine, tertiary amine, observe now. The secondary amine is also form hydrogen bond. Primary amine form hydrogen bond. Secondary amine also will form hydrogen bond, but in case of tertiary amine, no hydrogen bond. What is the reason? Reason is, in case of primary amine, two hydrogens are there. In case of secondary amine, only one hydrogen is there. In case of tertiary amine, no hydrogen, that's a zero hydrogen. So more number of alpha hydrogen, more number of hydrogen, more ability to form hydrogen bond. More ability to form more hydrogen bond means that is called more stable. More stable means that is called more boiling point. So that's why it is more boiling point. Next to this one, next to this one. So that's one. Number of hydrogens are more. Hydrogen bond strength also more. Hydrogen bond strength is more. Again boiling point also more. Then finally primary, secondary, tertiary amine. Which one is the more boiling point? First one primary, next one secondary, next one is tertiary. In these three. Now comparison. First one alcohol, because of more hydrogen bond strength than primary amine, because of it is polar. Oxygen is the more polar nature than amine, than nitrogen. So that's why answer is finally 1. So that's one. 1, 2, 3, 4, 5. First one is 5. 1, 2, 3, 4, 5. 5 after 1. 1 after 2. 2 after 3. 3 after last one is 4. Why 4 is least one? Because 4 is what now? Hydrocarbon. Hydrocarbon means what type of interaction will be present? Induced dipole, induced dipole. That means, so dipole-dipole interaction where we have to observe? In case of ether, in case of aldehyde and ketone. Aldehyde and ketone and ether is the dipole-dipole interaction will be present. So finally, first one hydrogen bond, alcohol and amine. Alcohol is more hydrogen bond strength than amine, because of it is more polar than this one. Why it is more polar? Means it is more electronegative, it is less electronegative. That's why finally 5, 1, 2, 3, 4. This is the boiling point order. One of the time they ask the question. This is the boiling point concept also. Right. Next one is basic nature. Important, basic nature. First points you should know. Just I will remind you just one point only now. Basic nature. So amines will exhibit the basic nature. That is the first point. Why? Because just I will write amine RNH2. This is ammonia. So amines and ammonia, what are those? That is contain nitrogen. Nitrogen is a heteroatom. Heteroatom means that is contain the lone pair of electron. Lone pair of electron is there means it is able to donate it to acid. So that means nitrogen is a basic nature, that is nitrogen contains nitrogen where it is present in case of amines, that means amines are in basic nature. Why? Because it is able to donate lone pair of electron to acid. Which one is able to donate lone pair of electron to acid, that is called as base. That's why finally amines and ammonia all are basic nature. Why? Because it is having the lone pair of electron means it is able to donate to acid. Okay, that is okay. Now this one is what observe. RNH2, or maybe I will take any one, methyl or ethyl or any one, that is called ethanamine. Ethanamine, that is called primary amine, that means aliphatic amine. This is ammonia, just neutral. That means aliphatic ammonia and aliphatic amine and ammonia. Which one is the more basic? Which one is the more basic means aliphatic amines are more basic than ammonia. Why? Reason is observed now. What is the reason? This amine NH2 group adjacent is attached to this ethyl group. Ethyl group is a alkyl. Alkyl group means what you call plus I. Plus I means what now? Electron releasing group or electron donating group. Then what will happen? Electron releasing group is there. Electrons will be releases. Electron will be donated to nitrogen. Then what happened? Already nitrogen having the one lone pair. Again still it is donating. It is donating means, that means what happened? Your electron density is more. That means electron density is more on nitrogen atom. Electron density is more means it is able to donate more. That means it is able to donate to acid is more. It is able to donate to more acid is more means it is more basic. That's why finally what you have to say, ethanamine is than ammonia. Aliphatic amines are more basic than ammonia. Finally, what I have to conclude, electron releasing groups are there. What happened? Lone pair on electron will be releases to nitrogen is more. Then what happened? Electron density is more. Electron density is more means basic nature also more. That means what you have to say, final conclusion. Basic nature is directly proportional to plus I and plus M, that means electron releasing group, and inversely proportional to minus I and minus M, that is called electron withdrawing group. That you have to know. This is exactly opposite to acidic nature. So electron releasing group increases, electron density increases on nitrogen atom. So it is able to donate to acid is more, but it is more basic. That's why finally what I have to conclude, electron releasing group increases, basic nature increases. Electron withdrawing group increases, basic nature decreases. That means finally what you have to say, this is the point I have to say. Next one, pKb value, sometime pKb is more, that means Kb, first one you should know Kb, dissociation constant of base. Kb is more, that means concentration of OH is more. OH concentration is more, Kb is more. Kb is more means what happened? pKb is less. That time what happened? Basic nature is more. This point also you have to know. Sometime basic nature, sometime what they will give you pKb value, experimental value, no need to remember, they will provide you. What you can say? OH minus concentration increases. OH minus concentration increases means, that is meaning OH minus means basic nature. OH minus concentration increases, then what is increases? Kb value increase. Kb value increase means what about pKb? pKb value decreases. pKb decreases means what about basic nature? Increases. Finally what you have to say? pKb and basic nature which relation? Inversely proportional. Kb and basic nature which relation? Directly proportional. OH minus and basic nature which relation? Directly proportional. So OH minus concentration increases, basic nature increases. Right. Next point. Some other important point. This is what aliphatic and ammonia. Now and ammonia. What do you call this one? Aromatic amine, that is called aniline with ammonia. Aniline and ammonia, which one is more basic? Ammonia is more basic than aniline. What is the reason? What is the reason here? That means aniline is a weak base than ammonia. Statement based questions. Correct only. Why? Here, what happened in case of ammonia and aniline observe now. Aniline means anyway nitrogen is there, nitrogen has the lone pair of electron. This lone pair of electron having the conjugation with benzene ring. How to know? Double bond, single bond, lone pair. Having the conjugation. Conjugation means what will happen? Involving in resonance. So resonance means what will happen? These lone pairs are donated into the benzene ring. That means less availability on lone pair electrons on nitrogen atom. That meaning electron density is decreases on nitrogen atom. Why electron density decreases on nitrogen atom? Because it is involving in conjugation. It is having the conjugation, it involves in resonance. That means here electron density is decreases. Electron density decreases means what happened? It is not able to donate to acid is less. That's it is less basic. That is the first point. That means because of resonance. Because of resonance, aromatic amines are less basic than ammonia. That is the first point. Second point is what? This NH2 group, amine group attached to this group. That is what? Benzene ring. That is called phenyl ring. Phenyl ring is, in case of inductive effect, is -I. That means aryl ring. That is called -I. -I means what? Electron withdrawing group. That means electron withdrawing group is there. What about basic nature? Decreases. So because of electron withdrawing group, these two reasons. What are the reasons? Because of resonance, it is less basic than ammonia. Because of electron withdrawing group means what happened? Because electron withdraw, then what happened? Lone pair of electron nitrogen atom is less availability. That means electron density also less. Electron density is less means it is not able to donate it to acid. That's it is less basic. Finally, last point here. RNH2, that is called aliphatic amine. Next ammonia. Next one is aniline. That is called aromatic ammonia. That means aromatic amine. So aliphatic, ammonia and aromatic. In these three, which one is the more basic nature? So aliphatic amines are more basic than aromatic amine. Very, very, very important. Because of plus I. Why it is more basic? Because of plus I, electron releasing group. In these two, which one is more basic? Ammonia. In these two, which one is more basic? Already I told you. In these two, aliphatic amine is more basic than ammonia. Ammonia and aniline, which one is more basic? Ammonia is more basic than aniline is the explanation, right? Because of -I ring and because of resonance. These are the reasons, very, very important. In case of plus I, in case of -I and resonance, it is less basic. It is plus I, it is more basic, it is neutral in between that. That means aliphatic amines are more basic than aromatic amines. Based on this, I am going to give some question to you, right? CH3NH2, CH3 2NH, CH3N and NH3. What are these? Primary amine, secondary amine, tertiary amine and ammonia. Basic nature order. They are not mentioned anything. That means, observe now. I am mentioning now here gaseous phase. Very important question. Gaseous phase. Gaseous phase, basic nature of amine, different type of amines. Methanamine, N-methyl methanamine, N-N methyl, N-N dimethyl methanamine, ammonia. So not only methyl, any group you can substitute, ethyl, propyl, any group you can substitute. In case of gaseous phase, which one is the more basic? 1, 2, 3, 4. So these are called aliphatic, this is ammonia. Ammonia is the least anyway. In these three, which one highest? 3, 2, 1, last one is ammonia. This is the order, very, very important. Tertiary amine is the more basic than secondary than primary. Then last ammonia. In case of which phase? Gaseous phase. Why sir? Here methyl group, here 2 methyl groups, here 3 methyl groups. That means more number of alkyl groups, where it is there now? Tertiary. More number of alkyl group means what you call? More plus I. Alkyl groups are electron releasing group. More plus I means more electron releasing group. More electron releasing group means what? More basic nature. This totally purely depends on inductive effect. Plus I and plus I. All are plus I, but where is more plus I? In case of tertiary. So tertiary, secondary, primary and ammonia. Next one. CH3NH2. Some questions I will write on the board. right? CH3NH2, CH3 twice NH, same like that, CH3 3N and ammonia. But here what I am saying now, I am not mentioning any phase. Any phase I am not mentioning. Any phase I am not mentioning, that is called aqueous phase. That is the meaning. Aqueous phase. Anything they are mentioned means, anything they are not mentioned means, that is called as aqueous phase. So compulsory they aqueous phase means compulsory they have to mention, already mentioned. They are not mentioned means, that is meaning aqueous phase. Sometimes they will mention aqueous phase, sometimes they will not mention aqueous phase. They are not mentioned means also you have to consider as a aqueous phase. That time aqueous phase is there, basic nature is affected by some factors. What are the factors? One is solvation effect, second one is first one is actually inductive effect also there, that is what plus I. Second one is solvation, third one is steric hindrance. These main three factors, including this one extra one factor I am including, that is what pKb values. These are the four factors. Actually mainly three only influencing. One is inductive effect, plus second one is solvation effect. Solvation means hydration energy or hydration enthalpy. All third one is steric hindrance, bulkier groups. Fourth one is pKb. These four factors influencing on which phase? Aqueous phase. In case of gases will not affect, only affecting on only inductive effect. In case of gases phase only inductive effect. In case of aqueous phase, these all four factors will be influenced. Because of these four factors influencing, then in case of aqueous phase, it is not following regular trend. That means regular order. The regular order means this is a regular order. Tertiary, secondary, primary, ammonia. Otherwise, primary, secondary, tertiary, ammonia. That is the regular trend. Now it is not following regular trend. So in case of methyl, what the order is there? Compulsory secondary, that means 2 followed by primary, then last tertiary, then ammonia. In case of this one, which phase? Aqueous phase, in case of methyl. In case of ethyl is there, observe here, C2H5NH2, C2H52NH, C2H5 twice N, then ammonia. These are the ethyl amine. That means primary amine, secondary amine, tertiary amine and ammonia. That means I didn't mention any phase. Any phase means that is you have to consider as a aqueous phase. Aqueous phase means influence on the factor these three, the total four. Most of these three: inductive effect, solvation and steric hindrance. Last one is pKb values. So in this, that four will be influenced because of that reason. So it is not following regular order, regular trend. So basic nature order is, first one is secondary, next followed by tertiary, next followed by primary, followed by ammonia. This is the order. Observe clearly. If you remember this order, whatever the question they will give you, automatically you will do that, right? In case of methyl, in case of ethyl. In case of methyl is secondary, primary, tertiary and ammonia. In case of ethyl is secondary, tertiary, primary and ammonia. Sir, why it is following this order? Why it is not following regular trend? Reasons are these only. In case of methyl, in case of ethyl. They are not mentioned anything means what you have to consider? Aqueous phase. They are mentioned aqueous gaseous phase means this is the order. Whatever the group, any group. Sir, I given methyl, sir. Sir, sometimes they will give ethyl. Ethyl like this. Ethyl, primary, secondary, tertiary, ammonia they will give. In case of gaseous phase, what is the order? Same order. Tertiary, secondary, primary and ammonia. Whatever the group they will give you. In case of gaseous phase, tertiary, secondary, primary, ammonia. In case of this one, this is the order now. Right? Based on this, some other questions I am going to give. Compulsory question, basic nature. Here basic nature, next one is acidic nature. Acidic or basic nature compulsory. 1 or 2 questions must be. C6H5NH2, C6H5NHCH3, C6H5CH2NH2. This is the one question, basic nature order. Next one is aniline, P nitroaniline, that means para nitroaniline. Next one is paratoluidine. These are the question. These are the two questions related to basic nature. Observe here. This is aniline, N-methyl aniline, that means benzyl amine. These three are there. These all are aromatic compounds. So different compounds are not there now. Aliphatic, aromatic not there. Okay, aliphatic, aromatic is there, then aliphatic is more than aromatic. Right? Now here aromatic only now. In these three, which one is the more basic? Right? First one, this is the least basic. Why? Because this nitrogen atom directly attached to benzene ring. This is called benzene ring. That means it is involving in resonance. That time what happened? That time what happened means electron density decreases on nitrogen atom. That way it is less basic. That is least. In these two, which one highest? In this, which one highest? Here nitrogen atom attached to somewhat benzene ring. That means it is involving resonance. Now adjacent group what is there now? Plus I. So this side is involving in resonance. This side. That side involving in plus I. So already we know plus I is more, means electron releasing group is more, basic nature is more. But here it is more, but it is less. That means intermediate, leave it now. This side, this nitrogen group is not directly attached to benzene ring. That's why it is not involving resonance. In nitrogen attached to CH2, CH2 means which group? Plus I, alkyl group. That means electron releasing group. Right? So electron releasing group means electron releasing group is there, basic nature is more. That 1, 2, 3, which is highest basic? First one is 3. 2 and 1. 2 and 1, which is highest basic? 2 and 1, 2 is the more basic than 1 because it is directly attached to benzene ring. Right? This also indirectly, this also directly, but somewhat what is the group there? Alkyl group is there. Somewhat basic nature is more because of plus I. So answer is 2. Next one is 1. This is the order of basic nature. This is called increasing order of basic nature. Now, next one, aniline. Aniline structure you have to know. That is what? NH2. Paranitroaniline. Aniline, para position NO2. Paratoluidine. Aniline, that means NH2 compulsory. Toluidine means what you call CH3 group. These are the compounds. In this basic nature order I want. Right? So these all are anilines only, no? Aromatic compounds. So aromatic, all are aromatic compound means we can't decide now. Decided by what? Basic nature, electron releasing and electron withdrawing group. Observe here. Here NO2 group. NO2 group is minus I and minus M. That means electron withdrawing group. This is plus I, plus M and H also. Hyperconjugation also. Right? All electron releasing group. So electron releasing groups are there. Basic nature increases. Here nothing is there now. That's why it is involving resonance directly. So least basic compared to this. Observe first. In these three, which are highest basic? These three. Why 3? Because electron releasing groups are. In these two, which one is more basic? In these two, which one is more basic? 1 and 2, which one is more basic? 1 is more basic than 2. Why? Because an electron withdrawing group is there. Here nothing is there. That is called neutral. So electron withdrawing group is there. Basic nature will be decreases. So answer this one is least. This one is intermediate. That's why 1 and 2. That means first 3, next 1, next 2 is the answer now. Very, very important. Is the information about basic nature. Next, some other questions we are going to solve. CH3COOH with ammonia, that is X. Next one is NaOBr, that is Y. Next one is NaNO2 HCl 0 degree centigrade or 0 to, that means 273 to 278, 0 to 5 degrees centigrade. Now this is Z. Now this reacting with H2O warming, that is what okay, A. Next Z only treated with CH3 CH2 OH, that is B. Again Z only treated with H3PO2 followed by water, that is C. What are A, B, C? That is the question. This is the one of the time they ask. Different questions some. This one question one time they ask. This mixture with this one they ask one question. This up to this one is this one they ask other time. Right? Observe now. Acid reacting with ammonia. Acid means this is called ammonia, this is called base. Acid base what will form? Salt is formed first. CH3 COO minus NH4 plus. NH3 NH4, this is called salt. Ammonium acetate first. Ammonium acetate is unstable, then followed by heating, then what happened? Water is eliminate. Here H2, here O. Water eliminate, what I can get? Here H2 and O, remaining what is there now? CH3 C double bond O NH2. Observe clearly. Here H2 and O, water eliminate because of heating. Heating is there. First what you have to do? First any gas is there or not we have to check. Heating symbol is there. Any gas is there or not we have to check. Gas is there, gas will eliminate. Gas is not there means first water. Water we have to eliminate. Right? Water eliminated. Then what happened? Amide. This amide reacting with this one only, NaOBr. What is NaOBr? This is the mixture of NaOBr is, it is a mixture of NaOH plus Br2. Otherwise sometime they will give you KOBr, KOH plus Br2. What I can get? Observe now. NaO and Br. That is called NaOBr, H and Br, HBr eliminate. Otherwise KOBr, otherwise HBr. Like this they will give. Sometimes they will give you. Sometimes they now this time this is only they are given. This is coming from NaOH plus Br2. NaOH Br2 means that is called your reacting material is amide. Amide with NaOH plus Br, that is called Hoffman bromamide reaction. Which reaction? Hoffman bromamide reaction. Amide is converted to amine. Which amine? Primary amine. That means CH3 NH2. And what happened? This eliminate, this one is eliminated. That from what happened here? The reactant number of carbons are N, product is N minus 1, very very important in case of Hoffman bromamide reaction. Amide is reacting with Br2 KOH, otherwise Br2 NaOH, otherwise NaOBr, otherwise KOBr. That is called sodium hypobromite, potassium hypobromite. Sometimes they will give the name. Then what happened? Number of carbons are N, number of carbons are, product is N minus 1. One carbon atom will be decreases. So CH3 that is called amine. This is Y. Reacting with NaNO2 plus HCl at 0 to 5 degrees centigrade, that is called diazotization. What do you call? Diazotization. So diazotization means what I can get? CH3 N2 plus Cl minus, CH3 N2 plus Cl minus, that is called benzene diazonium chloride. So not benzene diazonium chloride, alkyl diazonium chloride. This alkyl diazonium chloride actually is highly unstable compared to RL diazonium chloride, directly converted to alcohol actually, right? Otherwise they are not given, this one means directly converted to alcohol only. This is the answer, actual product. Now this is they are given, same H2O warming, then what I can get? CH3, so N2 gas eliminate, HCl eliminate, then I can get water. So what I can get? CH3OH, right? Observe this one, instead of this. So that is the answer now, leave it this one. Why? Because this aliphatic compound, in case of aromatic compound, these two products is possible. Wait now, this aliphatic compound. So aliphatic compound I am getting aliphatic diazonium salt. Aliphatic diazonium salt is very very highly unstable as compared to the aromatic diazonium salt. So, aliphatic diazoxide salt is directly converted to alcohol in case of this one only now. So, extra I am giving anyway the final product also alcohol. Now observe now next question. Same, instead of this one what this I am giving what you call alkyl diazonium chloride. Now I am giving CH3N2 plus Cl minus one question, this one N2 plus Cl minus. So I got product this one Y and Z. This is called aliphatic diazonium salt, this is called aromatic diazonium salt. Aromatic diazonium salt is somewhat more stable than aliphatic diazonium salt. That's why it is diazonium salt is in these two diazonium salt is formed. This diazonium salt is directly converted to alcohol. But this diazonium salt is as it is like this only because somewhat stable compared to this. It is also stable at a short time only now. It's short time, then increase the temperature, then what happened? This also will converted to some other product. That's why now what I am doing now, I am taking H2O followed by warm. That's what I given. And what I can get the product? What I can get the product? That is called phenol. Observe, H and Cl, HCl eliminate, N2 gas eliminate because of warming, remaining OH is there, then I am getting OH. This is the called phenol. That's the first product. Next one what I given B. What the B I was given? H3PO2 followed by H2O with benzene diazonium chloride. Then what I can get? What I can get means benzene diazonium chloride with H3PO3 first H3PO3 converted to H3PO3 PO2 to PO3. That means H3PO2 here oxygen H3PO3. That means addition of oxygen. Addition of oxygen is called what you call oxidation. Remaining what is there now? H2 is there now. H2 means here H and Cl, HCl. N2 gas eliminate. Remaining what is there? Here H here C6H5. Then what I can get? Benzene. Very, very important that I am getting benzene. Then what happened here? Here what is the role of H3PO2? H3PO2 converted to what? H3PO3. Addition of oxygen. Addition of oxygen means what you call oxidation. Which is undergo oxidation? H3PO2 undergo oxidation. It is called as reducing agent. That means in this case, benzene diazonium chloride case, H3PO2 acting as a reducing agent. Next, same benzene diazonium chloride. That one only. With alcohol CH3CH2OH, that is called ethanol. Then what I can get? Same as it is. What I have done? Alcohol is converted to aldehyde. What happened? Removal of hydrogen. There addition of oxygen here, removal of hydrogen is called what? Removal of hydrogen is called addition of oxygen, removal of hydrogen is called what you call oxidation. Which is undergo oxidation? Ethanol. It is acting as a reducing agent. Then again, what I have removed? HCl, N2, remaining product is what I can get? Benzene, like that. In these two cases, H3PO2 and alcohol cases, diazonium salt converted to what? Benzene. In these two, alcohol and H3PO2, both are acting as reducing agents. Right. Some other question? Benzene reacting with concentrated HNO3 plus H2SO4, that is called nitration. That is one. Second one is SN followed by HCl. This is A. This one is NaNO2 followed by HCl at 0 to 5 degrees centigrade. Then again reacting with phenol with OH minus. What is B? B is from what is B? Observe here. First one, constant HNO3 H2SO4 means what you call nitrobenzene. That is called nitration. Nitration, electrophile is NO2, nitrobenzene. Nitrobenzene with SnHCl, that is called reduction. Already you know, nitrobenzene to aniline, that is second one. This is the first one. This reacting with NaNO2 plus HCl. NaNO2 HCl means that is called diazonium salt. 0 to 5 degree, that is called diazonium salt. What I can get? Benzene diazonium chloride, that is BDC. Benzene diazonium chloride with phenol. N2 plus Cl minus reacting with what? Phenol. Which condition? Phenol means acidic. Acidic means which condition you have to use? Basic condition. This is called coupling reaction. Coupling reaction, what happened here? Your para position hydrogen, this hydrogen and Cl, HCl eliminate, then what I can get? This is the product. N double bond N, H and Cl, HCl eliminate, that phenol ring is will attached. This is called para hydroxy azobenzene. Para hydroxy azobenzene, this is called orange dye, dyes. This is the final product, right? This is called coupling reaction. From here it is called diazonium salt, that is called diazotization. From here it is called reduction. From this to this is called what you call nitration. That means first step is nitration, second step is reduction, third step is diazotization, fourth step is coupling reaction, right? These are the questions now. Last and final question I will give you. Just you have to try. CH3NO2, NO2 at para, Fe followed by H plus means FeHCl, that is 1. Br2 aqueous, that means Br2 water, aqueous means Br2 water, second one. Third one is HNO2, fourth one is H3PO2, these are the four, fourth one, third one. So answer is what now? Observe, one last question I will discuss. First one, FeHCl, FeHCl means reduction, reduction means nitrobenzene. Nitrobenzene converted to aniline, that means CH3NH2. CH3 will not be changed, that is the first one, right? Br2 water, Br2 aqueous means Br2 followed by water, that means excess of mole, 3 moles. Now here this is called electrophilic substitution reaction. Now electrophilic substitution reaction means here 2 groups are there now, observe clearly. NH2 and CH3, which one is highly electron donating group? NH2. That means this group will be decide the incoming electrophile moving to ortho, para or meta. Which one decide? NH2. Because in these two which are highly activating group, NH2 than methyl. So how many moles actually we have to take? 3 moles. 3 mole mean 2 ortho, 1 para. Ortho is for this group. Ortho this one, meta, para. Para is already CH3 there. That means here we will not use the 3 moles, just we have to use 2 moles only. Why sir? Third mole if I want to use, third mole is not a free, that is attached to CH3. Now here CH3 will attack. So answer CH3, Br already NH2 is there now. Next, that is the second one. Third one is HNO2. HNO2 means that is coming from diazonium salt. That is what already I told yesterday. NaNO2 plus HCl. What I can get? HNO2 plus NaCl. NaCl, HNO. That is called HNO2 means nitrous acid. This nitrous acid is coming from diazonium mixture. That means that diazonium salt you will get it, you know. CH3, Br, NH2 is converted to N2 plus Cl minus. That is third one. Fourth one, H3PO2. now I told H3PO2 reaction, where here only. H3PO2 reaction, what happened? Diazenyl salt is converted to benzene. So answer is CH3 is H3PO2. H3PO2 there means compulsory water is there. It is acting as a reducing agent. Here Br, here Br. So this is remove N2 eliminate, HCl eliminate, H3PO2 converted to H3PO. This is the answer now. So this is the information regarding amine chapter, right? Remaining questions you have to focus. Okay, Amma. Thank you. Remaining concept I will start next day, next class. Okay, thank you.
So, good morning students. Yesterday the part of discussion was the plant growth and development, the third chapter in the plant physiology discussion. So far we have completed photosynthesis in higher plants, respiration in plants, and this is the chapter plant growth and development. And yesterday we told that the basic statement, that is growth and differentiation, combinedly we can consider it as a development. So in the life history of a plant, growth and differentiation and development are closely related part. So remember, development is the sum of growth and differentiation. So the growth here going to be is a irreversible permanent increase in the size of an organ, and it is accompanied by the metabolism, and the plant growth is open because new cells are always being added because of presence of meristems at certain locations. These meristems are of primary and also are of secondary type, and plant growth is measurable, not directly, indirectly we are measuring, because the direct method is to measure the increase in the amount of protoplasm. So the increase in the growth we can observe in the cell number 17,500 new cells are formed per 1 hour within the single root apical meristem of the maize, and 3,50,000 times a cell will be increased in size, that is related to watermelon. Increase in the length we can assume by pollen tube growth, and even increase in the surface area, it is going to be the broadleaf, that is a dicotyledonous leaf. Later on we have discussed the many concepts related to the growth, and we are end up yesterday by the growth rates. The growth rates may be arithmetic, geometric, absolute and a relative growth rate. In arithmetic growth rate, following the mitotic division, cell division, only one cell continues to divide, other cell stops dividing and become mature. Because of this, growth will be constant, root elongation at the constant rate, and the graph is going to be the linear. Next, second growth is a geometric growth rate, in which following the mitotic cell division, only both cells continue to divide. Because of this, the growth initially slow, later on rapid, we call it as exponential phase or log phase. Later, because of limited nutrient supply, it is entering into stationary phase. Same like you can see in the S-shaped curve in organisms and population chapter. Later on, we have said about absolute growth rate and relative growth rate. See, absolute growth rate is a measurement and comparison of total growth per unit time. Relative growth rate, we are comparing the total growth per unit time with the initial parameter. So leaf A and leaf B, yesterday we have considered A and B having the similar absolute growth rate, but relative growth rate of leaf A is greater than leaf B. 5, 5 dash, 50, 55 dash, that is a logic. Now we are entering into the next concept of discussion, that is conditions for the growth. See, these conditions for the growth, yesterday even we have seen phases of growth. The three phases of growth are meristematic phase, elongation phase and the maturation phase. See, these conditions for the growth, how can we assume? There are many conditions. One is the water, another one is the nutrients, even the oxygen, along with that light, temperature, etc. many will be there. So how the water going to affect? First, water helps to maintain the turgidity. What is meant by turgidity? When the water enters into the cell, the size of the cell will be enlarged. This condition where cell is filled with water, that is called as turgidity. So because of entry of water, what turgidity happens? Because of this turgidity, cell will undergo elongation and cell will undergo enlargement. So cell enlargement and cell elongation is because of this particular thing, water. And yesterday we have seen in the phase of elongation, increased vacuolation is there, that is because of entry of water. Along with this, water can provide the mechanism or medium for the enzymatic activities. Water acts as a medium for enzymatic activities, so that the water is very, very, very important. There is a statement, plant growth and further development was intimately, closely linked to water status of the plant, because it maintains the turgidity, elongation, enlargement, and it is acting as a medium for enzymatic activities. Next, the nutrients. There are two kinds of nutrients. One is micronutrients, which are required in less quantities. Some are macronutrients, which are required in high quantities. The micro and macronutrients are going to works in the plant body in two ways. It is helpful for the synthesis of the protoplasm. Helpful for the synthesis of protoplasm. Yesterday I told you protoplasm, the removal of cell wall makes it as a protoplast. Protoplast includes cell membrane, cytoplasm and the cell organelles. Whereas exception of even cell wall and cell membrane, both the cell organelles and cytoplasm, we can consider it as a protoplasm. See, this protoplasm synthesis occurs with the help of micro and macronutrients. Along with that, it acts as a source of energy. Source of energy this can act as. Because of these two reasons, it's one of the conditions for the growth. Next, oxygen. Just we have completed the chapter of respiration. Oxygen helps in aerobic respiration, which helps in breakdown of the glucose to release the ATP, large quantities of ATP. A small question here, what are the products of respiration? Do you think products of respiration? Equation C6H12O6 plus oxygen gives rise to carbon dioxide, water and the energy. The products of respiration are carbon dioxide and water. So, the oxygen, in the presence of oxygen, biomolecules will be broken down to release the energy. So, textbook statement, to release metabolic energy. To release the energy, oxygen is required in the perspective of respiration. So, these are the three major conditions of the growth. Light is important, temperature is important, and we already know for every living organisms to survive, particular temperature is required. We call it as the optimum temperature. More than or less than this optimum, enzymatic reactions will be stopped. Organism survival will be detrimental. It's a questionable thing. Next. After saying these conditions for the growth, let we enter into the next concept, that is differentiation, dedifferentiation and redifferentiation. I need the longest part of the board. So, this concept, how can we say? Simply with a simple flow chart, let we see. First, there are primary meristems present in the body of the plant. See these primary meristems. For example, shoot apical meristem, root apical meristem. What is the function of this meristems? It undergoes continuous cell division. After undergoing continuous cell division, its function is to add the new cells to the plant body. As new cells are always being added, the growth of the plant is open, already we have considered. So, the cells of the primary meristems, after they have produced, they lose the capacity to divide to form a mature cell. To form a mature cell. From the meristematic cell, a mature cell is formed by losing the capacity to divide. This process is called as differentiation. How can we assume this process of differentiation? A meristematic cell loses the capacity to divide and attain a specific function, that is called as what? Differentiation process. After losing the capacity to divide, that cell is called as mature cell. So, the process of differentiation makes a meristematic cell as a mature cell. During this differentiation process, there are two changes going to happen. First change is happening in the cell wall. Connected with the phases of growth, in the first phase, meristematic phase, the cells are thin cell wall made up of cellulose. Elongation phase, new cell wall deposition. Cell wall completely mature in the maturation phase. Secondary cell wall is formed. So, cell wall null differentiation going to happen. Thin cell wall will become thick. Primary cell wall will become secondary cell wall, and primary cell wall is capable of growth, secondary cell wall is incapable of growth. Remember it. Next, there is a changes happens in the protoplasm because it attains a particular function. Protoplasm changes and cell wall changes happen during the differentiation process. For example, I am saying the cells of the root apical meristem or shoot apical meristem forming the permanent tissues. For example, you can take parenchyma cells. Parenchyma cells or collenchyma cells, parenchyma, collenchyma, even the sclerenchyma cells. Even the sclerenchyma cells. This is a living, both are living tissues, this is a dead tissue. In the textbook, they have explained the formation of one sclerenchyma cell, that is a dead cell, that is a trachary element. This trachary element so trachary element is a sclerenchyma cells, that is the cells of the xylem, simply to understand. Now the cell of the shoot apical meristem or root apical meristem undergoes cell wall changes, protoplasm changes to become a mature cells. What are the changes happening during the formation of the tracker element? A living cell is becoming dead cell, so that protoplasm will be absent. Protoplasm will be deleted, it was gone completely. And the cell wall will become lignocellulosic cell wall. Lignocellulosic cell wall. Lignocellulosic cell wall means what? The cell wall is made up of cellulose actually. It is deposited with the secondary cell wall material called as lignin. So because of presence of lignin, cell wall is very thick and it is very strong to transport the water to longer distances. I told you trachary elements is a cell that belongs to xylem. Water pipe, to transport the water to longer distances in the plant body, the cell wall should be strong. So this is the thing. So ultimately I am saying meristematic cell becoming a mature cell by the process of differentiation. For example, shoot apical, root apical meristems are undergoing differentiation to produce parenchyma, collenchyma and sclerenchyma. One of the sclerenchyma cell is a trachary element. During the formation of the trachary element, the protoplasm will be absent. At the same time, cell wall become lignocellulosic cell wall to transport the water to longer distances. Now, the matured cell during some time, it will undergo reversal of the above process, so that a matured cell again became a meristematic cell. Meristematic cell is formed. This process is reversal to above process. We call it as a de-differentiation. De-differentiation. In the differentiation, meristematic became mature. De-differentiation, a matured cell will become the meristematic. So the meristematic cell which is formed later in the plant body, we call it as a secondary meristems. And the condition here, everyone has to remember, only living matured cells will undergo de-differentiation. Sclerenchyma like dead cells cannot undergo next process. Living differentiated cell can undergo de-differentiation, so that it can be formation of secondary meristematic cells. Secondary meristematic cells are formed. Example for the secondary meristematic cells, that is vascular cambium and cork cambium. Vascular cambium and cork cambium. These two are secondary meristems, and these are lateral meristems also. Now, the process of matured cell undergo de-differentiation to produce the secondary meristem is happening after the differentiation. Now, the cells of these secondary meristems can regain the capacity to divide. Means second time there is a differentiation. Again, not regain the capacity to divide, they loses the capacity to divide. It is going to be called as formation of the matured cell. So already lost the process of division that regain the capacity to divide to form the secondary meristematic cell. These cells of the secondary meristem again loses the capacity to divide to form the matured cell. This process is called as a second time differentiation. We call it as redifferentiation. Redifferentiation. So in the redifferentiation, the cell which has already lost the capacity to divide can regain the capacity, regain capacity to divide here. The cell which got the capacity to divide again lost the capacity to divide to form a matured cell. So the cells of this matured cell, the matured cell example from the vascular cambium, the matured cells formed are secondary xylem and secondary phloem. Secondary xylem and secondary phloem. Suppose this is a vascular bundle, below xylem, above phloem. In the middle there is a cambium. We call it as a vascular cambium. This vascular cambium towards above it is forming the secondary phloem, towards below it is forming the secondary xylem. This is going to be the secondary meristem producing matured cells. Next, the cells of the cork cambium, these are going to produce cork cells towards outer side and the secondary cortex. One cortex is already there, it is going to produce a secondary cortex. So this is overall differentiation, de-differentiation and redifferentiation. So observe, a primary meristem, the cells of the primary meristem loses the capacity to divide to form a matured cell by the changes in cell wall and protoplasm. The cells which has already lost the capacity of the division regain the capacity to division to form a secondary meristematic cell. The process is called dedifferentiation. And the condition here is only living mature cells like parenchyma can only undergo dedifferentiation, dead mature cells cannot undergo dedifferentiation. The meristematic cells which got the capacity to divide loses the capacity to divide again to form a mature cell. That is going to be called as redifferentiation, which is a second time differentiation. Example for the secondary meristems are vascular cambium and cork cambium. Example for the products of redifferentiation are secondary xylem, secondary phloem, cork cells and secondary cortex. So this is the concept of differentiation, dedifferentiation and redifferentiation. After that, there is a paragraph below to this that is saying in the plant growth may be determinate or may be indeterminate and may be open, and differentiation is also open. So this statement we have to catch up. The cells which are undergone differentiation will be in a different way. Suppose with the example of a root diagram I am saying, this is a root, here root apical meristem is there, ram. This root apical meristem produces cells in all directions. It is going to produce cells in all directions. Suppose the cells which are produced away from the root apical meristem, these cells are becoming the root cap. The cells which are produced towards the periphery, these are going to form the epidermis. The cells which are going to push towards in the middle, these are going to form the central cylinder. Central cylinder. So the basic point here you have to understand, what I am trying to say here, the process of differentiation is open. This is the statement, process of differentiation is open. How come? The cells, observe the statement, cells arised from the same meristem have different structures at maturity. The cells arised from the same meristem, same meristem going to produce different kinds of cells. All these cells are performing different functions based on what? Based on their location. The cells arised from the same meristem have different structures at maturity because the location decides the fate of the cell. Because of this, differentiation is open. Any cell can become anything. All are coming from the same meristem, but some are forming root cap, epidermis and central cell because the location is different. So this is the heading, differentiation, dedifferentiation and redifferentiation. After that, next concept to discuss is the development. So here is the second definition of the development. Development means all changes that an organism undergo from birth to the senescence, death. From birth to death, all the changes that an organism undergo, we can consider it as a development. For example, with the help of a diagram, let we understand. There is a meristematic cell. This meristematic cell undergo plasmatic growth. Which growth? Plasmatic growth, increase in the amount of protoplasm. After plasmatic growth, it is having two options. Either it continue to divide or it stops dividing and become a mature cell. So if it is want to continually divide, it is going to be undergo cell division. Undergo cell division, again it will become a meristematic cell. Sometimes a meristematic cell after plasmatic growth enter second phase of the cell or enter second phase of the growth, that is elongation or expansion. Cell expansion, we can consider it as a elongation, the second phase of growth. The moment it is entering into second phase of growth, it stops dividing, and as it stops dividing, we call this process as differentiation. Differentiation. After differentiation, it attains a particular function, we call it as a maturation. So observe here, very simple logic. Meristematic cell after growth, either it continue to divide or it stops dividing. If it is stopping dividing, it is entering into second phase of the growth, that is called as expansion or elongation. Do you remember what are the changes happening in the elongation phase? New cell wall deposition, increased vacuolation, cell elongation and cell enlargement. After elongation, it is entering into third phase, that is a differentiation and maturation. Ultimately, it will become a mature cell. A mature cell is formed. This mature cell undergo senescence, which is an old age process. Because of the senescence, one fine day it undergo death. So all these changes in the life cycle of a plant we can consider as what ma? Development. And the development is the sum of growth and differentiation. Here is growth is happening and also differentiation is happening. Ultimately this is the development of a plant body. And the development of the plant body is under the control of two different factors. Development is under the control of two different factors. What are those? Some are internal factors, some are external factors. Internal factors are there, external factors are there. The internal factors is of two types again. Intracellular factors, another one is intercellular factors. Intracellular factors means the factors which are helping for the growth from the cell, inside the cell. Inside the cell, what are the factors? Genes, we have completed this molecular basis and principles of inheritance. And next, intercellular factors are plant growth regulators, that is hormones which are going to affect the body of the plant. Next, external factors, like there we have already mentioned conditions for the growth. Water, temperature, nutrients, light, different factors are there, external factors. So external factors was completed. Intracellular factors in detail we have discussed in principles of inheritance and molecular basis of inheritance. Now this is the time we have to discuss about the plant growth regulators. And I forgot to mention one concept here, plasticity. Plasticity is simple, plant showing different pathways in response to environment or the phases of life. Two things you have to remember, developmental plasticity and environmental plasticity. So developmental plasticity and environmental plasticity. First, developmental plasticity example, cotton, coriander, larkspur. Cotton, coriander, larkspur. In them, young leaf is different than mature leaf. Juvenile leaf structure was different, and the mature leaf or a completely developed leaf, its structure was different. Whereas environmental plasticity example, buttercup. If you remember this, cotton, coriander, larkspur, all these are showing the developmental plasticity. Developmental plasticity means young leaf is different than mature leaf. And buttercup is showing the environmental plasticity, that includes the leaf which was grown in aquatic environment is in different shape. The leaf that was grown in the terrestrial environment was different. That is related to plasticity. Plasticity can be exemplified by formation of different kinds of leaf. We call it as a heterophily. Phily means leaf, hetero means different. Next, let we come to this concept and especially we are going to talking about the PGR, plant growth regulators. Let we talk about them, plant growth regulators, which is the last point of discussion in this particular chapter. Already some people who are there until the last in the college, I have explained to them. Still for everyone we are going to revise it in a simple manner. Simple manner, let me see. Plant growth regulators. We call it as a PGRs. These PGRs are very small compounds, simple compounds, but having diverse chemical composition. Different hormones are having different chemical composition. See, these plant growth regulators in detail, let me discuss. First, they are sometimes called as plant growth promoters. Some are called as plant growth inhibitors. Some are promoting the growth, some are inhibiting the growth. The plant growth promoters here going to involve in different kinds of functions like cell growth, cell division, flowering, fruiting, pattern formation, trophic growth. All these functions are considered as plant growth promoting activities. The plant growth promoters first and foremost is auxin, second one is gibberellin, we can call it as a gibberellic acid, and the third one is the cytokinin. Cytokinin. All these are the plant growth promoters. Plant growth inhibitors are going to be majorly abscisic acid. Abscisic acid. And the fifth one, that is ethylene. Ethylene belongs to both, but majorly most of the cases it is acting as a plant growth inhibitor. Same word you can write it here also, C2H4, ethylene. So ethylene can do both plant growth promoting activities and plant growth inhibitory activities also. Now these what can you say, ethylene majorly belongs to plant growth inhibitors. Now chemical composition, already I told you there are diverse chemical composition is there. So ethylene is a derivative of indole compounds. Ethylene is a derivative of the indole compounds like IAA, indole 3 acetic acid, and indole butyric acid, IAA, IBA. Whereas gibberellin is a derivative of secondary metabolite, we can call it as a terpene. So gibberellin is a terpene compound or terpene derivative compound. Whereas cytokinin is a derivative of adenine. We can call it as a purine derivative because adenine is a purine. So purine derivative or adenine derivative. For example, there is a compound called kinetin. Kinetin, that is N6 furfuryl aminopurine. Aminopurine. Ultimately, you have to catch this word purine. So this is the chemical name of this kinetin or N6 furfuryl aminopurine. Purine. This is the derivative of purine called adenine, that is a cytokinin. And abscisic acid is a derivative of a pigment, that is a carotenoids. Carotenoid is a compound from the abscisic acid. And ethylene, as I written the formula, it is a kind of gas. So that the statement here is plant growth regulators are small simple compounds which are of diverse chemical composition. So chemical composition remembrance is important. Auxin is a indole derivative, gibberellin is a terpene derivative, cytokinin is a adenine derivative, whereas abscisic acid is a carotenoid derivative and ethylene is a kind of gas. Let me go one by one discussion. Auxin. First discussion is related to the auxin. Related to the auxin, the discovery story if you see, I will touch the main points here, that is Darwin and Darwin. Charles Darwin and his son Francis Darwin, they have observed the unilateral illumination of light in the coleoptile of the canary grass. Coleoptile. Where we have seen this word coleoptile? Monocot embryo. In the monocot embryo, there is a coleoptile and the coleorhiza. We can consider it as in the embryo, it is a covering of the plumule. Covering of plumule. So, or shoot apex. So, this coleoptile is a covering of the plumule, we can consider. In the coleoptile of canary grass, let me take like this, shoot tip. They passed the unilateral illumination of light. Unilateral means one direction, illumination means passing of the light. When they pass the light in one direction, the tip of the coleoptile was bent towards the light source. We call it as a phototropism. Phototropism. So, Darwin and Darwin found that there is a chemical found at the tip of the canary grass, we can call it coleoptile of the canary grass, that causes the bending of the shoot tip towards the light source. And they are unable to find what is the reason for this. Later it was found that there is a chemical produced here that is migrated towards opposite side of the light source. It is migrated towards here. That causes the bending of this. Later it was found that is a auxin. So then F.W. Wendt is a scientist. He helps in isolation of the auxin from the coleoptile of oat seedlings. Coleoptile of the oat seedlings. So concept is very clear. Darwin, Charles Darwin and Francis Darwin are the scientists. They have credited with the discovery of the auxin in the coleoptile of the canary grass. Later on, F.W. Went is the scientist first to isolate the auxin from the coleoptile of the oat seedlings. We can call it as a Avena. Avena is the scientific name of the oat seedlings. Before to F.W. Went, there is another scientist called as a Kogel and Hagen-Smith. Kogel and Hagen-Smith, these names are not there in the NCERT textbook. What they have done, they have isolated the auxin before to F.W. Went, isolated the auxin from the human urine. From the human urine, for the first time auxin was isolated by Kogel and Hagen-Smith. No need to remember the names, but remember, before to isolation by F.W. Went, there is a first auxin was isolated from human urine. Later on by F.W. Went from the oat seedlings. So from the plant source, first this fellow, from the total, that is animal source, which is isolated from the human urine. So they discovered them, these two isolated them, and their experimental material is important. For Darwin, canary grass; for F.W. Went, oat seedling; for Kogel and Hagen-Smith, human urine. For the first time human urine indane isolate agita. Later on done by the F.W. Went. So this is the discovery story of the auxin. Auxin precursor. Precursor means that is a material that can be developed into auxin. That is a amino acid tryptophan. And the types of auxin. Let me discuss this story in detail. First, auxin types. Types of the auxin. There are two types. One is the natural auxin, another one is the synthetic auxin. Natural auxin and the synthetic auxin. The natural auxin is indole 3-acetic acid, whereas next one is indole butyric acid. Indole butyric acid, indole 3-acetic acid are the two compounds. We can consider them as natural auxins. And the synthetic auxin is 2,4-D. 2,4 dichlorophenoxyacetic acid. I am repeating, 2,4 dichlorophenoxyacetic acid is a synthetic auxin. Another one is a naphthalene acetic acid. Naphthalene acetic acid. So these are the natural and these are the synthetic auxins. And the way the auxin is going to get synthesized, the reasons of growth. Root apices and the shoot apices. Root and shoot tip is the site where auxin will be synthesized. Remember it. Next, functions are the effects of auxin on the plant body. So there are main functions. Many functions are there. First, auxin andrene on the mind al barbeku, that is apical dominance. Apical dominance. What is this apical dominance? The growing apical bud. Growing apical bud inhibits the growth of lateral bud. So because suppose this is the plant body, at the apex who will be there? Auxin. Because of this, auxin helps in the growth of this apical bud, whereas lateral bud growth will be stopped. Growing apical bud inhibits the growth of lateral bud. This is called as what? Apical dominance. To overcome this apical dominance in the tea plantations, what they are doing? Decapitation. What is mean by decapitation? Removal of the shoot tip. After removal of the shoot tip, they can be observed growth of the lateral bud. So while decapitation, remember here the question is important here. If the decapitation is happening, removal of the tip is there, they are removing the auxin. As they are why? Because auxin is synthesized at the tip. If they are removing the auxin concentration will be decreased, so that helps in the growth of the lateral bud, overcoming the apical dominance. So what we can say here, apical dominance means growing apical bud inhibits the growth of the lateral bud. Later in the tea plantation, for the purpose of growing the lateral bud, they are doing the decapitation, means they are decreasing the concentration of the auxin from the apical bud, so that it facilitates the growth of the lateral bud. This growth of the lateral bud process, we can call them as hedge making process. Hedge making. We can make the plant to grow the lateral buds. Hedge making process. That's the thing. Next, Along with this is the first function, main function of the auxin, that is apical dominance. A for auxin, A for apical dominance. Remember it. Next, another A is there, abscission. Second one is abscission. So what is meant by abscission? Falling off plant parts. We can call it as abscission, falling off or detachment. Now this auxin can do both promotes the abscission and also inhibits the abscission. It can promote and also it can inhibit the abscission. It will promote the abscission at the older stage. Older mature parts should be fallen off from the plant body. Auxin will promote it. Whereas it will inhibit the abscission also. How? By, what can you say? It can inhibit the abscission at the early stages. Early young fruits and young flowers will be stopped from abscission by the auxin. So auxin will promote the abscission at the older stage. Auxin will inhibit the abscission at the earlier stage. That is a logic. Next, after saying this, the next function, the third function, that is rooting. So rooting in means helps in the formation of the root. Auxin promotes rooting in stem cuttings like sugarcane. Sugarcane plants will be grown by cutting the stem and placing it in the soil. The sugarcane stems, if you spray the auxin on it, it will promote the rooting. So rooting in stem cutting will be done by the auxin. Next, flowering. Auxin promotes the flowering in case of pineapple. In the pineapple, auxin helps in the formation of the flowers. Next, auxin can be used as a herbicide or weedicide. So this 2,4-D, which is a synthetic auxin, it can kill dicot weeds or broad-leafed plants. Broad-leaf means which are having very broad leaf. That is dicotyledonous plants, not the monocotyledonous plants. Monocotyledonous plants having the length, not the surface area. Next, herbicide, there is a 2,4-D dichlorophenoxyacetic acid is used to kill the dicot weeds without affecting the mature monocotyledons. So D kills D, remember it 2,4-D will kill the dicotyledonous plants. And at the same time, next function, xylem differentiation. So it helps in the differentiation of the xylem from the meristematic plants, xylem differentiation. Along with that, cell division. Out of all these, another important function is a parthenocarpy. So what is meant by parthenocarpy? All of us know, it is there in the second year sexual reproduction concept also. Formation of the fruits without fertilization of the ovary. Formation of fruits without fertilization of the ovary, it is going to be called as a parthenocarpy. Those fruits are seedless fruits. Example is a tomato and a banana. So these are all the functions of the auxin. First, it will promote the apical dominance. To avoid this, in the tea plantation, they are doing the tea decapitation for the hedge making procedure. Second one is auxin promotes and inhibits the abscission. Promotes the abscission at the older stage, inhibits the abscission at the earlier stage. It can promote the rooting in case of the stem cutting, I mean by root formation. Next, promotes the flowering in the pineapple, and it can act as a herbicide or weedicide, that is the 2,4-D synthetic auxin kills the dicotyledonous weeds without affecting the mature monocots. And it helps in the xylem differentiation, cell division and the parthenocarpy. How can we remember every part of the plant body having connection with the auxin? Imagine a plant body, roots, it helps in the rooting. Stem, it promotes the apical dominance and it inhibits the abscission and promotes the abscission. To the leaf, what it is doing, promotes the young leaf fall and it permits the older mature leaf fall. For the flower, what it is doing, promotes flowering in pineapple. For the fruit, what it is doing, parthenocarpy. Total plant body, what it is doing, xylem differentiation and cell division. Like that you can remember. Next, another hormone to discuss here is gibberellin. But this gibberellin is also a plant growth promoter and it is a derivative of terpenes, which is a secondary metabolite. Next, the discovery story of this gibberellin. discovery story of the gibberellin. It is going to be like this. Na? There is a disease called as a Buchanay disease or foolish seedling disease arises to the rice seedlings. In the Japan, this disease was first identified. On this Buchanay disease, first person to do the research was Mr. E. Kurosawa. Mr. E. Kurosawa is a scientist that studied on this Buchanay disease on the rice seedlings, and he found that there is a fungus which can cause this disease. That fungus is already named, that is Gibberella fusicori. Gibberella fusicori. So, a small technical error. Observe, I am repeating. Discovery of the gibberellin occur because of Buccaneer disease, E. Kurosawa, Gibberella fusicorae, extracted part is gibberellic acid. So, until now, from the plants and the fungi, more than 100 gibberellins was isolated. More than 100 gibberellins was isolated from the higher plants and the fungi. Next, these gibberellins are named as gibberellic acid 1, gibberellic acid 2 and gibberellic acid 3. The gibberellic acid 3 was the first discovered and most intensively studied. Total how many gibberellins are isolated? More than 100 gibberellins from the higher plants and the fungi. Among them, the most studied and first discovered was gibberellic acid 3. And the functions of the gibberellin includes, there are different kinds of functions, like in the auxin, the main function is apical dominance. Same way, the main function in case of the gibberellin is going to be the bolting. What do you mean by bolting? Internodal elongation just prior to flowering. Simply to say, in the plant body, the place where leaf arises, that is called as a node. The portion between the two nodes is going to be called as internode. Elongation of the internode, we can call it as a bolting. So, main function of the gibberellin is bolting, that includes the elongation, so that length of the stem will be increased. So, this bolting is a internodal elongation, can be observed in a different perspectives. As per our textbook statements, bolting means elongation, it helps in the grape stalks to elongate. The grape stalks, if they elongate, it can hold more fruits, it will be helpful for the farmer. We can call it as a horticulture. So, horticulture means growth of the or growing of the fruit producing crops. In the grape stalk will be elongated with the help of spraying of auxin. And this bolting, it can be applied to the fruits like apple. Apple shape will be elongated, so that improvement of the shape happening because of the gibberellin. Next, the bolting will be applicable to the sugarcane. All of us know sugarcane is a crop, from that we want the stem part, because the stem contains the carbohydrates like sugars. So, these sugarcane, if it is sprayed by the gibberellin, it can undergo bolting, so that internodal elongation will happen. Length of the stem of sugarcane will be increased. How much? It can increase the yield 20 tons per acre. 20 tons per acre increase in the yield happen because of the spraying of gibberellin, that is because of bolting. And another function of the gibberellin, malting process. Malting process. So, this malting process was happen in brewing industry. What is mean by brewing industry? Beer producing industry, we can call it as a brewing industry. In this, they will take the grains and they will soak it and they will make it into fermentation. Because during this fermentation, starch which is present in this seeds will be converted into maltose. Starch will be converted into maltose. This process will be controlled by the enzyme alpha amylase. Alpha amylase is the enzyme that converts the starch concentration, which is a carbohydrate, converted into another form of carbohydrate called maltose. The process of breakdown of starch into maltose is called as a malting process. This is generally happening in the beer producing industries, we call it as a brewing industries. So, our gibberellin, especially GA3, gibberellic acid 3, if we apply to this brewing industry, especially during the malting process, it promotes the function of the alpha amylase, so that it can speed up the malting process. How it can speed up the malting process? Gibberellic acid 3 affects the promotion of the activity of alpha amylase, so that formation of the maltose will be speed up. So, textbook statement what it says, gibberellic acid 3 can speed up the malting process in the brewing industry. Along with that, this can delay senescence. So, getting the old age, aging process, we can call it as a senescence. Senescence will be slowed down by the gibberellic acid. So that if you spray the gibberellins to the crop which is ready to be harvested, the process of ripening of the fruits will be delayed, so that we can keep the fruits on the tree for the longer time. Generally, if there is a in the market, crop rate was not sufficient, the rate of the fruit was not happy or not sufficient, we can spray the gibberellin to these crop plants, so that crop plant it can hold the fruits for longer time to increase the or to extend the market period. Simply to remember, gibberellin can delay the senescence so that aging process will be slowed down. Next, after that, juvenile conifers. So conifers in this perspective we can consider them as cone containing plants. Those are gymnosperms. In the gymnosperms, the seed formation process is very slow. So if they are sprayed with the gibberellin, it can speed up the seed formation. Early maturity and speed formation will be improved by spraying of gibberellin to the juvenile conifers. So these are all the functions of the gibberellin. Main function is bolting, internodal elongation, so that it can increase the length of the grape stalk, and fruits like apple to elongate and improve their shape, and it helps the sugarcane to elongate, increase the length, so that yield will be increased by 20 tons per acre. And gibberellin will promote the malting process in the brewing industry by activating the alpha amylase enzyme that converts the starch into maltose, and it can delay the senescence and it can promote the maturity period in case of the juvenile conifers. That is the thing. So this is the second hormone, which is a plant growth promoter. The third hormone to discuss is the cytokinin, that is a plant growth promoter. Cytokinin. Now this cytokinin discovery story. So cytokinin, especially there is a scientist behind this discovery, F. Skoog. So what he has done, he had selected a tobacco plant. From the tobacco plant, from the internodal segment of the tobacco plant he has taken. This internodal segment is taken as an explant. We are now entering into the tissue culture concept. That is an explant. Any part of the plant that was taken out from the plant body for the growth is called as explant. So internodal segment, a small piece of the internode has taken and place it in the nutrient medium. The nutrient medium contains sucrose, starch, vitamins, minerals, inorganic salts, many things are there. We have seen in biotechnology chapter. So this nutrient medium, they have added the auxin. If they have added only auxin, there is no proliferation. Rapid cell division was not occurring when the nutrient medium contains only auxin. They came to know that along with the auxin, there is another substance should be there to promote the cell division. That's why they have tried different combinations of the nutrient medium. So this was proliferated, process was a success when they have added some elements in the nutrient medium. What are those? One is vascular extract, another one is yeast extract, another one is going to be the extract of the DNA, we can consider vascular extract, another one is coconut milk. So the concept is very simple. F. Skoog is a scientist. What they have done, internodal segment of tobacco, from the tobacco plant, internodal part is taken and placed in the nutrient medium. In this nutrient medium, initially they have added only auxin. When they added the auxin, cell division is there. Auxin promotes the cell division, but the growth is not up to the mark. We can call it as a no proliferation. So that they have started adding different components. When they add vascular extract or yeast extract or coconut milk, any one of these, not all, any one of this, it got proliferated. By that they came to understand that there is a cell division promoting substance present in these three particular things. They call it as a cell division promoting substance as cytokinin. Cyto means cell, kinesis means to divide. So cell division promoting substance, they call it as a cytokinin. So this was observed by F. Skoog and his co-workers. Later, the element which is extracted, the cell division promoting substance cytokinin, is first time isolated and crystallized by another scientist. His name is Miller. Miller is the scientist behind the isolation or crystallization of the cytokinin. So what Miller and his team, Miller et al. And his team, what they have done, they have taken a fish, that fish is called herring fish. From the herring fish, they have isolated the sperm. From the sperm of this herring fish, they have isolated the DNA. That DNA was undergone autoclaving process. After autoclaving, they identified there is a cell division promoting substance, that is a kinetin. So this kinetin, I told you N6 furfuryl aminopurine. N6 furfuryl aminopurine kinetin. As per textbook statement, what they have done, they explained kinetin was extracted from autoclaved herring sperm DNA. Autoclaved herring sperm DNA means what? From the herring fish sperm DNA, they have autoclaved and isolated the kinetin. And remember, the kinetin is not a natural cytokinin because it is not occurring in the plant. It is an artificial cytokinin extracted from autoclaved herring sperm DNA. So Skoog discovered the cytokinin presence, but it was crystallized and isolated by Miller et al. That too not from the plant source, it is from the animal source. So we can call it as a artificial cytokinin. Next to discuss is the functions of the cytokinin. We will discuss them in the tomorrow's class. So as of now, we have completed auxin and the gibberellin cytokinin discovery story. The functions of the cytokinins will be discovered in the upcoming class. Thank you.
Good morning, ma. Today I will explain about body fluids and circulation. So, in this chapter, the most important concept, that is about cardiac cycle, I will explain. First one, cardiac cycle. What is cardiac cycle means? Before discussing about cardiac cycle, first of all, we need to discuss about human heart. So, human heart is a mesodermal origin. That means our heart is formed from the cells of mesoderm. It is one of the germ layer. Okay? So, after implantation, the inner cell mass consists of specialized cells are called stem cells. These stem cells differentiated into 3 germ layers in the embryo, an outer ectoderm, an inner endoderm and middle mesoderm. From these 3 germ layers, cells modified to forms into all the organs and organ systems of our body. Similarly, our heart is also derived from the cells of mesodermal tissues. Hence, it is called as a mesodermal origin. Human heart is mesodermal origin. So, where human heart is located? Human heart is mesodermal origin, and where human heart is located means exactly between the two lungs and slightly tilted to the left side. That means an exact location of the position of the human heart is mediastinum. What do you call it, ma? Mediastinum. Human heart is located at mediastinum. Mediastinum means between the two lungs and which is slightly tilted to the left side. So called the left lung is slightly smaller than the right lung. Okay? And what is the size of human heart? The human heart size is our clenched fist. Our clenched fist. So the size of the human heart is their own clenched fist is the size of human heart, and which is muscular because it is made up of with a specialized muscles known as cardiac muscles and pulsating. Pulsating means it will show pulse, contraction, relaxation, kind of structures we can see in it, and also pumping organ. Human heart helps in the pumping of blood to the body parts. So that pumping of blood is very essential for the supply of nutrients and oxygen to the body tissues, and collection of carbon dioxide and waste materials from the body. So called human heart is very crucial role it will performs in the human being. Such type of human heart consists made up of with mainly 4 chambers. How many chambers, ma? 4 chambers. The human heart is made up of with 4 chambers. So this is called superior vena cava. What is the name of this blood vessel, ma? Superior vena cava. It will carry deoxygenated blood from all body parts to right auricle, and this is called systemic aorta. It is known as systemic aorta, which is the largest blood vessel, which is the largest blood vessel in the human heart, which supplies oxygenated blood, from left ventricle to all body parts. And the third blood vessel is pulmonary artery. Third blood vessel is pulmonary artery. This is left pulmonary artery branch. It is right pulmonary artery branch. So this will supplies deoxygenated blood from. It will supplies deoxygenated blood from right ventricle to the lungs for purification of blood, because where the blood purification takes place in our body? In the lungs. So respiratory organs are called lungs. These lungs purifies the blood. How? So whatever we breathe in during respiration, during inspiration, that oxygen exchanged into the blood at the lungs, and carbon dioxide produced in our body because of catabolic reactions exchanged into the alveoli at lungs, and that will comes outside along with the expiration process. So here, so that purification of blood takes place by the lungs. ಆ ಲಂಗ್ಸ್ಗೆ ಬ್ಲಡ್ ತಗೊಂಡೋಗೋ ಬ್ಲಡ್ ವೆಸಲ್ ಯಾವುದು ಅಂದರೆ ಪಲ್ಮನರಿ ಆರ್ಟರಿ. ದೆನ್ this pulmonary artery leads to, this is called interventricular septum. Interventricular septum. Yeah. Now see, the human heart, and human heart is made up of with how many chambers ma? 4 chambers. What are that 4 chambers? The 2 smaller, the 2 when compared to the ventricles, these 2 are the smaller structures. The 2 upper smaller chambers are called auricles or atria. So these auricles, one auricle present at right side, it is called as right atrium, and left side chamber, upper smaller chamber is called left atrium, and the 2 larger lower chambers are called ventricles. Ventricles are 2 types. One is the left side lower chamber is called left ventricle, and also the right side larger lower chamber is called right ventricle. That means the human heart contains totally how many chambers ma? 4 chambers. What are that 4 chambers ma? The 2 smaller upper chambers are called right atrium and left atrium, and the remaining 2 lower larger chambers are called right ventricle and left ventricle. And dear students, you always remember that the left side of the heart chambers, the left side of the heart chambers always carry oxygenated blood. Oxygenated blood will be carried. So what type of blood? Carried out or present in the left side chambers of the heart means oxygenated blood. In the right side of the heart chambers always carries deoxygenated blood. Deoxygenated blood. Then the 4 chambers of the heart will be well separated by septums. For example, you can take the 2 upper chambers. The 2 upper chambers I will draw here. If you think this is the human heart, so the 2 upper chambers, these are the 2 upper chambers, these are the 2 lower chambers. Hello ma. So the 2 upper chambers are called what? Right atrium and left atrium. The right atrium and left atrium are separated by a septum interventricular interauricular ma, because between the auricles present, no, interatrial septum. The two upper chambers, also known as auricles or right atrium and left atrium, is well separated by one septum, that is called interatrial septum. It is the thin septum. It is the thin septum which is called interatrial septum. Inter means between, atria means auricles, a septum means a partition is present, that is called interatrial septum. And another septum present between two ventricles, the right ventricle and the left ventricle, is well separated by a septum called interventricular septum. So, interventricular septum divides which chambers ma? The two ventricles are separated by interventricular septum. So, this is called actually interventricular septum. Yaudu? This one. This is called interventricular septum. Interventricular septum. Okay. Now, the two upper chambers and the two lower chambers are well separated by an another septum is called interauriculo or atrial ventricular septum. The two auricles and ventricles are separated by a septum called interatrial ventricular septum, a septum present between atria and ventricle is called interventricular septum. These are the three types of septums present in the human heart. Okay ma? And now the human heart consists two types of valves, especially three types of valves are present in the human heart. First one, the type of valve present between right atrium and right ventricle. See carefully, the valve present between right atrium and right ventricle. This is the valve. These valves are called, what do you call it? Tricuspid valve. What do you call it ma? Tricuspid valves. Tricuspid valve. So, why the valve present between right atrium and right ventricle is called tricuspid valves means in the right atrium three cusps are present like this. See, this is one papillary muscle. Papillary muscles are holded by chorda tendineae. E tara three types of papillary muscles with chorda tendineae are present. So, in the right ventricle, three cusps are present. Cusps andre, these cusps, each cusp is formed by a papillary muscle and also chorda, a fibrous thread-like structures are called chorda tendineae. So, hence the name came tricuspid valve. Sir, what is the role of chorda tendineae or papillary muscles present in the right ventricle andre? That will be holds the tricuspid valve during atrial systole, when walls of these two will be closed and there is a chance to damage during when the ventricles are contracted, there is a chance to blood backflow into the auricles. No, to prevent that backflow, these valves are closed. So, during that time, a damage agdira complete back side ಹೋಗ್ಬಿಟ್ಟು ಆ ವಾಲ್ವ್ಸ್ ಈ ವಾಲ್ವ್ಸ್ ಡ್ಯಾಮೇಜ್ ಆಗ್ದಿರ ಹಾಗೆ ಹೋಲ್ಡ್ ಮಾಡೋದಕ್ಕೆ ಪ್ರೊಟೆಕ್ಟ್ ಮಾಡೋದಕ್ಕೆ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. ಹೆನ್ಸ್ ಇಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಟ್ರೈಕಸ್ಪಿಡ್ ವಾಲ್ವ್. ಅಂಡ್ ಅನದರ್ ವಾಲ್ವ್ ಪ್ರೆಸೆಂಟ್ ಬಿಟ್ವೀನ್ left atrium and left ventricle is called bicuspid valve. Bicuspid valve, also known as mitral valve. Bicuspid valve is also known as what ma? Mitral valve. Because the shape of the bicuspid valve looks like a meter shaped, hence it is called as mitral valve. And why it is called as bicuspid valve means in the left ventricle two cusps are supported by these valves. Two cusps are supported by this valve, hence it is called as bicuspid valve. And here tricuspid valve plus bicuspid valves, two together called as AV valves also we can say it. What do you call it ma? AV valves. That means atrioventricular valves. Auricles ಮತ್ತು ventricles ಮಧ್ಯದಲ್ಲಿ ಇರೋ valves ನ atrioventricular valves or AV valves ಅಂತ ಕರೀತಾರೆ. And also third type of valves present at the opening of pulmonary artery. This is the pulmonary artery. Pulmonary artery is the blood vessel which carry deoxygenated blood from right ventricle to lungs for purification, right ma? So at this opening semilunar valves are present. At the same time systemic aorta opens into the left ventricle, means exactly here one pair of valves are present. That means semilunar valves present at the opening of pulmonary artery and opening of systemic aorta. Pulmonary artery opens into the which chamber of the heart? Right ventricle. Systemic aorta is opens into the which chamber of the heart? Left ventricle. Understand ma? So these valves are called semilunar valves. What do you call it ma? Semilunar valves. Semilunar valves. Yeah. And about blood vessels. The human heart consists mainly four types of blood vessels. Number one, superior vena cava and inferior vena cavas. See, this is the inferior vena cava and it will collect all the deoxygenated blood from lower parts of the body. Inferior vena cava of the heart collect deoxygenated blood from the lower part of the body and gives it to the right atrium. Right atrium. Similarly, because this blood vessel opening will be here, and also the superior vena cava collect deoxygenated blood from upper parts of the body like head, neck, upper chest region in the deoxygenated blood na collect ಮಾಡಿಕೊಂಡು it will gives it to the right auricle. Okay ma? So this blood vessel name is called superior vena cava. Superior vena cava. And this one is inferior vena cava. What is the role of superior vena cava? It will collect deoxygenated blood from all the upper parts of the body and gives it to the right atrium. And inferior vena cava collect deoxygenated blood from lower parts of the body into the right atrium. And second one, systemic aorta. This systemic aorta opens from the which chamber of the heart? Left ventricle. Left ventricle contain what type of blood? Oxygenated blood. So the oxygenated blood from the left ventricle enters into the systemic aorta. Systemic aorta too, it will supply all body parts. Okay? And the third blood vessel is pulmonary artery. Pulmonary artery is opens into the which chamber of the heart ma? Right ventricle. From the right ventricle, deoxygenated blood enters into the pulmonary artery to the, it will goes to the lungs for purification of blood. And the last one, left and right pulmonary veins. These are two left pulmonary veins and these are two right pulmonary veins. Remember dear students, these two blood vessels are opens here not here, okay. This right pulmonary veins present at the back of the human heart. Human heart back side in the banbitu left atrium olgade open agutte. So this is what actually human heart. And one more important structures, very essential role they play in the functioning of the heart, our cardiac cycle, is called a conducting system, okay. So the conducting system of the heart contain, see here, 4 important structures. First one, SAN. This is called a SAN. So SAN is a mass of muscle tissue, a mass of muscle tissue. The full form of SAN is sinoatrial node. What do you call it? SAN expanding form what ma? Sinoatrial node. So it is the present at right side upper junction of the right atrium. Can you expand SAN? Sinoatrial node. Where it is located? Right upper junction of the right atrium it is located. And what is the function of SAN, sir? Andre, SAN generates an action potential. SAN generates what ma? It generates action potential without any external stimuli. Andre ಬೇರೆಯವರು ಯಾರು ಯಾವ ಆರ್ಗನ್ಸ್ ಇನ್ಫ್ಲುಯೆನ್ಸ್ ಇಲ್ದಿರ ಅದಕ್ಕದೇ ಆಟೋಮೆಟಿಕಲಿ ಆಕ್ಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ನ ಜನರೇಟ್ ಮಾಡೋ ಕೆಪಾಸಿಟಿ ಸ್ಯಾನ್ಗಿರುತ್ತೆ. ಸೊ ಹೆನ್ಸ್ ಸ್ಯಾನ್ ಈಸ್ ಕಾಲ್ಡ್ ಫೇಸ್ ಮೇಕರ್ ಆಫ್ ದ ಹಾರ್ಟ್. ವಾಟ್ ಈಸ್ ಕಾಲ್ ಇಟ್ ಮಾ? ಫೇಸ್ ಮೇಕರ್ ಆಫ್ ದ ಹಾರ್ಟ್. ವಿಚ್ ಈಸ್ ಫೇಸ್ ಮೇಕರ್ ಆಫ್ ದ ಹಾರ್ಟ್? SAN. Why SAN is called phase maker of the heart? Because SAN generate an action potential without any external stimuli. Then the question is, how many action potentials generated by the SAN in a minute? So it is very clear. If once the SAN generate one action potential, that will be is equal to 1 heartbeat. That means a SAN generate an average 70 to 75 action potential. So an average anta kelidre 72 action potentials produced by the SAN. I repeat, SAN generate 72 action potentials in a minute. In 1 minute, how many action potential generated by the SAN means 72 times an average. 1 minute ಅಲ್ಲಿ ಎಷ್ಟು SAN ಜನರೇಟ್ ಮಾಡುತ್ತೆ ಅಂದರೆ 70 to 75. ಇದರಲ್ಲಿ ಆವರೇಜ್ ಅಂತ ಕೇಳಿದರೆ 72 ಆಕ್ಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ಸ್ ಜನರೇಟೆಡ್ ಬೈ ದ SAN ಇನ್ 1 minute. 1 ಆಕ್ಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 1 ಹಾರ್ಟ್ ಬೀಟ್. 1 ಆಕ್ಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 1 ಹಾರ್ಟ್ ಬೀಟ್. ಅಂದರೆ 72 ಆಕ್ಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ ಜನರೇಟ್ ಮಾಡಿದರೆ ಆ ಪರ್ಸನ್ ಹಾರ್ಟ್ ಬೀಟ್ ಎಷ್ಟು ಟೈಮ್ ಅಮ್ಮ ಪರ್ ಮಿನಿಟ್? 72 ಟೈಮ್ಸ್ ಓನ್ಲಿ. ಇಫ್ ಅ SAN generate 80 action potentials in a minute, then the person's heartbeat will be 80 times per minute only. Understand? So this is about SAN. Then SAN leads to another important structure in the conducting system of heart is called AVN. This is called AVN. So AVN is another mass of muscle tissue which is present left side lower corner of the right atrium. Which is the location of AVN amma? Left side lower corner of the right atrium. This AVN do not produce any action potentials, just it will receives action potential from the SAN and it transmit it to the another important structure is called bundle of His. What do you call it ma? Bundle of His ಗೆ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡುತ್ತೆ. ಈ ಪ್ರಾಸೆಸ್ ಅಲ್ಲಿ AVN ಅನ್ನೋದು ರಿಲೇ ಸೆಂಟರ್ ಆಗಿ ಆಕ್ಟ್ ಮಾಡುತ್ತೆ. ಅದಕ್ಕೆ AVN ನ ಫೇಸ್ ಸೆಟ್ಟರ್ ಅಂತ ಕರೀತಾರೆ. SAN is phase maker because it can generate action potential without any external stimuli, and AVN is called phase setter because it do not generate action potential, just it will receive and transmit to the next part of the conducting system. Okay, and then the bundle half is transmit this action potential to its left and right branches into Purkinje fibers. So these are called Purkinje fibers. The left and right branches of bundles of is further show a fine branches are called Purkinje fibers. Through this Purkinje fibers, the electrical impulses which are generated by the SAN will reach us to the walls of the ventricles. Is it clear now? So now I will try to explain what is exactly cardiac cycle. So remember dear students, cardiac cycle means a cyclical events which are repeatedly or which are cyclically occurs, a sequential events which are cyclically repeated are called cardiac cycle. What are those sequential events andre? Like contraction of auricles, like contraction of ventricles, like relaxation of auricles and relaxation of ventricles. So these are called sequential events. One event admele next another event, idu one time matra agalla, idu ಮತ್ತೆ cyclically repeat ಆಗ್ತಾ ಇರುತ್ತೆ. So that is called cardiac cycle. Okay ma? So what is cardiac cycle ra? Cardiac cycle means the sequential events which are cyclically repeated. The sequential events of the heart which are cyclically repeated are called cardiac cycle, or known as cardiac cycle. Then what are that sequential events present in the cardiac cycle means? Number one, systole. Systole is one of the event. Systole is also known as what ma? Contraction. What contraction takes place? So systole or contraction of atria and ventricles takes place. These are the two events. For example, contraction of atria, one event. Contraction of ventricle, second event. Next one, diastole, are also known as the relaxation of relaxation of atria and ventricles. So here are another two events again. Diastole means what ma? Relaxation. So relaxation of atria, another event. Relaxation of ventricles. So here four events occurs in the human heart. These events are repeatedly or cyclically repeated, like atrial systole followed by ventricular systole, followed by atrial diastole, followed by ventricular diastole. So these sequential events which are repeatedly occurs. Then how many cardiac cycles will occurs an average in 1 minute? I said you before, one action potential is equal to one cardiac cycle. One action potential is equal to one cardiac cycle. An average, how many action potential produced by the SANMA? 72. Andre 1 minute alli ಎಷ್ಟು cardiac cycles ಆಗುತ್ತೆ ಅಂದ್ರೆ approximately 72. And approximately 72 cardiac cycles occurs in a minute. Then the cardiac cycle duration, I mean these events, 4 events, systole of atria and ventricle, diastole of atria and ventricle will persist 0.8 second, that is called duration of cardiac cycle. So what is the duration of one cardiac cycle? The duration of one cardiac cycle is equal to 0.8 seconds. Okay. So among these 0.8 seconds, what phases are involved? Each phase will take how many seconds? We'll see now. Okay na? So an average cardiac cycle consists of 3 phases ma. I repeat, the cardiac cycle duration how much? 0.8 seconds. So this cardiac cycle contains how many phases? 3 phases. Number 1, atrial systole. Number 2, ventricular systole. Systole means what ma? Contraction. And number 3, joint diastole. Illi, as per our NCERT, joint diastole now first explain ಮಾಡಬಹುದು. ಯಾಕಂದ್ರೆ cardiac cycle, every cardiac cycle begins with a joint diastole only. It will begins with a joint diastole and even ends with the joint diastole. But overall, these 3 events are present: atrial systole, ventricular systole and joint diastole. Here, atrial systole duration is 0.1 second. Within 0.1 second, atrial auricular contraction takes place. That we will discuss soon. Then ventricular systole duration 0.3 seconds. And the third one is joint diastole duration is 0.5 seconds. Let me explain first how the cardiac cycle will be performed. Dear students, the cardiac cycle begins with joint diastole stage. I repeat, cardiac cycle begins with joint diastole stage. Andre idu first joint diastole stage in the cardiac cycle start agutte. What is the meaning of joint diastole? Means joint means all the 4 chambers of the heart. Diastole means relaxed. I repeat, in the joint diastole stage what happens ma? All the 4 chambers, 2 auricles, 2 ventricles are in relaxed, no contraction, no movement. So that condition is called joint diastole stage. Then when all the 4 chambers are relaxed, you know, the tricuspid and bicuspid valves are open. The tricuspid and bicuspid valves are open. And semilunar valves are closed at this time. Just imagine in the joint diastole stage, when 4 chambers are relaxed, tricuspid and bicuspid valves are opened, semilunar valves are closed. Okay ma? If tricuspid and bicuspid valves are opened, in the sense what happens? The blood from the superior and inferior vena cava, what type of blood? Deoxygenated blood will comes to the right atrium. From the right atrium into right ventricle ge 70% of blood will directly enters. Remaining 30% remains in the right ventricle. I repeat, during joint diastole stage, from the superior and inferior vena cava, deoxygenated blood from all body parts will enters into the right ventricle through right auricle. How much amount of blood directly flows from right atrium to right ventricle before contraction, before atrial systole means 70%. ಮತ್ತೆ 70% ಆಫ್ ಬ್ಲಡ್ ಡೈರೆಕ್ಟ್ ಆಗಿ ವೆಂಟ್ರಿಕಲ್ಸ್ಗೆ ಬಂದರೆ, ಯಾಕಂದರೆ ಟ್ರೈಕಾಸ್ಪಿಡ್ ವಾಲ್ವ್ಸ್ ಆರ್ ಓಪನ್, 70% of blood will comes to the right ventricle, and remaining how much percentage of blood present in the right auricle ma? 30%. Okay na? Similarly, from the left and right pulmonary veins, from the left and right pulmonary veins, oxygenated blood is collected from the lungs after purification and enters into the left atrium, from the left atrium into left ventricle. Then how much percentage of oxygenated blood enters into the left ventricle before contraction, before atrial systole andre 70%, and remaining how much ma? 30% of oxygenated blood present in the left atrium. Dear students, this is happens during joint diastole stage or the first stage of cardiac cycle. So joint diastole means what? All the four chambers of the heart will be relaxed state. At this time, which valves are opened? Tricuspid and bicuspid valves are opened. As a result, what happens? The deoxygenated blood from superior and inferior vena cava flows through right atrium into right ventricle 70%, and from the pulmonary veins oxygenated blood flows through left atrium to left ventricle, that is about 70%. Clear ma? And during joint diastole stage, semi-lunar valves condition what? It will be closed. So the joint diastole phase is completed. This is happens 0.4 seconds. It will take how much time, mama? 0.4 seconds. And the second one followed by atrial systole. Atrial systole. Officially, ಇದು ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಆಗುತ್ತೆ. ಬಿಗಿನ್ ಆಗೋದು ಮಾತ್ರ, ಸ್ಟಾರ್ಟ್ ಆಗೋದು ಮಾತ್ರ ಜಾಯಿಂಟ್ ಡಯಾಸ್ಟೋಲ್, ಬಟ್ ಪ್ರಾಸೆಸ್ ಇನಿಷಿಯೇಟ್ ಆಗೋದು, ಐ ಮೀನ್ contraction start ಆಗೋದು ಮಾತ್ರ atrial systole. So atrial systole means contraction of auricles. Then how atrial systole takes place, we'll see now. Okay, now 70% of blood present in the each ventricle and 30% of blood present in the each auricle. Correct ma? So now in the atrial systole what happens? The sun is there, no? Where sun is located? Right upper corner of the right atrium. This sun generates action potential without any external stimuli. This action potential reaches to the walls of the auricles. When sun generate action potential, this action potential reaches to the walls of that both the atria. ಎರಡು ಆರಿಕ್ಯುಲರ್ ವಾಲ್ಸ್ಗೆ ಈ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಆಕ್ಷನ್ ಪೊಟೆನ್ಷಿಯಲ್ ರೀಚ್ ಆಗುತ್ತೆ. ದ್ಯಾಟ್ ವಿಲ್ ಸ್ಟಿಮ್ಯುಲೇಟ್ ಕಾಸಸ್ ಆಫ್ ಕಾಂಟ್ರಾಕ್ಷನ್ ಆಫ್ ಬೋತ್ ದ ಏಟ್ರಿಯಾ simultaneously. I repeat, when sun generate action potential, this action potential stimulates contraction of both the auricles simultaneously. This is called atrial systole. ಅಂದ್ರೆ two auricles constrict ಆಗುತ್ತೆ, contraction ಆಗುತ್ತೆ. When the two auricles are contracted, what will happen? The 30% of blood which is present in the each auricle flows into the, increases flow into the respective ventricles. ಅಂದರೆ ಬಿಫೋರ್ ಏಟ್ರಿಯಲ್ ಸಿಸ್ಟೋಲ್ ಅಲ್ಲಿ ಆಲ್ರೆಡಿ 70% ಆಫ್ ಬ್ಲಡ್ ಬಂದಿದೆ. ಆಫ್ಟರ್ ಏಟ್ರಿಯಲ್ ಸಿಸ್ಟೋಲ್ 30% ಆಫ್ ಬ್ಲಡ್ ಈಸ್ added. Now after atrial systole, how much percentage of blood present in each ventricle ma? 100% of blood is present in the each ventricle. You understand? So this is happens within 0.1 second. That is called the atrial systole. Clear? Now, followed by ventricular systole. Ventricular systole means ventricular contraction. How ventricular contraction occurs, we will see now. Now, some of the action potential generated from the SAN will be received by the AVN. ಈ AVN ಏನು ಮಾಡುತ್ತೆ? It cannot generate action potential ಅಲ್ವಾ? SAN generate ಮಾಡಿರೋ ಕೆಲವು action potential ನ ಇದು ರಿಸೀವ್ ಮಾಡಿಕೊಂಡು it will transmit it to the bundles of his. AVN receives action potential from the SAN and transmit it to the bundle of his. Bundles of his transmit this action potential to the its right and left branches, and its right and left branches to the Purkinje fibers. Through Purkinje fibers, this action potential supplies to the along with the length of walls of the ventricles. ಅಂದ್ರೆ ಈ electrical impulse ಎರಡು ventricular walls ಗೆ supply ಆಗುತ್ತೆ. Then the ventricular walls are also stimulated, they undergoes contraction. This is called ventricular systole. I repeat, when the AVN receives action potential from the SAN, it will transmit it to the bundles of his. Bundle of his transmit that action potential to the its branches. Its right and left branches transmit that action potential to the Purkinje fibrous. Purkinje fibrous supplies that action potential to the walls of ventricles. As a result, ventricles are going to be contracted. That is called ventricular systole. Okay. If once ventricles are contracted, begins to contract, what will happen? In the ventricles, 100% of blood is there, no? When ventricles are contracted, ventricular contraction begins, what will happen? The blood pressure present in the ventricles will be increases. Ventricular systole increases the ventricular blood pressure. ಯಾಕಂದ್ರೆ ಅದು ಈ ಥರ ಕಾಂಟ್ರಾಕ್ಟ್ ಆದರೆ ಸ್ಪೇಸ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಸ್ಪೇಸ್ ಕಡಿಮೆ ಆದರೆ ಬ್ಲಡ್ ಪ್ರೆಷರ್ ಏನಾಗುತ್ತಮ್ಮ? ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಆಸ್ ಅ ರಿಸಲ್ಟ್ the blood try to escape from left ventricle to left atria, right ventricle to right atria. There is a chance, am I right? To prevent this backflow of blood from respective ventricle to auricles, these tricuspid valves and bicuspid valves will be closed. I repeat, when ventricular systole begins, ventricular blood pressure increases. When ventricular blood pressure increases, tricuspid and bicuspid valves are closed. You know why? To prevent its backflow of blood into the auricles. As a result, we get first heart sound. First heart sounds. That is called S1 is a lub sound will be produces. There are two types of heart sounds in a cardiac cycle. First S1 sound 1 is called lub. Tell me, lub sound is produced by the closure of AV valves. Closure of AV valves. AV valves andre enu? Atrioventricular valves, also known as tricuspid and bicuspid valves. Okay. Now tricuspid and bicuspid valves are closed now. Then ventricular contraction increases furthermore. That means ventricles are completely contracted, but tricuspid and bicuspid valves are closed. And you know what happens? Ventricular pressure is furthermore increases. As a result, semilunar valves are opened. Semilunar valves are opened. As a result, the 100% of oxygenated blood from left ventricle enters into the aorta to the, it will goes to the body parts. Similarly, that remaining 100% of deoxygenated blood enters into the pulmonary artery it will goes to the lungs for purification. This is called ventricular systole. Clear ma? Ventricular systole. So it will takes place within 0.3 seconds, dear students. Ventricular systole takes place how many seconds ma? 0.3 seconds. Now come to the ventricular diastole or joint diastole antanu karitare. Ventricular diastole or joint diastole is the third phase of cardiac cycle. In this what happens, the two ventricles are in will started to relax, not completely, just after contraction blood will goes to the body parts and pulmonary artery, right ma? So as a result, in the ventricular diastole or joint diastole what happens, the two ventricles are relaxed. When the two ventricles are started to relax, ventricular pressure what happens ma? Decreases. Am I right? So when ventricular pressure is decreases, there is a chance to backflow of blood from pulmonary artery to the right ventricle and from systemic aorta to the left ventricle. Alva? Yakandre ee heart kanta mele ide, pressure ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಇಲ್ಲಿ ಕಡಿಮೆ ಇದೆ, ಮತ್ತೆ some amount of blood back side ಬರೋಕ್ಕೆ ಚಾನ್ಸ್ ಇರುತ್ತೆ. To prevent its backflow, what will happen? The two semilunar valves are closed. When ventricular relaxation is begins, the ventricular pressure is decreases. As a result, semilunar valves are closed to prevent its backflow. To prevent its backflow. As a result, by the closure of semilunar valves, we get second heart sound is called S2 is called a dub sound. So dub sound is produced by the closure of semilunar valves. Semilunar valves. These are the two heart sounds. These two heart sounds are we can listen by using an instrument is called a stethoscope. And heart sounds are very essential and important for the clinical diagnosis purpose. Okay, ಈ number of heart sounds base ಮಾಡಿಕೊಂಡು whether heart functioning is normal or not ಅನ್ನೋ ವಿಷಯನು clinical diagnosis purpose ಅದನ್ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಓಕೆನಾ? And then ventricles are completely relaxed. When ventricles are completely relaxed, ventricular pressure is furthermore decreases, 0. When ventricular pressure is 0, then the atrial pressure will be more, right? As a result, tricuspid and bicuspid valves are again opens. Again soon the heart enters into the joint diastole stage. Again all the four chambers of the heart filled with the blood and soon one more cardiac cycle will be begins. So here atrial systole 1 second, ventricular systole 0.3 seconds, joint diastole 0.4 seconds. Overall within 0.8 seconds this is what happens. This is one cardiac cycle occurs because of production of one action potential. Now stroke volume, another important concept related to this one. Stroke volume. Okay, Here what is stroke value means? The amount of blood pumped out by each ventricle per one heartbeat. One heartbeat means what? One lub-dub alva. So for one lub-dub ge ಒಂದೊಂದು ವೆಂಟ್ರಿಕಲ್ ಇಂದ ಎಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ಬ್ಲಡ್ ಹಾರ್ಟ್ ಇಂದ ಆಚೆ ಹೋಗುತ್ತೋ, ಸಪೋಸ್ ಫ್ರಮ್ ದ ರೈಟ್ ವೆಂಟ್ರಿಕಲ್ ಹೌ ಮಚ್ ml ಆಫ್ ಬ್ಲಡ್ ವಿಲ್ ಗೋಸ್ ಔಟ್ಸೈಡ್ ಟು ದ ಲಂಗ್ಸ್ through the pulmonary artery, from the left ventricle to body parts through the systemic aorta. This is called stroke volume. So the volume of blood pumped out by each ventricle per one heartbeat, for one heartbeat, that is approximately 70 ml irutte. Average human beings alli one time one ventricle ಇಂದ 70 ml of blood body parts ಗೆ ಹೋಗುತ್ತೆ. From the left ventricle 70 ml of blood lungs ಗೆ ಹೋಗುತ್ತೆ purification. And then what is called cardiac output. Cardiac output. Here cardiac output means the amount of blood pumped out by each ventricle per 1 minute. Per 1 minute. Per one heartbeat ಗೆ ಎಷ್ಟು ಅಮೌಂಟ್ ಆಫ್ ಬ್ಲಡ್ ಈಚ್ ವೆಂಟ್ರಿಕಲ್ ಇಂದ ಆಚೆ ಹೋಗುತ್ತೆ ಅನ್ನೋದನ್ನ ಸ್ಟ್ರೋಕ್ ವ್ಯಾಲ್ಯೂಮ್ ಅಂತಾರೆ. ಅದೇ 1 ಮಿನಿಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ ಅದನ್ನ ಕಾರ್ಡಿಯಕ್ ಔಟ್ಪುಟ್ ಅಂತಾರೆ. ಸೊ ವಿ ಕ್ಯಾನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಕಾರ್ಡಿಯಕ್ ಔಟ್ಪುಟ್ ಬೈ ಯೂಸಿಂಗ್ ಅ ಫಾರ್ಮುಲಾ ದಟ್ ಈಸ್ ಸ್ಟ್ರೋಕ್ ವ್ಯಾಲ್ಯೂಮ್ ಇಂಟು ನಂಬರ್ ಆಫ್ ಹಾರ್ಟ್ ಬೀಟ್ಸ್ per minute. So stroke volume ಎಷ್ಟಿದೆಮಾ 70 ml into number of heartbeats per minute ಎಷ್ಟಮ್ಮ average 72 times per minute is equal to 5040 ml approximately, that is 5 liters of blood pumped out by the each ventricle per 1 minute, that is called cardiac output. So I repeat, stroke volume for one heartbeat 70 ml, cardiac output of the normal healthy person 5 liters or 5040 ml. Remember dear students, stroke volume and cardiac output is not same in all the human beings. That will be changes from different category of peoples. For example, you can take stroke volume and cardiac output is always increases highest in the athletes. ಅಥ್ಲೆಟ್ಸ್ ಅಲ್ಲಿ ಮೋರ್ ದೆನ್ 70 ml ಸ್ಟ್ರೋಕ್ ವ್ಯಾಲ್ಯೂಮ್ ಇರುತ್ತೆ. ಮೋರ್ ದೆನ್ 5 ಲೀಟರ್ಸ್ ಆಫ್ ಬ್ಲಡ್ ಗಂತ ಜಾಸ್ತಿ ಕಾರ್ಡಿಯಕ್ ಔಟ್ಪುಟ್ ಇರುತ್ತೆ ಅಥ್ಲೆಟ್ಸ್ ಅಲ್ಲಿ. ಓಕೆ, ಸೊ ರಿಮೆಂಬರ್ ದಟ್ ಒನ್. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್? ಇಟ್ ಈಸ್ ನಾಟ್ ನಾರ್ಮಲ್ ಇನ್, ಇಟ್ ಈಸ್ ನಾಟ್ ಸೇಮ್ ಇನ್ ಆಲ್ ದ ಹ್ಯೂಮನ್ ಬೀಯಿಂಗ್ಸ್. ಕ್ಲಿಯರ್ ಮಾ? ಅಂಡ್ ರಿಲೇಟೆಡ್ ಟು ನೀಟ್ ಸಮ್ ಕ್ವಶನ್ಸ್ ಯು ಮೇ ಗೆಟ್ ಇಟ್. Regarding cardiac cycle, for example, you can take this is the cardiac cycle ma. Okay, so this is called atrial systole. What it is? Atrial systole. Duration how much ma? 0.1 second. And this is called ventricular systole. Duration ma 0.3 seconds. And this is called ventricular diastole. Duration ma 0.4 seconds. Now when we get lub sound we obtained at the end of, at the beginning of ventricular systole, correct? So this is called lub sound. Then when we get dub sound ma at the end of ventricular systole, at the beginning of ventricular systole means exactly we can take here. This is called dub sound. Here the questions will arise from this topic. What is the time duration between lub to dub What is the time duration between one lub to one dub? That is 0.3 seconds. How much ma? 0.3 seconds is the time duration between lub and dub. And second one, what is the time duration between dub to lub anta keltare. So this is dub to lub andre ventricular diastole plus atrial systole is equal to 0.5 seconds. Okay ma? So what is the duration of lubra? 0.3 seconds. What is the duration of lubbala? What is the duration of lub dub ma? 0.3 seconds. Dub to lub ma? 0.5 seconds. So this is the first criteria. And second criteria, you already know that atrial systole duration. Then what is the duration of atrial diastole? Atrial diastole. Here atrial diastole is equal to ventricular systole plus ventricular diastole. ಯಾಕೆ ಹೇಳಿ ಏಟ್ರಿಯಾ ಅನ್ನೋದು ಯಾವಾಗ ರಿಲ್ಯಾಕ್ಸ್ ಆಗುತ್ತೆ? ವೆಂಟ್ರಿಕ್ಯುಲರ್ ಸಿಸ್ಟೋಲ್ ಫಾಲೋಡ್ ಬೈ ವೆಂಟ್ರಿಕ್ಯುಲರ್ ಡಯಾಸ್ಟೋಲ್ ಅಂದರೆ VS ಪ್ಲಸ್ VD is equal to atrial diastole ಆಗುತ್ತೆ. VS how much ma? 0.3 seconds plus VD how much ma? 0.4 seconds is equal to 0.7 seconds. Remember, the atrial diastole duration is 0.7 seconds. Similarly, you know that ventricular systole, but what is the duration of ventricular diastole? Here ventricular diastole is equal to, see here, ventricular diastole is equal to ventricular diastole VD plus atrial systole andre 0.4 plus 4 seconds plus 0.1 seconds is equal to 0.5 seconds. So these are the some important area you may get questions from the NEET examination, dear students, and be careful with this one, okay na? And prepare well. So this weekend syllabus I already revealed you. Number 1 evolution chapter, number 2 organisms and population, number 3 biodiversity and conservation, number 4 body fluids and circulation. You understand ma? Yeah, thank you. We will meet in the next class.
Good afternoon all of you students. Yesterday gravitation I completed. Now today topic oscillations. Oscillations. So in oscillations every year minimum 2 questions and 3 questions are also given. Minimum 2 and maximum 3. On May 3rd, under 2026 May 3rd, 3 questions are is given. So simple. Continuation. Okay. Now listen amma. In first point, a particle is in a simple harmonic motion like this. This is the mean position. So this is the extreme position of that x value plus a. This is the another extreme position x value minus a. Particle is in a simple harmonic motion about the mean position x is equal to 0, x is equal to plus a, x is equal to minus a. What is the equation? X is equal to a sin omega t when a particle starting at the mean position towards the positive side. X is equal to a sin omega t. What is the velocity? V is equal to a sin theta differentiation of cos theta into omega. A omega cos omega t. This is the velocity. That's where this value also equal to a square minus x square. Omega is omega into root of a square minus x square. Next, what is the acceleration? Minus a omega square sin omega t. That value is also equal to minus omega square x. So these three are the very important formulas. X is equal to a sin omega t. Velocity is equal to a omega cos omega t, or v, that v is equal to omega into root of a square minus x square. Acceleration is equal to minus a omega square sin omega t, or minus omega square x. So these three are the very important formulas. Now listen. This value 0, this value plus a, this value minus a. What about the velocity at the mean position? At the mean position x value 0 ga, what is the remaining value? Omega a. Velocity is equal to omega a. At the extreme position x value lo, like substituting the value a square minus a square 0. Velocity 0. So the velocity at the mean position is maximum. At the extreme position is minimum, like 0. This is the maximum value. Similarly, what about the acceleration? Minus omega square x. X value 0 at the mean position. A value 0. What is the acceleration value here? Plus a value substituting minus omega square a. Minus a value substituting omega square a. So the acceleration is the maximum at the extreme positions. Acceleration is the maximum at the extreme positions. 0 at the mean position. Velocity is the maximum at the mean position, and at the extreme position velocity value 0. So that is another important point. Next point. Now listen carefully. X value 0, x value plus a, x value minus a. What is that for one complete oscillation? What is the total distance? Total distance and total displacement for one complete oscillation. For one oscillation. For one oscillation, what is the total distance and what is the total displacement? Another important point. Now listen, what is the meaning of one complete oscillation? For example, particle starting at the mean position, moving towards to a extreme and come to mean, another extreme and come to original. That is known as one complete oscillation. This is a one complete oscillation. That's where what is the total distance? X is equal to 0 to plus a and like a, next a, next a, next a, total 4a. For one complete oscillation, the total distance is 4a. What is the total displacement? Like starting point, ending point, both are same, displacement value 0. Displacement value 0. So this is the another important point like a previous year question. For one complete oscillation, what is the total displacement of the particle? Like 0, right? Next point. Now listen, this is the x is equal to 0, x is equal to plus a, x is equal to minus a. What is the time period? The time taken for one complete oscillation like this one and coming towards mean and again another extreme like this one. This is the total is nothing but one oscillation, the time period is t. For mean to extreme, the time is t by 4. The time is t by 4, another important point. Exactly at half of the amplitude, what is the time? Exactly at half of the amplitude, what is the time? This model is the important. Already we know that particle starting from the mean position, what is the value of x? A sin omega t. Particle traveling the how much distance? A by 2 ga? Like A by 2. A sin omega t. A value cancel. 1 by 2. 1 by 2 value I am writing as a sin 30. 30 means pi by 6. Sin value cancel. Pi by 6 is equal to omega t. Omega value 2 pi by t into t. Pi value cancel. What is the value of small t? T by 12. So the particle is traveling how much distance? Half of the amplitude. For half of the amplitude, how much time is taken? T by 12, important point. So when a particle starting from mean to extreme, t by 4. Particle starting from mean to half of the amplitude, t by 12. Like this point to this point, time is t by 12. What is the remaining time? What is the remaining time? Sometimes is asking for half of the amplitude to extreme position, what is the time? How to solve that one? Total time t by 4. This time t minus t by 12. Both are minus, we get the remaining time like 12 LCM. 4 3s 1 t. Like t by 6. This value t by 6. This value t by 12. So this is the another important model. The time taken by the particle from the mean position to extreme position is t by 4. The time taken by the particle from the mean position to half of the amplitude is t by 12. For half of the amplitude, another extreme position, t by 6. So these points are the very important is the given on the previous years. So this is the concept . Next what is the kinetic energy of the particle? Kinetic energy is equal to half m v square. Half m v square. Half m. What is the value of v? Omega into a square minus x square. That value whole square means omega square into a square minus x square. This is the kinetic energy. What is the expression of the potential energy? Like half k x square. Half k x square. Already we know that when the particle is in a simple harmonic motion, the best example is nothing but spring oscillations. In spring, when any some displacement is there, like elongation or compression, we can producing the energy. That energy is stored as potential energy, like half k x square. This value also written as half m omega square x square. Half m omega square x square. What is the expression of the total energy? Kinetic energy plus potential energy. We get half m omega square a square. Half m omega square a square. That is the total energy. Kinetic energy, potential energy. These three formulas are important, like 2026, 2 questions are is given on the kinetic energy, 1 question, other one potential energy. Now, what are the questions are given on 2026 questions? Simple questions. Now listen carefully. 2026 questions. Now listen. One of the question is 2026 law. What is the graph between the kinetic energy and the time period? Time and asking the kinetic energy. Now listen. So this is the time. Already we know that particle starting from the mean position or another any one number. For example, particle starting from the mean position. What is the value of V amma? Here A omega, here value 0, here value 0 ga. For example, time t is equal to 0. For example, starting like this one, velocity maximum. After t by 4 amma, velocity 0. Velocity value 0. Another t by 4 amma, t by 4 plus t by 4 like t by 2 ga, velocity maximum. Another t by 4 amma, like velocity 0 and like 3t by 4. Again come to amma total time gara velocity maximum. What is the graph shape amma? Like this one. So the kinetic energy time graph is like this. Already this is the 2026 question amma. Common model amma, like basic model. So kinetic energy and time graph amma like a wave. Like a wave. Compulsory at time is equal to 0. Particle starting from the mean position like velocity is maximum. Next t by 4 velocity 0. Next come to the original position kada. Next t by 4 ki on 2026 question. Now one more question is the given amma. Now another question. The sum of the kinetic energy and the potential energy of the simple pendulum is kinetic energy plus potential energy value is 0.02 joules. Kinetic energy and the potential energy like total energy, that is 0.02 joules ega. That's where he is asking what is the speed of the bob. What is the speed of the bob at the equilibrium position? Equilibrium position means mean position. What is the speed? So that speed is nothing but a omega. That is asking the speed at the mean position a omega. So how to find the value? V is equal to a omega amma is asking that like this one. In that question amma is the given amma. Another one is body mass is 20 grams. 20 grams. Now listen. What is the total energy formula amma? Half m omega square a square. Half m omega square a square. How much value amma? 0.02. This two value cross multiplying 0.04 amma by mass value 20 grams converted into kg. What is the remaining value amma? A square omega square whole square ega. Right. What is the remaining value? This 10 power minus 3 take the numerator plus 3 and like 1000. So 1000 or 2 zeros is multiplied amma like 4 and 40 by 20 like this value 2. But a omega value amma, a omega value root 2 nega. So root 2 value is how much amma? 1.414 ega. That's why I is asking what is the speed of the particle at the mean position ega? What is the speed of the particle at the mean position? 1.414. Like this is the another question in 2026. So these two are the important questions amma. Every year amma number of the models are explained the same one is again repeated. Right. Now next point. Kinetic energy, potential energy values already we know that. Now the graph is, now listen carefully. This is the displacement bar. This is the kinetic energy and the potential energy. Both graphs are take them on a single graph. So like x value 0, x value plus a, x value minus a. Already we know that at the mean position velocity is maximum. Mean position velocity maximum means kinetic value 0. Like what is the graph shape amma? Like this. Potential energy amma at x value 0. The potential energy minimum, extreme position maximum. Like this is the potential energy graph. We can observe the in this point amma, the kinetic omega square x square. Half m omega square, leave it. A square minus x square is equal to x square. 2x square. X square is equal to a square by 2. X is equal to a by root 2. So the kinetic energy and the potential energy are equal at what displacement? A by root 2. And here also here negative value minus a by root 2. That is also the previous question. The kinetic energy and the potential energy are equal at a distance is a by root 2. So kinetic energy and like energy summa, like energies concept number of the questions are given do number of times these models. So Ke and Pe are equal at what distance a by root 2. Now another question, another previous question. This is the x, this is the energy One graph like this one one graph like this one here one dotted line. One dotted line. That dotted line is represents total energy, kinetic energy, potential energy. So already we know that as the displacement value changes, what is the formula of total energy? Half m omega square a square. So is there any x value in this equation? No. That's why as the displacement value changes, the total energy remains same like this one. At any point the total energy is same like this one. So that means that a dotted line is represents total energy graph. Total energy and displacement graph. So that is the given So one time is the given this dotted line is represents the total energy and displacement graph like this one. So similarly kinetic energy graph is the given 2026. So each and every points on the energy models are the important one, right? Okay, now some more previous questions like only energy Right. Now 2026 question another question is given Now listen carefully. Savita, like a 10th standard student, while conducting the experiment to determine the effective length of the simple pendulum is L. Like simple pendulum length is L. And note down the data of time taken to complete 30 oscillations. 30 oscillations. 30 oscillations in 60 seconds. 30 oscillations in 60 seconds. Then calculate the length of the pendulum. Then asking what is the length of the pendulum. That simple pendulum length is L. 30 oscillations in 60 seconds. That is the time is noted for oscillation 30 oscillations in 60 seconds. What is the length of the pendulum? How to find that? What is the meaning of 30 oscillations in 60 seconds means what is the frequency 30 oscillations by 60. Error. Number of oscillations in 1 second is known as a frequency. 30 oscillations in 60 seconds is nothing but frequency. How much 1 by 2. What is the time period 2 seconds Time period value reciprocal of the frequency like time period. Like time period value we get what is the time period of the simple pendulum? 2 pi into root of L by G. So T square 4 pi square L by G, squaring on both sides. T square 4 pi square L by G. Right already we know that G value and pi square cancel. G value 10 pi square and like 3.14 into 3.14 approximately 10 cancel. 4 cancel. What is the length of the pendulum? 1 meter. The length of the pendulum is 1 meter. That is the 2026 question. Total how many questions are given? Like 3 questions are given on the oscillations 2026. But all models are nothing but basic questions. Simple formula based, very small questions. So note them, all are important formulas. Next one 2024 question. Already I am explaining the point, Emma. What is that one? A particle executing the simple harmonic motion has the amplitude is A. Particle simple harmonic motion x is equal to 0 plus A and minus A. And having the same potential and kinetic energy at the displacement. Same kinetic energy and potential at what displacement? At what displacement Ke and P are equal, amma? Like A by root 2. Now I am explaining that one, A by root 2. That is the 2024 question. Now another question. Like 2024 question again. X is equal to 5 sin pi t plus pi by 3. A particle in a simple harmonic motion whose displacement value is given, that's why is asking the amplitude and the time period. What is the amplitude and the time period? What is the amplitude value, amma? X is equal to A sin omega t plus phi ega. That's why what is the amplitude value? 5 meters. How to find that time period, amma? What is the value of omega? Omega is equal to pi. Omega is nothing but 2 pi by t is equal to pi. Pi value cancel, amma. Time period is equal to 2 seconds. Time period is equal to 2 seconds. So that is the 2024 question. So amma compulsory ga oscillations lo all questions are like the basic models, amma. Do practice carefully ra. Okay, Namma. Some two concepts I will explain. Now listen carefully. In a simple pendulum, what is the time period, amma? T is equal to 2 pi into root of L by G. T is equal to 2 pi into root of L by G. Here L is the length of the pendulum, T is the time period. So the time period of the pendulum is independent of the mass of the body. T is independent of mass of body. That is the one of the point, amma. Next, that a total pendulum is dipped in water. That a total pendulum is dipped in water. What is the time period of the pendulum? In this one, the total length, amma. The total length is nothing but in water. So this body is pulled down one side and released. What is the time period of the pendulum? 2 pi into root of L by G into 1 minus dl by dB. G into 1 minus dl by dB. Another important point, amma. Next one. This is the spring. Body mass M. K is the spring constant. What is the time period of the simple pendulum? Spring pendulum. 2 pi into root of M by K. Here, amma, this spring pendulum depends upon the mass of the body and spring constant. Mass of the body and spring constant. Now, another important point. Now, next. This is the K1 and K2. These two springs are in parallel. What is the effective spring constant? 1 by Ks. The effective spring constant in series is equal to 1 by K1 plus 1 by K2. 1 by K1 plus 1 by K2. So here, amma, what is the time period, amma? 2 pi into root of M by Kn. But here take them effective spring constant. Effective spring constant like Ks. Value substituting here, we get the time period. Another point. Here am K1, here am K2. The two springs are connected in parallel. What is the effective spring constant? Effective spring constant is K1 plus K2. K1 plus K2. Now, what is the time period, amma? 2 pi into root of m by k. Time period t is equal to 2 pi into root of m by k. You can observe them, amma. Here, I am not explaining that the total depth problems are not explaining here. But I am explaining the formula based. But you can observe them in the last 5 years or 6-7 years low, oscillations or problems are is given only simple formula based. Only simple formula based. Is not asking the lengthy models more calculation part is not asking. Just is asking the simple basic formula based. Right. Just here I am explaining the time period of the simple pendulum, time period of the spring pendulum. Okay, in this combination of models, 1 or 2 models, I will explain them on the previous year questions. Now listen, amma. One by one questions, you can explain them. Already 2024 complete. Again, 2024 one model is given. What is that one? A mass of the bob in a simple pendulum is increased thrice of the original mass. Mass value is given thrice of the original mass. And the length is made half of the original. Half of the original. That's why the new time period is, the new time period, initial time period t, what is the new time period, amma? Sorry, new time period is x by 2 times of the original t, x by 2 times of the original, then what is the value of x? What is the value of x? But here, amma, we can observe them, mass value is how much, amma? 3 times of the original mass. That one is no need. Already I am explaining. Time period, amma, is independent of the mass of the body for simple pendulum, amma. So here mass 1 is no need, amma. What is the initial value? 2 pi into root of L by G nega. But here what is the value of T1? Next case lo 2 pi into length value is how much, amma? L by 2 into G. 2 pi into root of length value half of the original length by G. Here, amma, 2 in root 1 by root 2, take them separate. 2 pi into root of L by G value is equal to how much, amma? 2 pi into root of L by G like T nega. What is the value of T dash, amma? T by root 2 value came. But that T dash value is equal to how much is given? X by 2 into T nega. This T value cancel ga. What is the value of X? 2, take them here root 2. Here, amma, root 2 times cancel. That's why what is the value of x, amma? Root 2. So this is the 2024 question. Again, mass value is 3 times of the original mass. And length half of the original length. Original time period t. By the increasing of the length, by the increasing the mass of the bob, time period is x by 2 times of the original. What is the value of x? Initial value, amma, 2 pi into root of L by G. What is the final time, amma? 2 pi into root of length value 1 by 2 into G. Mass value is independent. So 1 by root 2 into 2 pi into root of L by G like T. This time value is given x by 2 into T. T value cancel, amma, 2 by root 2 like x value root 2. So that is the 2024 question. Now another question, 2023. 2023 question. A simple pendulum, again the simple pendulum. Now listen, a simple pendulum in air has the time period is root 3. In air, root 3. In air, what is the value, T is equal to 2 pi into root of L by G nega. Okay, next. It is completely immersed in a liquid, has the density of the liquid is 1/4 of the material of the body. 1/4 of the density of the body. Then what is the new time period? That's why in what is the time period in liquid? Already we know that time period in liquid is equal to 2 pi into L by G into 1 minus dl by dB. Error. Now listen, 2 pi L by G 1 minus dl by dB. What is the value of dl by dB amma? 1 by 4 ega? 1 by 4. 2 pi into root of L by G value I am taking as a how much value? Root 3. Root 3. T is 2 pi into root of L by G value root 3. What is the remaining value in root? 1 minus 1 by 4. 3 by 4. Okay, total having the root value ne kada 3 into 3 by 4 reverse 4 by 3. Root 4 like 2 seconds. Now again, time period value amma root 3 seconds amma in air. In air amma 2 pi into root of L by G. Now the body is dipped in liquid amma. The density of the liquid is amma 1 by 4th of the density of the body. What is the new time period? So time period of the body in liquid 2 pi into root of L by G into 1 minus dl by dB. So 2 pi L by G 1 minus dl by dB value 1 by 4. But 2 pi into root of L by Z value is equal to how much amma? Root 3 ga? Root 3. Remaining value, what is the root value ra? 1 minus 1 by 4 ra? How much amma? Like 3 by 4. 3 total both are in root kada? Common root. 3 into denominator lo 3 by 4 gara 4 by 3. Cancel, we get the 2 seconds. So that is the 2023 question. Now another question. 2023 another question. Now this is the time, this is the xt time graph like wave is given. Here am 2, here am 4, 6 and 8. Here am max value 1. Here am below maximum value minus 1. Right. What is the acceleration of the particle at 2 seconds? A particle is in a simple harmonic motion amma, like a xt graph is given. What is the acceleration of the particle at 2 seconds? What is the acceleration of the particle at 2 seconds? That is the question. Like this is the particle in a simple harmonic motion gara. This is the mean position. This is the extreme and again mean, negative extreme and mean. But exactly at 2 seconds amma like extreme position amma. Exactly at the 2 seconds extreme position kada. So at extreme position acceleration is equal to minus omega square a nega, minus omega square a minus omega square is nothing but 2 pi by t whole square ega into a minus 2 pi whole square 4 pi square into by time period value one complete oscillation the time taken is 8 amma. The time taken for one complete oscillation is 8 seconds. What is the amplitude amma? 8 whole square gamma whole square whole square ga 64. What is the amplitude value amma? 1. That's why how much? Minus pi square by this value 16 meter per second square. The acceleration of the particle is minus pi square by 16 meter per second square amma. Now that is the another important model. One minute amma. Okay nama, sorry for the break. Now next point amma. Now 2022 question. Again we can do the only previous year questions amma, compulsory same models repeated. Same models are repeated. Do 1 or 2 times the previous year questions. And every weekend paper we can practice all the questions one more time. That's is enough amma, we get the minimum marks amma. Minimum 120 plus easily we get. But do practice amma very strong. Right amma. What is the graph between the force and displacement? X value and the force. What is the graph between the force and the displacement of the particle? Now listen, already we know that A is equal to minus omega square x ga, and according to Newton's second law, F is equal to ma. M A value minus m omega square x, and force is directly proportional to x ga, and a compulsory negative sign. What is the meaning of negative sign amma? Both force and displacement are in opposite direction. So force value plus x value minus. For example, force value minus x value positive. That's why directly proportional to like graph shape. In this one force value positive, in this one x value negative. In this one x value positive, force value negative, because of both are in opposite. That's why a graph shape in the second and fourth coordinate is the graph is nothing but in the second and fourth coordinate. Now another point. A particle is moving 2021 question. Now 2021. A particle is in a simple harmonic motion, has the frequency n. Then what is the frequency of the potential energy? Now listen carefully. X is equal to A sin omega t. Omega is the frequency gara. That's why 2 pi n. What is the frequency n? The displacement of the particle frequency is n amma. That's why what is the potential energy? In case of the potential energy, what is the frequency? Now listen, they having the lengthy derivation part is there amma. That's why frequency for the displacement of the particle n for potential energy ki 2n. In case of the kinetic energy is asking, that value also is nothing but 2na. Sometimes here time period t. Sometimes displacement of the particle time period is t. Then what is the time period of the particle for a potential energy like t by 2. This one also like t by 2. So that points are the very very important one number. Right, note it. Displacement of the particle having the frequency n, time period t. Then potential energy of the particle in simple harmonic motion like 2n t by 2. Kinetic energy also like 2n and t by 2. So important one. That question is the given 2021. Like is asking the only frequency like 2 of the potential energy 2n. Now another question. 2021. A spring is stretched by 5 cm by a force of 10 newtons. By the 10 newtons the spring is stretched by 5 meters. 5 centimeters. Sorry 5 centimeters. So that's why what is the time period of the spring when mass 2 kg is suspended to it? 2 kg suspended what is the time period? What is the formula of the time period of the spring pendulum? M by K. Mass value given but K value don't know. How to find that one? But there that spring we can apply the force 10 what is the elongation? 5 centimeter gara. That's where already we know that F is equal to minus Kx. We can apply in the some force on a spring we can producing the elongation x. Then what is the relation? F is equal to minus Kx. 10 minus negative sign shows that force and error. This force displacement opposite take them minus K 5 centimeter 10 power minus 2. That's why what is the value of K This 10 power minus 2 take them here plus 2 gara into 10,000 by 5 200. So 2 pi into m value 2 kg by k value 200. 2 value 1 time ra 100 by 10. So that's why ra 5 by 5 pi by 5 seconds. The time period of the spring pendulum is pi by 5 seconds. So this is the another model. We can observe them in previous questions, so all are nothing but simple questions. Only is asking the basic formulas. Neat point of here, only that type of the formulas concept is enough. Right. Now another model. Now listen, in 2019, one question is the given. Now listen carefully. This model, lengthy question, but simple model. A mass is falls from a height h, has a time period is t. For example, this is the ground, m mass of the body, is falling from a height h. What is the time, t? And time period of the simple pendulum, capital T. Simple pendulum, like 2 pi into root of L by Z, simple pendulum time period is T. That's why the relation between them is T is equal to 2T. T is equal to 2T is given. Next case, the entire setup is taken to another planet. This is the total on Earth. This one taken the another planet. This one taken to the another planet, the total system. So another planet whose mass is half, mass of the planet is half of the mass of the Earth, and the radius value same. And the radius value same. That's why the same experiment is repeated. Same experiment repeated. This time taken t dash, that time like t dash. What is the relation between them? So that is the question. Again the previous question. Important model. Same model means previous concept, like listen carefully. In this one, freely falling body, what is the time? T is equal to root of 2h by z. Freely falling body from a height h, t is equal to 2 pi root of 2h by z. T is equal to root 2h by z. What is the time period, root of L by z. What is the relation, This is the point. Okay, this is on the Earth. But in another planet, what is the formula? What is the value of small g on the planet? Gm by r square, where m is the mass of the planet, r is the radius of the planet. G, what is the mass of the planet? M by 2. Radius of the planet as it is. And like gm by r square ante small g nega, like g by 2. Simple ga, the acceleration due to gravity on a planet is half of the acceleration due to gravity on the Earth. That's why same experiment is done in another planet. What is the time period? 2 pi, root of 2h by g value, g by 2 ga. Take them numerator. Root 2h by z value is how much, t ga? Already here root 2t. Root 2t. That's why what is the value of t, t1 by root 2 nega, leave it. Okay, next, what is the time period value, t dash? 2 pi into root of L by g value, g by 2 nega. Right. This 2 value, root 2 value, take them separate. 2 pi into root of L by g and like t nega. That's where what is the value of t, t1 by root 2 ega. Okay, so t1 value is nothing but root 2t. That's where what is the original t value, t1 by root 2. T1 value name root 2 into t. That what is the original value, t1 by root 2. But small t and capital T, what is the relation given, t is equal to 2t ga. What is the value of t, t1 by root 2. 2 into what is the value of capital T, t1 by root 2. Root 2 cancel. What is the value of t1? That t1 is equal to 2t1. So the time t1 is equal to t1. Original case and final relation both are same era. When g value is a half, when g value is nothing but half of the original one, like time periods are also same. This question is the 2019 question. So this is the another model amma. Now another model. So 2019 amma, again another question. 2019 y is equal to a naught a sin omega t plus b cos omega t. That's why what is the net amplitude of the oscillation? What is the net amplitude? Find net amplitude of the oscillation. Now listen amma, here amma only a naught. Generally in a particle in a simple harmonic motion gamma a sin omega t or cos omega t compulsory. But here amma only a naught value. That's why it is not in simple harmonic motion ga, that term is leave it. What is the remaining value? A sin omega t plus b cos theta. Cos theta value can be written as sin 90 plus theta. Sin 90 plus theta cos theta. Now we can observe them. This one is sin omega t. Omega t plus 90. What is the phase difference between them? 90 ga. One value amplitude A. For a 90 degrees, another one amplitude is B. Therefore, what is the net amplitude? Resultant. Root of A square plus B square. The net amplitude is root of A square plus B square. That is the 2019 question. Now another point. Again 2019 another question is the given. The average velocity of the particle in one complete oscillation. 2019 question. When particle in simple harmonic motion, x value 0 plus a, this value minus a. What is the average velocity in one complete oscillation? Average velocity. What is the formula of average velocity? Total displacement by total time. What is the total displacement? Starting point, let us assume this origin like extreme and come to mean and again extreme and come to mean, that is the one complete oscillation. Starting point, ending point both are same. What is the displacement value? 0 by t. 0 by anything is 0. That's why average velocity is 0. Sometimes average speed. What is the average speed amma? Average speed is nothing but total distance by total time. What is the total distance of one complete oscillation? A, 4A by t. So the answer is 4A by t. This is the average velocity, average speed amma. So that is the another point. Next amma, one more question. Now listen amma, this is the 2017 question. Now listen. A particle executing the simple harmonic motion as amplitude is 3 centimeter. Amplitude is 3 centimeter. And the particle 2 centimeter from the mean position. Particle in simple harmonic motion gara x value 0 ga, x value nemo a value 3 centimeter. But a particle nemo at 2 centimeter. Particle at 2 centimeter. What is the magnitude of the velocity and acceleration? Then it's a time period in n seconds. The magnitude of the velocity is equal to acceleration. Exactly in this point, velocity is equal to acceleration. That's why what is the time period? Particle in simple harmonic motion, the amplitude is 3 centimeter. Exactly at the 2 centimeter, velocity and acceleration both are equal. What is the time period? Now listen, velocity is equal to amplitude. What is the formula of the velocity? Like this one. What is this one, omega square x. Omega value square root cancel. Like omega x. Root is also there. Squaring on both sides. Squaring on both sides. A square minus x square, omega square x square. Therefore, omega square is equal to a square minus x square by x square. What is the value of a square, A square. 3 square, 9. X square and 2 square, 4 by x square, 4. Like 5 by 4. What is the value of omega, Omega square value, omega value, root 5 by 2. Root 5 by 2. But is asking the time period, omega value 2 pi by t. That's why t value, 4 pi by root 5. What is the time period value, 4 pi by root 5 seconds. This is the one model. Velocity and acceleration are equal at x is equal to 2 meters. What is the time period? Velocity formula, acceleration formula. Omega value cancel, remaining value. Squaring on both sides. Right. After that, omega square value, a square minus x square by x square. That's why we get 5 by 4. Only omega value root 5 by 2. 2 pi by t omega value. Therefore, t is equal to 4 pi by root 5. Next, another point, 2016 question, 2016 question. A body of mass m is attached to the lower end of the spring, and upper end is fixed. Upper end is fixed, here lower end is attached to a body mass, having the spring constant is k. When mass is slightly pulled down and released, the time period is 3 seconds. Here time period is 3 seconds. Next, it is mass is increased by 1 kg. Mass is increased by 1 kg. Same experiment, m plus 1. Mass is increased by 1 kg. Then the time period is 5 seconds. Then the time period is 5 seconds. Then what is the value of m? Then find the value of m. Now initially the spring is oscillating, whose time period value 3 seconds. What is the formula? Time is equal to time period 3, 2 pi into root of m by k. Initial time period 3, that is equal to 2 pi into root of m by k. And next case, time period is 5, 2 pi into root of mass value increased by 1 kg, like m plus 1 by k. Time period same spring, that's where m k value same. Now both are dividing. 3 by 5 is equal to 2 pi cancel. Denominator values are cancel. What is the remaining value, m by m plus 1. Squaring on both sides, like 9 by 25. 9 by 25, m by m plus 1. So on cross multiplying, 25m, here 9m plus 9. This value take them here, 16m is equal to 9. Therefore, m is equal to 9 by 16 kg. So here mass value, original mass is nothing but 9 by 16 kg. This is the one model, that is the 2016 question. Next, last model, 2015 question number in AAPMT. A particle is executing a simple harmonic motion, maximum acceleration is alpha. Maximum acceleration is alpha. And the maximum velocity is beta. Maximum velocity is beta. That's why what is the time period of the vibration? What is the time period of the vibration? A particle is in a simple harmonic motion whose maximum acceleration is alpha, maximum velocity is beta. What is the time period? Right, first, what is the maximum acceleration is alpha. What is the formula of maximum acceleration? Omega square A, value alpha. Next, maximum velocity is beta. What is the maximum velocity? Omega A, value beta. So now both are take them, okay, both are a alpha value or a beta value. 1 no, this value 2. Now 1 by 2. Divide the two equations. LHS are dividing, RHS are dividing. Alpha by beta. Here A value cancel. 1 omega value cancel. That's why only omega value alpha by beta. What is the value of omega? 2 pi by t nega. 2 pi by t. Therefore, t is equal to cross multiplying 2 pi beta by alpha. The time period of the oscillation is 2 pi beta by alpha. Okay. So, this is the last model. So, we can revise the only we can practice the previous questions. Same models are is repeated. So, that's why on tomorrow only this week syllabus exam right. On tomorrow 140 to 240 paper discussion. Right. Thank you.
Hello all. Today we are going to talk about electrochemistry part 2, and we are going to have a discussion of some more questions. So let's start with that. So here is a question. the EMF of a cell, thallium plus 10 to the power minus 3 molar, Cu plus 2, 10 to the power minus 2 molar copper. And for this, E cell equals 0.83 volt. And the question is, E cell could be increased by, and the options are increase concentration of thallium plus ions, increase concentration of copper plus 2 ions, increase concentration of both thallium plus and copper plus 2, decrease concentration of both thallium plus and copper plus 2. To understand this, first we'll write the Nernst equation applying it to this particular cell. E cell equals E naught cell minus 0.059 by n log. We have copper plus 2 concentration divided by thallium plus concentration divided by copper plus 2 concentration. Idu Nernst equation when applied to this. Idu bariyabodu equation onsala barita idini. Thallium becomes thallium plus, copper plus 2 becomes copper. Idralli thallium is a solid, thallium plus is aqueous and solid. ಆದರೆ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಒಂದೇ ಎಲೆಕ್ಟ್ರಾನ್ ಚೇಂಜ್ ಇದೆ, ಬಟ್ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸಿನ ಚೇಂಜ್ ಇದೆ. ಹಾಗಾಗಿ ನಾನು 2 ಇಂಟು ಮಾಡಬೇಕಾಗತ್ತೆ. ಆ ಥರ ಮಾಡಿದಾಗ ಇಂಟು 2 ಇಲ್ಲಿ ಕೂಡ ಮಾಡಬೇಕಾಗತ್ತೆ. ಆ ಥರ ಮಾಡಿದಾಗ ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ 2 ಬರ್ತವೆ. thallium plus whole square is in the numerator, copper plus 2 is in the denominator. ಈಗ ನಾನೇನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಅಂದರೆ, ಈ ಟೋಟಲ್ ಈ ಸೆಲ್ಲನ್ನು ಇನ್ಕ್ರೀಸ್ ಮಾಡಲಿಕ್ಕೆ ನಾವು ಏನು ಮಾಡಬೇಕು ಅನ್ನೋದು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಅದಕ್ಕೆ ನೀವು ಈ ಸೆಲ್ಗೂ ಥ್ಯಾಲಿಯಂ ಪ್ಲಸ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ಗೂ ಮಧ್ಯದಲ್ಲಿ ರಿಲೇಷನನ್ನು ಯೋಚನೆ ಮಾಡಿ ಒಂದು ಸಲ. ಈ ಸೆಲ್ ಇಲ್ಲಿದೆ, ಥ್ಯಾಲಿಯಂ ಪ್ಲಸ್ ಇಲ್ಲಿದೆ. ಈ ಸೆಲ್ ಮತ್ತು ಥ್ಯಾಲಿಯಂ ಪ್ಲಸ್ಗಳನ್ನು ಕಂಪೇರ್ ಮಾಡಿದರೆ ಈ ಸೆಲ್ ಈಸ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಥ್ಯಾಲಿಯಂ ಪ್ಲಸ್ ಕಾನ್ಸಂಟ್ರೇಷನ್. ನೀವು ನ್ಯೂಮರೇಟರ್ನಲ್ಲಿದೆ ಅಲ್ವಾ ಅಂತ ಅನ್ಕೋಬೋದು. ಇಲ್ಲ, ಅಲ್ಲಿ ಮೈನಸ್ ಇದೆ. ಮೈನಸ್ ಇಂಡಿಕೇಟ್ಸ್ ದಟ್ ದರ್ ಈಸ್ ಆನ್ ಇನ್ವರ್ಸ್ ರಿಲೇಷನ್ ಬಿಟ್ವೀನ್ ದ ಟು. ಅದರಿಗೋಸ್ಕರ ಈ ಸೆಲ್ ಈಸ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಥ್ಯಾಲಿಯಂ ಪ್ಲಸ್, whereas E cell is directly proportional to copper plus 2 concentration. ಇದನ್ನು ನಾವು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ದಾಗ ನಮಗೆ ಅರ್ಥ ಆಗಬೇಕಾಗಿದ್ದ ವಿಷಯ ಏನು ಅಂತಂದರೆ, E cell is inversely proportional to thallium plus and E cell is directly proportional to copper plus 2. ಹಾಗಾಗಿ ನಾನು ಈ ಸೆಲ್ಲನ್ನು ಇನ್ಕ್ರೀಸ್ ಮಾಡಬೇಕಂದ್ರೆ ಥ್ಯಾಲಿಯಂ ಪ್ಲಸ್ಸನ್ನು ಡಿಕ್ರೀಸ್ ಮಾಡಬೇಕು, ಕಾಪರ್ ಪ್ಲಸ್ 2 ಕಾನ್ಸಂಟ್ರೇಷನನ್ನು ಇನ್ಕ್ರೀಸ್ ಮಾಡಬೇಕು. ಅದಕ್ಕೆ ತಕ್ಕಂಥ ಆಪ್ಷನ್ ಅಂತಂದರೆ ಇಟ್ ಈಸ್ ಆಪ್ಷನ್ 2 ವಿಚ್ ಇಸ್ ಕರೆಕ್ಟ್. ಕ್ವೆಶ್ಚನನ್ನು ಇನ್ನೊಂದು ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ಥ್ಯಾಲಿಯಂ ಪ್ಲಸ್ ಕಾಪರ್ ಕಾಪರ್ ಅನ್ನುವ ಈ ಸೆಲ್ನಲ್ಲಿ ಈ ಸೆಲ್ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದಾರೆ. ಈ ಸೆಲ್ ವ್ಯಾಲ್ಯೂವನ್ನು ನಾನು ಇನ್ಕ್ರೀಸ್ ಮಾಡಬೇಕಂದ್ರೆ ಏನು ಮಾಡಬೇಕು ಅಂತ ಆಪ್ಷನ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇನ್ಕ್ರೀಸಿಂಗ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಥ್ಯಾಲಿಯಂ, increasing concentration of copper plus 2, increasing concentration of thallium plus and copper plus 2, decreasing concentration of thallium plus and copper plus 2 ಅಂತ. ನಾನು ನರ್ನ್ಸ್ಟ್ ಈಕ್ವೇಷನ್ನ ಅಪ್ಲೈ ಮಾಡಲಿಕ್ಕೆ ಇದಕ್ಕೆ ನಾನು ಫಸ್ಟ್ ರಿಯಾಕ್ಷನ್ ಈಕ್ವೇಷನ್ನ ಬರೆದುಕೊಂಡಿದ್ದೀನಿ. ರಿಯಾಕ್ಷನ್ ಈಕ್ವೇಷನ್ ಬರೀಲಿಕ್ಕೆ ಇದು ರಿಯಾಕ್ಟೆಂಟ್ 1, ಇದು ರಿಯಾಕ್ಟೆಂಟ್ 2, ಇದು ಪ್ರಾಡಕ್ಟ್ 1, ಇದು ಪ್ರಾಡಕ್ಟ್ 2 ಅಷ್ಟೇ, ಇನ್ನೇನಿಲ್ಲ. ಸೊ ಇದು ಈ ಥರ ಕನ್ವರ್ಟ್ ಆಗ್ತಾ ಇದೆ, ಇದು ಈ ಥರ ಕನ್ವರ್ಟ್ ಆಗ್ತಾ ಇದೆ. ದೇರ್ಫೋರ್ ನಾನು ಎರಡನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಈಕ್ವೇಷನ್ ಬರೆದಿದ್ದೀನಿ. ಬರೆದಿದ್ದಾಗ ಥ್ಯಾಲಿಯಂ ಪ್ಲಸ್ ಆಗಿದೆ, ಕಾಪರ್ ಪ್ಲಸ್ ಟು ಕಾಪರ್ ಆಗಿದೆ, ಬ್ಯಾಲೆನ್ಸ್ ಮಾಡಿದ್ದೀನಿ. ನರ್ನ್ಸ್ಟ್ ಈಕ್ವೇಷನಲ್ಲಿ ಪ್ರಾಡಕ್ಟ್ಸ್ ಬೈ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಬರೆದಿದ್ದೀನಿ. ಈಗ ನಾನು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ದಾಗ ಈ ಸೆಲ್ಗೆ ಮೈನಸ್ ಇದ್ದು ನ್ಯೂಮರೇಟರ್ನಲ್ಲಿದೆ, ಅಂದರೆ ಇದು ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಆಗುತ್ತೆ. ಆಮೇಲೆ ಇದು ಮೈನಸ್ ಮತ್ತು 1/, ಇದೆ ಡಿನಾಮಿನೇಟರ್ನಲ್ಲಿ. ಡಿನಾಮಿನೇಟರ್ ಅಂದರೆ ಇನ್ವರ್ಸ್, ಬಟ್ ಮೈನಸ್ ಅಂದರೆ ಇನ್ನೊಂದು ಇನ್ವರ್ಸ್. ಸೊ ಇನ್ವರ್ಸ್ಗೆ ಇನ್ವರ್ಸ್ ಅಂದರೆ ಡೈರೆಕ್ಟ್ಲಿ ಬರುತ್ತೆ. ಸೊ ಈ ಸೆಲ್ ಈಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಕಾಪರ್ ಪ್ಲಸ್ ಟು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅಂತ ತಿಳ್ಕೋಬೇಕು. ಸೊ ಥ್ಯಾಲಿಯಂ ಪ್ಲಸ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ನ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದರೆ ಈ ಸೆಲ್ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಕಾಪರ್ ಪ್ಲಸ್ ಟು ಕಾನ್ಸಂಟ್ರೇಷನನ್ನು ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದರೆ ಈ ಸೆಲ್ ಅನ್ನೋದು ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಸೊ ಆಪ್ಷನ್ ನಂಬರ್ 2 ಈಸ್ ಕರೆಕ್ಟ್ ಆನ್ಸರ್. ಲೆಟ್ಸ್ ಮೂವ್ ಟು ದ ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. ಇಲ್ಲಿ ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ ಏನಂದರೆ, ಫಾರ್ ದಿ ಎಲೆಕ್ಟ್ರೋಕೆಮಿಕಲ್ ಸೆಲ್ m+2 x(x-2), if E0 m+2 m 0.46 volt, E0 x(x-2) 0.34 volt, which of the following is correct ಅನ್ನೋದು ಕ್ವೆಶ್ಚನ್. ಅದರಲ್ಲಿ ಆಪ್ಷನ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಫಸ್ಟ್ ಆಪ್ಷನ್ ಈ ಸೆಲ್ ಈಕ್ವಲ್ಸ್ 0.8 ವೋಲ್ಟ್. ಸೆಕೆಂಡ್ ಆಪ್ಷನ್ m+x gives rise to m+2 plus x-2 is a spontaneous reaction. Option 3, E cell equals minus 0.8 volt. Option 4, m+2 plus x-2 gives rise to m+x is a spontaneous reaction. We need to look at the correct option. ಯಾವುದು ಕರೆಕ್ಟ್? ಡೇಟಾ ಇಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ, ಆಪ್ಷನ್ಸ್ ಯಾವುದು ಕರೆಕ್ಟ್ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನು ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಇದರಿಗೋಸ್ಕರ ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿದರೆ ಇದರದು ಕೊಟ್ಟಿದ್ದಾರೆ. ಇದು ಆ್ಯನೋಡ್ ಆಗಿದೆ, ಇದು ಕ್ಯಾಥೋಡ್ ಆಗಿದೆ. ಸೊ ನಾವು ಕ್ಯಾಥೋಡ್ ಮೈನಸ್ ಆ್ಯನೋಡ್ ಮಾಡೋಣ. ಆ ಥರ ಮಾಡಿದರೆ E0 ಸೆಲ್ ಈಕ್ವಲ್ಸ್ E0 ಕ್ಯಾಥೋಡ್ ಮೈನಸ್ E0 ಆ್ಯನೋಡ್, ಅಂದರೆ x(x-2) 0.34 ಮೈನಸ್ 0.46. ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡುವ ಅವಶ್ಯಕತೆಯೇ ಇಲ್ಲ ಇಲ್ಲಿ, ಬಟ್ ಯು ಕ್ಯಾನ್ ನೋಟಿಸ್ ದ್ಯಾಟ್ ದ ಫೈನಲ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ ನೆಗೆಟಿವ್. E0 ಸೆಲ್ ನೆಗೆಟಿವ್ ಆದರೆ ಡೆಲ್ಟಾ G0 ವಿಲ್ ಬಿ ಪಾಸಿಟಿವ್. ಅಂದರೆ ಈ ರಿಯಾಕ್ಷನ್ ಅಂದರೆ m+2 ಆಗೋದು, x(x-2) ಆಗೋದು. ಈ ತರಹದ ರಿಯಾಕ್ಷನ್ ಏನಿದೆ, ಇದು ಈ ಥರ ಆಗುವ ರಿಯಾಕ್ಷನ್ ಏನಿದೆ, ಇದು ಖಂಡಿತ ವಾಟ್ ವಿ ನೀಡ್ ಟು ಕನ್ಸಿಡರ್ ಇಸ್ ದರ್ ಇಸ್ ಲೈಕ್ ಈ ತರಹ ರಿಯಾಕ್ಷನ್ ಏನಿದೆ ಇದು ಖಂಡಿತ ಏನಾಗುತ್ತೆ, ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿಕಮ್ ಅ ನಾನ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ರಿಯಾಕ್ಷನ್. ಅದರಿಗೋಸ್ಕರ ಈಗಿದು ನಾನ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ಅಂದರೆ ಯಾವ ರಿಯಾಕ್ಷನ್ ಅದು? m+x gives rise to m+2 plus x-2. ಇದು ನಾನ್ ಸ್ಪಾಂಟೇನಿಯಸ್. ಎದಕ್ಕಿದನ್ನು ನಾನ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ಅಂತ ಇದ್ದೀನಿ ನಾನು? ಇಲ್ಲಿ m+2 ಆಗ್ತಾ ಇದೆ, x(x-2) ಆಗ್ತಾ ಇದೆ. ಅಂದರೆ ಈ ರಿಯಾಕ್ಷನ್ಗೆ ನಾನು E0 ಸೆಲ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ದಾಗ ನೆಗೆಟಿವ್ ಬಂತು, ಅಂದರೆ ಡೆಲ್ಟಾ G0 ಪಾಸಿಟಿವ್ ಆಗುತ್ತೆ. ಅಂದರೆ ರಿಯಾಕ್ಷನ್ ಏನಾಗುತ್ತೆ? ನಾನ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ಆಗುತ್ತೆ. ಯಾವ ರಿಯಾಕ್ಷನ್ ನಾನ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ಆಗುತ್ತೆ ಅದರ ರಿವರ್ಸ್ ರಿಯಾಕ್ಷನ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ಆಗುತ್ತೆ. ಅಂದರೆ ಈಗ m+2 x-2 ಗಿವ್ಸ್ ರೈಸ್ ಟು m+x ಅನ್ನೋದು ಸ್ಪಾಂಟೇನಿಯಸ್ ಆಗುತ್ತೆ. ಅಂದರೆ ಫೋರ್ತ್ ಆಪ್ಷನ್ ಈಸ್ ಕರೆಕ್ಟ್ ಆನ್ಸರ್. ಇನ್ನೊಂದು ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಕ್ವೆಶ್ಚನ್ನಲ್ಲಿ ನಮಗೆ ಈ ಸೆಲ್ ಕೊಟ್ಟು ಅದಕ್ಕೆ E0 ವ್ಯಾಲ್ಯೂಸನ್ನು ಕೊಟ್ಟಿದ್ದರಲ್ಲಿ ಯಾವುದು ಕರೆಕ್ಟ್ ಆಪ್ಷನ್ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. ನಾನೇನು ಮಾಡಿದ್ದೀನಿ, E0 ಸೆಲ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದರೆ ನನಗೆ ನೆಗೆಟಿವ್ ಬಂತು. ಅಂದರೆ ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ದ ಪ್ರಕಾರ m ಆಕ್ಸಿಡೈಸ್ ಆಗ್ತಾ ಇದೆ, x ರೆಡ್ಯೂಸ್ ಆಗ್ತಾ ಇದೆ. ದೇರ್ಫಾರ್ ಅದರ ಪ್ರಕಾರ ನೋಡಿದರೆ E0 ಸೆಲ್ ನೆಗೆಟಿವ್ ಬಂದಿದ್ದಕ್ಕೆ ಈ ರಿಯಾಕ್ಷನ್ ನಾನ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ಅಂತ ಅರ್ಥ ಮಾಡಿಕೋಬೇಕು. ಬಿಕಾಸ್ ಈ ರಿಯಾಕ್ಷನ್ ನಾನ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ಆಗಿದ ಕಾರಣ ನಾನೇನು ಮಾಡಬೇಕಂದ್ರೆ ರಿವರ್ಸ್ ರಿಯಾಕ್ಷನನ್ನು ಸ್ಪಾಂಟೇನಿಯಸ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋಬೋದು. ಅಂದರೆ m+2 x-2 ಗಿವ್ಸ್ ರೈಸ್ ಟು m+x ಈಸ್ ಆ್ಯಕ್ಚುಲಿ ಸ್ಪಾಂಟೇನಿಯಸ್. ಸೊ ಆಪ್ಷನ್ ನಂಬರ್ 4 ಈಸ್ ದ ಸ್ಪಾಂಟೇನಿಯಸ್ ರಿಯಾಕ್ಷನ್. ದ ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. The next question is, molar conductivities of divalent cation and anion are. Divalent cation m+2 ಅನ್ಕೋ, ಇದಕ್ಕೆ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಕೊಟ್ಟಿದ್ದಾರೆ which equals 57 Siemen centimeter square mole inverse. ಹಾಗೆ divalent anion x-2 lambda m 73. ಈಗ ಕ್ವೆಶ್ಚನ್ ಏನು, ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಆಫ್ ಸೊಲ್ಯೂಷನ್. ಈ ಕ್ವೆಶ್ಚನಲ್ಲಿ ಮಿಸ್ಟೇಕ್ ಏನಂದರೆ ಕೋಲ್ಡ್-ರಾಸ್ ಲಾ ಅಪ್ಲೈ ಮಾಡಬೇಕು. ಬಟ್ ಕೋಲ್ಡ್-ರಾಸ್ ಲಾ ಅಪ್ಲೈ ಮಾಡಬೇಕಂದ್ರೆ ಅವು ಲಿಮಿಟಿಂಗ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟೀಸ್ ಆಗಬೇಕು. ಇವಾಗ m+2 ಮತ್ತು x-2 ಕಂಬೈನ್ ಆದಾಗ ಬರುವಂತಹ ಎಲೆಕ್ಟ್ರೋಲೈಟಿನ ಫಾರ್ಮುಲಾ ಏನು, mx. ದೇರ್ಫಾರ್ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ m ಈಕ್ವಲ್ಸ್ ಏನಾಗುತ್ತೆ, ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ m ಆಫ್ m+2 ಪ್ಲಸ್ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ m ಆಫ್ x-2. ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ m ಆಫ್ m+2 ಏನಿದೆ 57, x-2 73. What is the sum? 57 plus 73, 130. Siemen centimeter square mole inverse is the answer. ಕ್ವೆಶ್ಚನ್ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, ಡೈವ್ಯಾಲೆಂಟ್ ಕ್ಯಾಟಯಾನ್ ಅಂದರು, ನಾನು m+2 ಅಂದ್ಕೊಂಡಿದ್ದೀನಿ. ಡೈವ್ಯಾಲೆಂಟ್ ಆನಯಾನ್ ಅಂದರು, x-2 ಅಂದ್ಕೊಂಡಿದ್ದೀನಿ. ಇದರದ್ದು ಫಾರ್ಮುಲಾ ಇದರದ್ದು ವ್ಯಾಲ್ಯೂ 57, ಅದರ ವ್ಯಾಲ್ಯೂ 73. ಈಗ ಸಾಲ್ಟ್ಗೆ, ಆ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ಗೆ ಎಷ್ಟು ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ m ಇರುತ್ತೆ ಅನ್ನೋದು ಕ್ವೆಶ್ಚನ್. ಅಕಾರ್ಡಿಂಗ್ ಟು ಕೋಲ್ಡ್-ರಾಸ್ ಲಾ ಫಸ್ಟ್ ನಾನು ಕ್ರಿಸ್ ಕ್ರಾಸ್ ರೂಲ್ ಅಪ್ಲೈ ಮಾಡಿ m+2 x-2 ಅಂದರೆ ರಿಯಲಿ ಕ್ರಿಸ್ ಕ್ರಾಸ್ ರೂಲ್ ಅಪ್ಲಿಕಬಲ್ ಆಗಲ್ಲ. ಬಟ್ m+2 x-2 ಕಂಬೈನ್ ಮಾಡಿದ್ದಾಗ mx ಅನ್ನುವ ಒಂದು ಫಾರ್ಮುಲಾ ಬರುತ್ತೆ. ಆ ಫಾರ್ಮುಲಾಗೆ ಕೋಲ್ಡ್-ರಾಸ್ ಲಾ ಅಪ್ಲೈ ಮಾಡಿದರೆ ಇದರ m+2 ಪ್ಲಸ್ x-2 57 ಪ್ಲಸ್ 73 130 ಬರ್ತಾ ಇದೆ. ಸೊ ದಿ ಫೈನಲ್ ಆನ್ಸರ್ ಇಸ್ 130. Next question. For a strong electrolyte, a plot of molar conductivity against concentration to the power half, andre lambda m versus root c. E graph is a straight line. Adu strong electrolyte alva, obviously adu straight line irutte. Avaru ಏನು ಕೇಳ್ತಿದ್ದಾರೆ ಅಂದರೆ ವಿತ್ ಎ ನೆಗೆಟಿವ್ ಸ್ಲೋಪ್ ಬಗ್ಗೆ ಮಾತಾಡ್ತಿದ್ದಾರೆ. ನೆಗೆಟಿವ್ ಸ್ಲೋಪ್ ಅದು ಕೂಡ ಕರೆಕ್ಟೇ. ಆ್ಯಂಡ್ ನೌ ದ ಕ್ವೆಶ್ಚನ್ ಈಸ್ ದ ಕರೆಕ್ಟ್ ಯೂನಿಟ್ ಆಫ್ ಸ್ಲೋಪ್ ಇಸ್ ಸ್ಲೋಪಿಗೆ ಯೂನಿಟ್ ಏನು ಅನ್ನೋದು ಕ್ವೆಶ್ಚನ್. ಗ್ರಾಫ್ ಆಫ್ ಲ್ಯಾಂಬ್ಡಾ ಎಮ್ ರೂಟ್ ಸಿ ಫಾರ್ ಅ ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ತಗೊಂಡಿದ್ದಾಗ ಇಟ್ ಈಸ್ ಅ ಸ್ಟ್ರೈಟ್ ಲೈನ್ ವಿತ್ ಅ ನೆಗೆಟಿವ್ ಸ್ಲೋಪ್. ಇವಾಗ ಈ ನೆಗೆಟಿವ್ ಸ್ಲೋಪ್ದೊಂದಿಗೆ ಇರುವ ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಇದಕ್ಕೆ ನಮಗೆ ಯೂನಿಟ್ ಏನು ಅನ್ನೋದು ಕ್ವೆಶ್ಚನ್. ಸೊ ಲೆಟ್ ಅಸ್ ಸ್ಟಾರ್ಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಟು ಸಾಲ್ವ್ ದಿಸ್. ಸೊ ಲ್ಯಾಂಬ್ಡಾ ಎಮ್ ವರ್ಸಸ್ ರೂಟ್ ಸಿ ಇಸ್ ಅ ಸ್ಟ್ರೈಟ್ ಲೈನ್ ಅಂತ ಹೇಳ್ತಿದ್ದಾರಲ್ವಾ, ಅದರಿಗೋಸ್ಕರ ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂತಂದರೆ, ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಗ್ರಾಫ್ ಅಂದರೆ ಈ ಗ್ರಾಫ್ ಏನಿದೆ ಇದನ್ನು ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡುವ ಒಂದು ಈಕ್ವೇಷನ್ ಇದೆ ನಮ್ಮ ಹತ್ತಿರ, ಡಿಬೈ ಹಕಲ್ ಆನ್ ಸ್ಯಾಗರ್ ಈಕ್ವೇಷನ್. ಲ್ಯಾಂಬ್ಡಾ ಎಮ್ ಈಕ್ವಲ್ಸ್ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಮೈನಸ್ ಎ ರೂಟ್ ಸಿ. ಇದು ಆ್ಯಕ್ಚುಲಿ ಎಲ್ಲಿ ಕೂಡ ಡಿಬೈ ಹಕಲ್ ಆನ್ ಸ್ಯಾಗರ್ ಅನ್ನುವ ವರ್ಡ್ಸ್ ಕೊಟ್ಟಿಲ್ಲ, ಬಟ್ ಜಸ್ಟ್ ಐ ಮೆನ್ಷನಿಂಗ್ ದ್ಯಾಟ್ ಇಟ್ ಈಸ್ ದ್ಯಾಟ್ ಈಕ್ವೇಷನ್. And now lambda m equals lambda naught m minus a root c ಅನ್ನೋದು ಈಕ್ವೇಷನ್ ಆದರೆ, if I apply y equals mx plus c format to this, then the slope m is none other than minus a. Therefore a ಗೆ ಯೂನಿಟ್ ಕೇಳ್ತಿದ್ದಾರೆ ಇವರು. a ಗೆ ಯೂನಿಟ್ ಯಾವ ಥರ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಂದ್ರೆ, lambda m equals lambda naught m minus a root c ಅಲ್ವಾ, ಅದಕ್ಕೆ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಅನ್ನು ಈ ಕಡೆ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡೋಣ. ಲ್ಯಾಂಬ್ಡಾ ಎಮ್ ಮೈನಸ್ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಈಕ್ವಲ್ಸ್ ಮೈನಸ್ ಎ ರೂಟ್ ಸಿ. ಮೈನಸ್ ಈ ಕಡೆ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡೋಣ. ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಮೈನಸ್ ಲ್ಯಾಂಬ್ಡಾ ಎಮ್ ಈಕ್ವಲ್ಸ್ ಎ ರೂಟ್ ಸಿ. ಈಗ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಮೈನಸ್ ಲ್ಯಾಂಬ್ಡಾ ಎಮ್ ಡಿವೈಡೆಡ್ ಬೈ ರೂಟ್ ಸಿ ಬರೆಯೋಣ. ಎ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಫಾರ್ಮುಲಾ ಇದು. ಇದರಿಂದ ಯೂನಿಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಣ. ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ಗೆ ಯೂನಿಟ್ ಸೀಮನ್ ಸೆಂಟಿಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಮೋಲ್ ಇನ್ವರ್ಸ್. ಲ್ಯಾಂಬ್ಡಾ ಎಮ್ಗೆ ಕೂಡ ಅದೇ, ಸಬ್ಟ್ರಾಕ್ಷನ್ ಕೂಡ ಅದೇ ಬರುತ್ತೆ. ಸೊ ನ್ಯೂಮರೇಟರ್ನಲ್ಲಿ ಸೀಮನ್ ಸೆಂಟಿಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಮೋಲ್ ಇನ್ವರ್ಸ್ ಆದರೆ ರೂಟ್ ಸಿ ಕೆಳಗಡೆ ಅಂದರೆ ಮೋಲ್ ಪರ್ ಲೀಟರ್, ಮೋಲ್ ಪರ್ ಲೀಟರ್ ಹೋಲ್ ಪವರ್ ಹಾಫ್. ಬಟ್ ಲೀಟ್ರ್ ಹಾಕಿದರೆ ಆಗಲ್ಲ, ಯಾಕಂದರೆ ಇಲ್ಲಿ ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಅಥವಾ ಸೆಂಟಿಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಬಗ್ಗೆ ಮಾತಾಡ್ತಾ ಇದೆ. ಸೊ ಇಲ್ಲಿ ಕೂಡ ಅದೇ ಬರುತ್ತೆ, ಸೆಂಟಿಮೀಟರ್, ಮೋಲ್ ಪರ್ ಸೆಂಟಿಮೀಟರ್ ಕ್ಯೂಬ್ ಬರುತ್ತೆ. ಯಾಕೆಂದರೆ 1 ಲೀಟರ್ಗೆ 1000 ಸೆಂಟಿಮೀಟರ್ ಕ್ಯೂಬ್ ಬರ್ತವೆ. ಇಲ್ಲಿ ಕನ್ವರ್ಷನ್ ಮಾಡುವ ಅವಶ್ಯಕತೆ ಇಲ್ಲ, ಯೂನಿಟ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ರೆ ಸಾಕು. ಈಗ ಏನು ಮಾಡಬೇಕಿದನ್ನು, ಸೀಮನ್ ಸೆಂಟಿಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಮೋಲ್ ಇನ್ವರ್ಸ್ divided by mole power half divided by centimeter 3/2. Then I'll transfer this to the numerator. That becomes Siemen centimeter square mole inverse, and then I also carry this here, mole power minus half centimeter minus 3/2. Siemen centimeter square 2 minus 3/2 is actually minus half. So minus half, mole minus 1 minus half is minus 3/2. Is the unit for A. ಇನ್ನೊಂದ್ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಇದಕ್ಕೆ ಯೂನಿಟ್ ಸೀಮನ್ ಸೆಂಟಿಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಮೋಲ್ ಇನ್ವರ್ಸ್, ಇದಕ್ಕೆ ಯೂನಿಟ್ ಸೀಮನ್ ಮೋಲ್ ಪರ್ ಸೆಂಟಿಮೀಟರ್ ಕ್ಯೂಬ್ ಅಂತ ಅಂದ್ಕೊಂಡ್ರೆ, ಅಂದರೆ ಪರ್ ಲೀಟ್ರ್ ಅಲ್ವಾ, ಲೀಟ್ರನ್ನು ಸೆಂಟಿಮೀಟರ್ ಕ್ಯೂಬ್ ಬರೀತಾ ಇದ್ದಾನೆ, ಯಾಕೆಂದರೆ ಇಲ್ಲಿ ಒಂದೇ ಯೂನಿಟ್ ಇರಬೇಕಲ್ಲ. ಅದಕ್ಕೆ ಸೀಮನ್ ಸೆಂಟಿಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಮೋಲ್ ಇನ್ವರ್ಸ್ ಬರೆದು ಡಿವೈಡೆಡ್ ಬೈ ಮೋಲ್ ಪವರ್ ಹಾಫ್ ಡಿವೈಡೆಡ್ ಬೈ ಸೆಂಟಿಮೀಟರ್ ಪವರ್ 3/2 ಅಂತ ಬಂದಿದೆ. ಸೊ ನಾನು ಸಪ್ರೇಟ್ ಮಾಡಿದ್ದೀನಿ, ಅದಕ್ಕೆ ಆ ಹಾಫ್ ಇಲ್ಲಿ ಕೂಡ ಅಪ್ಲೈ ಆಗುತ್ತಲ್ವ, ಸೀಮನ್ ಸೆಂಟಿಮೀಟರ್ ಪವರ್ 3/2 ಬರುತ್ತೆ. ಆ್ಯಂಡ್ ನಾನು ಇದನ್ನು ಏನು ಮಾಡಿದ್ದೀನಿ, ಐ ಕ್ಯಾರಿಡ್ ಇಟ್ ಟು ದ ನ್ಯೂಮರೇಟರ್. ವೆನ್ ಐ ಕ್ಯಾರಿ ಇಟ್ ಟು ದ ನ್ಯೂಮರೇಟರ್ ಇಟ್ ಬಿಕಮ್ಸ್ ಸೀಮನ್ ಸೆಂಟಿಮೀಟರ್ ಪವರ್ 3/2. ಇದು ಮೇಲೆಗೆ ಹೋಗಿಬಿಟ್ರೆ ನಮಗೆ 3/2 ಹಾಗೇ ಇರುತ್ತೆ. ಇದು I should keep it as 3/2, not minus 3/2. Then it becomes 3/2 plus 2. 3/2 plus 2 is 2 2s are 4, 7/2. It will remain as 7/2. and then mole power minus 3 by 2 ಆಗುತ್ತೆ ಇದು. So this is how we solve this question. Let's go to the next question. When we consider the next question, what pressure of hydrogen would be required to make EMF of hydrogen electrode 0 in pure water at 25 degrees Celsius is the question. I repeat the question to understand it better. What pressure of hydrogen? What is the pressure of hydrogen to be required to make EMF of hydrogen electrode? Hydrogen electrode in EMF anna 0 in pure water. ಮಾಡಬೇಕಂದ್ರೆ at 25 degrees Celsius what is the pressure due to hydrogen ಅಂತಿದ್ದಾರೆ. ಹೈಡ್ರೋಜನ್ ಎಲೆಕ್ಟ್ರೋಡ್ದು ಎಲ್ಲ ಹೆಂಗಾದರೂ ಕೂಡ ಪ್ರೆಷರ್ ಅನ್ನೋ ಇ ಎಮ್ ಎಫ್ ಅನ್ನೋದು ಝೀರೋನೇ ಇರುತ್ತಲ್ವ. ಮತ್ತೀಗ ಸ್ಪೆಷಾಲಿಟಿ ಏನು ಅಂತಂದರೆ ಹೈಡ್ರೋಜನ್ ಎಲೆಕ್ಟ್ರೋಡ್ದು ಹೆಂಗಾದರೂ ಝೀರೋ ಇರುತ್ತೆ, ಬಟ್ ಅದು 1 molar HClನಲ್ಲಿ. ಬಟ್ ಇವಾಗ ಇದು ವಾಟರ್ನಲ್ಲಿ H+ ಅಯಾನ್ಸ್ನೊಂದಿಗೆ ಆಗಬೇಕು. ಅದಕ್ಕೆ ನಾನು ಹೈಡ್ರೋಜನ್ ಎಲೆಕ್ಟ್ರೋಡ್ಗೆ ಸಂಬಂಧಪಟ್ಟಂಥ ನರ್ನ್ಸ್ಟ್ ಈಕ್ವೇಷನನ್ನು ಬರೀತಾ ಇದ್ದೀನಿ. ಅದು ಬರೆದ್ರೆ ಈ ಎಲೆಕ್ಟ್ರೋಡ್ ಈಕ್ವಲ್ಸ್ E0 ಮೈನಸ್ 0.059/n ಲಾಗ್ ಅಂದರೆ ನಾರ್ಮಲ್ ನರ್ನ್ಸ್ಟ್ ಈಕ್ವೇಷನ್ ಬರೆದಾಗ ಮೋಲಾರ್ m/m+n ಇದು ರಿಡಕ್ಷನ್ಗೆ ಸಂಬಂಧಪಟ್ಟಂಥ ಸಿಂಗಲ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಷಿಯಲ್. ಇದು ಹೈಡ್ರೋಜನ್ಗೆ ಅಪ್ಲೈ ಮಾಡಿದ್ದೀವಿ ಅಂತ ಅನ್ಕೋ, ಆವಾಗ ಈ ಥರ ಇರುತ್ತೆ ಈಕ್ವೇಷನ್. ಸೊ ನರ್ನ್ಸ್ಟ್ ಈಕ್ವೇಷನ್ ಅಪ್ಲೈ ಮಾಡೋಣ. E ಮೈನಸ್ 0, E0 ಅನ್ನೋದು 0 ಅಲ್ವಾ ಹೈಡ್ರೋಜನ್ ಎಲೆಕ್ಟ್ರೋಡ್ಗೆ. n ವ್ಯಾಲ್ಯೂ 1 ಲಾಗ್. ಇದು ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್, ಸಾಲಿಡ್ ಲಿಕ್ವಿಡ್ ಅಲ್ಲ 1 ಹಾಕಲಿಕ್ಕೆ, ಗ್ಯಾಸ್ ಇದು. ಪ್ರೆಷರ್ ಡ್ಯೂ ಟು ಹೈಡ್ರೋಜನ್ ಟು ದ ಪವರ್ ಹಾಫ್ ಡಿವೈಡೆಡ್ ಬೈ H+ ಅಯಾನ್ ಕಾನ್ಸಂಟ್ರೇಷನ್. E ಈಕ್ವಲ್ಸ್ ಮೈನಸ್ 0.059 ಲಾಗ್ pressure due to hydrogen divided by H+ ion concentration. ಇದು equation to be utilized here. ಈ ಈಕ್ವೇಷನನ್ನು ಯೂಸ್ ಮಾಡಲಿಕ್ಕೆ ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂತಂದರೆ, ಇಲ್ಲಿ H+ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು, pH2 ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಂದ್ರೆ E ಅನ್ನೋದು 0 ಆಯಿತು ಅಂತ ಅವರೇ ಹೇಳಾರೆ. ದೇರ್ಫೋರ್ 0 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀನಿ. ಮೈನಸ್ 0.059 log pressure due to hydrogen to the power half H+ ion concentration. ಇದು ಆ ಕಡೆ ಹೋಗಿ 0 ಆಗಿಬಿಡುತ್ತೆ. log pressure due to hydrogen to the power half divided by H+ ion concentration is 0. log pressure due to hydrogen to the power half H+ ion concentration in pure water at 25 degrees Celsius according to ionic product of water is 10 to the power minus 7. So I will substitute that. Then antilog. Antilog 0 is 1. Pressure due to hydrogen to the power half is minus 7. Then pressure due to hydrogen is 10 to the power minus 14. This is what we get as a result. ಇನ್ನೊಂದ್ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ಇಲ್ಲೇನು ಹೇಳ್ತಿದ್ದಾರೆ, ಪ್ರೆಷರ್ ಡ್ಯೂ ಟು ಹೈಡ್ರೋಜನ್ ಎಷ್ಟು ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. EMF ಅನ್ನೋದು 0 ಆಗ್ತಾ ಇದೆ ಎಲೆಕ್ಟ್ರೋಡ್ಗೆ, ಬಟ್ ಇನ್ ಪ್ಯೂರ್ ವಾಟರ್ ಅನ್ನೋದು ಕ್ವೆಶ್ಚನ್ ಇಲ್ಲಿ. ನಾನೇನು ಮಾಡಿದ್ದೀನಿ, ಸಿಂಗಲ್ ಎಲೆಕ್ಟ್ರೋಡ್ ಪೊಟೆನ್ಷಿಯಲ್ಗೆ ನರ್ನ್ಸ್ಟ್ ಈಕ್ವೇಷನ್ ಬರೆದು ಅದನ್ನು ಹೈಡ್ರೋಜನ್ ಎಲೆಕ್ಟ್ರೋಡ್ಗೆ ಅಪ್ಲೈ ಮಾಡಿದ್ದೀನಿ. ಆವಾಗ ಎಲೆಕ್ಟ್ರೋಡಿನ E0 ವ್ಯಾಲ್ಯೂ 0 ಆಗುತ್ತೆ, ಇದು 0, n ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ 1 ಆಗುತ್ತೆ. ಪ್ರೆಷರ್ ಡ್ಯೂ ಟು ಹೈಡ್ರೋಜನ್ ಟು ದ ಪವರ್ ಹಾಫ್ ಬೈ H ಪ್ಲಸ್ ಅಯಾನ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಬರೀಬೇಕು. ಬರೆದು -0.059 ಲಾಗ್ ಪ್ರೆಷರ್ ಡ್ಯೂ ಟು ಹೈಡ್ರೋಜನ್ ಟು ದ ಪವರ್ ಹಾಫ್ ಬೈ H ಪ್ಲಸ್ ಅಯಾನ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಬರುತ್ತೆ. ಇವಾಗ ಇದೆಲ್ಲ ಆ ಕಡೆ ಹೋಗಿಬಿಟ್ರೆ ಅದು 0 ಆಗುತ್ತೆ. ಆ್ಯಂಡ್ ಆ್ಯಂಟಿಲಾಗ್ 0 ಇಸ್ 1. Therefore, pressure due to hydrogen by 10 power minus 7 is 1. I'll send it there. It becomes pressure due to hydrogen as 10 to the power minus 14 is the question. Let's go to the next question. ಇವಾಗ ಕ್ವೆಶ್ಚನ್ ಏನಂತಂದರೆ, ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಆಫ್ X% mass by mass mx solution is 123.5 Siemens centimeter square mole inverse. The conductance of same solution is G 1.9 into 10 to the power minus 3 Siemens. The value of X is, X andre idu ಎಷ್ಟು, ಸೆಲ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದರೆ L/A 1.3. ಮೋಲಾರ್ ಮಾಸ್ ಆಫ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ 75 ಗ್ರಾಮ್ ಪರ್ ಮೋಲ್. ಡೆನ್ಸಿಟಿ 1. ಇಷ್ಟು ಡೀಟೇಲ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಕ್ವೆಶ್ಚನ್ ಏನಿಲ್ಲಿ, ಕ್ವೆಶ್ಚನ್ನಲ್ಲಿ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಆಫ್ X% W/W ಮಾಸ್ ಪರ್ಸೆಂಟೇಜ್ ಇರುವ mx ಅನ್ನುವ ಎಲೆಕ್ಟ್ರೋಲೈಟಿನ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ 123.5 ಇದ್ದರೆ ಅದರ ಕಂಡಕ್ಟೆನ್ಸ್ ಎಷ್ಟಿದ್ದರೆ ಆವಾಗ ಎಕ್ಸ್ ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು, L/A ಕೊಟ್ಟಿದ್ದಾರೆ, ಇದೆಲ್ಲ ಕೊಟ್ಟಿದ್ದಾರೆ. ನನಗೆ ಲ್ಯಾಂಬ್ಡಾ ಎಮ್ ಕೊಟ್ಟಿದ್ದಕ್ಕೆ ಒಂದು ಫಾರ್ಮುಲಾ ನೆನಪು ಬರ್ತಾ ಇದೆ. ಲ್ಯಾಂಬ್ಡಾ ಎಮ್ ಈಕ್ವಲ್ಸ್ K × 1000/C. ಇದರಲ್ಲಿ ಕಂಡಕ್ಟಿವಿಟಿ ಕೊಟ್ಟಿಲ್ಲ ಹಾಕಲಿಕ್ಕೆ, ಇದರಲ್ಲಿ ಕಂಡಕ್ಟಿವಿಟಿ ಹಾಕಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ತರ್ಬೋದು, ಮೋಲಾರಿಟಿ. ಆವಾಗ ಮೋಲಾರಿಟಿಯನ್ನು ಬೇಕಾದರೆ ಪರ್ಸೆಂಟೇಜಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ನಾನೇನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಇಲ್ಲಿ, ಕೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀನಿ ಫಸ್ಟ್. ಫ್ರಮ್ ದ ಫಾರ್ಮುಲಾ G ಈಕ್ವಲ್ಸ್ K × 1/L/A ಅನ್ನುವ ಫಾರ್ಮುಲಾದಿಂದ ನಾವು ಕೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಣ. G is 1.9 into 10 to the power minus 3. L/A, whatever we have here, is actually 1.3. 1.9 into 10 to the power minus 3 into 1.3 equals K. 1.9 into 1.3. 24.7. (2.47) into 10 to the power minus 3 Siemens per centimeter. ಈ ಕೆ ತಗೊಂಡು ಹೋಗಿ ಅಲ್ಲಿ ಹಾಕೋಣ, ಆವಾಗ ಸಿ ಬರುತ್ತೆ. C is in molarity, no? ಇದು ನನಗೆ ಮೋಲಾರ್ನಲ್ಲಿ ಬರುತ್ತೆ. K is 2.47 into 10 power minus 3 into 10 power 3 divided by lambda m 123.5. I can also write it as, it gets cancelled, by 1.235 into 10 to the power 2. ಈ ತರಹ ಬರೆದ್ರೆ ಇದು ಇದರಲ್ಲಿ 2 ಟೈಮ್ಸ್ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. 2 into 10 power minus 2 ಅಂದರೆ 0.02 ಮೋಲಾರ್. ಇವಾಗ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎಕ್ಸ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಲ್ವಾ, ಅದರಿಗೋಸ್ಕರ ಮೊಲಾರಿಟಿ ಫಾರ್ಮುಲಾದಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಮೊಲಾರಿಟಿ ಈಕ್ವಲ್ಸ್ W by M into 1000 divided by volume of the solution. Molarity is 2 into 10 to the power minus 2. Mass of the solute in X% is X grams in 100 grams of solution. So, ಇದು mass of the solute X. Molar mass ಅವರೇ ಕೊಟ್ಟಿದ್ದಾರೆ 75 into 1000 divided by ವಾಲ್ಯೂಮ್ ಆಫ್ ದ ಸೊಲ್ಯೂಷನನ್ನು ಡೆನ್ಸಿಟಿರಿಂದ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಡೆನ್ಸಿಟಿ 1 ಆಗಿದ್ದಕ್ಕೆ ಮಾಸ್ ಆ್ಯಂಡ್ ವಾಲ್ಯೂಮ್ ವಿಲ್ ರಿಮೈನ್ ಸೇಮ್. ಸೊ ಇಟ್ ಬಿಕಮ್ಸ್ 100. Then 100 in 1000 for 10 times, 2 into 10 to the power minus 2 into 75 divided by 10 is what I get. That means 75 is 150 into 10 to the power minus 3, because 10 malak bandre. That means it is 0.15. The value of x is 0.15 is what I get. So I am going to explain the same thing again. Let's take a look at that. In order to calculate x value, ಫಸ್ಟ್ ನಾನು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಣ ಅಂತ ಹೇಳಿ ಲ್ಯಾಂಬ್ಡಾ ಎಮ್ಗೆ ಫಾರ್ಮುಲಾ ಹಾಕಿದ್ದೀನಿ. ಲ್ಯಾಂಬ್ಡಾ ಎಮ್ ಫಾರ್ಮುಲಾದಲ್ಲಿ ಹಾಕಲಿಕ್ಕೆ ಕೆ ಬೇಕು. ಕೆ ಬೇಕಲ್ವಾ, ಅದಕ್ಕೆ ಜಿ ಈಕ್ವಲ್ಸ್ ಕೆ ಇಂಟು 1/L/A ಬರೆದು ಜಿ ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ದೀನಿ. ಕೆ ವ್ಯಾಲ್ಯೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ L/A ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ದೀನಿ. 1/3 ಆ ಕಡೆ ಹೋದರೆ 2.47 ಇಂಟು 10 power minus 3 ಬಂತು. ಇದನ್ನು ನಾನು ತೊಗೊಂಡು ಹೋಗಿ ಇಲ್ಲಿ ಹಾಕಿದ್ದೀನಿ. ಹಾಕಿದ್ದಾಗ ಅದು ಕ್ಯಾನ್ಸಲ್ ಆಗಿದ್ದಾವೆ. 2.47 by 123 ಬಂತು, ಅದು 0.02 ಮೋಲಾರ್ ಬಂದಿದೆ. ಇದರಿಂದ ಮೊಲಾರಿಟಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ W by M into 1000 by V ಫಾರ್ಮುಲಾ ಹಾಕಿದ್ದೀನಿ. ಮೊಲಾರಿಟಿ 2 into 10 power minus 2. ಎಕ್ಸ್ ಅಂದರೆ ಎಕ್ಸ್ ಗ್ರಾಮ್ಸ್ ಇನ್ 100 grams ಆಫ್ ಸೊಲ್ಯೂಷನ್. ಸೊಲ್ಯೂಷನಿನ ಮಾಸೆ ವಾಲ್ಯೂಮ್ ಕೂಡ 100 milliliter. 100 in 1000 is for 10 times. Therefore 10 ಕೆಳಗಡೆ ಬಂದರೆ 2 into 75 is 150. 150 into 10 power minus 3 is 0.15. So this is what we get as an answer to this question. Let's move to the next part. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. ಈ ಕ್ವೆಶ್ಚನ್ನಲ್ಲಿ ಎಲೆಕ್ಟ್ರೋಕೆಮಿಕಲ್ ಸೆಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಒಂದು, ವೇರ್ M+X/M /Fe+3F ಅಂದರೆ ಇದು ಕೊಟ್ಟಿಲ್ಲ, ಈ ಥರ ಏನು ಕೊಟ್ಟಿಲ್ಲ, ಬಟ್ ಜಸ್ಟ್ ಇದರ E0 ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಪ್ಲಸ್ 0.15. ಎರಡನೇದು Fe+3 to Fe ಕೊಟ್ಟಿದ್ದಾರೆ, ಅದರ E0 ವ್ಯಾಲ್ಯೂ ಮೈನಸ್ 0.036. ಸೆಲ್ EMF ಕೊಟ್ಟಿದ್ದಾರೆ, ಈ ಸೆಲ್ 0.2057 volt. If the reaction quotient of the electrochemical reaction is found to be 10 to the power minus 2. Reaction quotient is 10 to the power minus 2. Value of X ಎಷ್ಟು ಅಂದರೆ ಈ ಚಾರ್ಜ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಆ ಚಾರ್ಜ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಂದ್ರೆ ಅದು ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ನಲ್ಲಿ ಇನ್ವಾಲ್ವ್ ಆಗಿರುತ್ತೆ. ಅಂದರೆ ನರ್ನ್ಸ್ ಈಕ್ವೇಷನ್ ಬರೆಯಬೇಕು ಇದಕ್ಕೆ. ನರ್ನ್ಸ್ಟ್ ಈಕ್ವೇಷನ್ ಬರೆದ್ರೆ ಇ ಸೆಲ್ ಈಕ್ವಲ್ಸ್ ಇ ನಾಟ್ ಸೆಲ್ ಮೈನಸ್ 0.059 ಬೈ ಎನ್ ಲಾಗ್ ಕ್ಯೂ ಅನ್ನೋದು ಈಕ್ವೇಷನ್. ಈ ಸೆಲ್ ವ್ಯಾಲ್ಯೂ ಅವರೇ ಕೊಟ್ಟಾರೆ 0.2057. ಇ ನಾಟ್ ಸೆಲ್ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಇ ನಾಟ್ ಸೆಲ್ ಈಕ್ವಲ್ಸ್ ಇ ನಾಟ್ ಕ್ಯಾಥೋಡ್ ಮೈನಸ್ ಇ ನಾಟ್ ಆ್ಯನೋಡ್ or higher minus lower. Higher is 0.15 minus of minus 0.036. 0.15 plus 0.036 which is 0.186 volt. Substitute ಮಾಡಿದರೆ 0.186 minus 0.059 by n ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಿಲ್ಲ, ಡಿಫರೆನ್ಸ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬರಲ್ಲ. ಸೊ ಲಾಗ್ q ವ್ಯಾಲ್ಯೂ 10 to the power minus 2. ನಾನು ಇದನ್ನು ಈ ಕಡೆ ಕಳಿಸ್ತೀನಿ. 0.2057 minus 0.186 equals minus 0.59 by log 10 to the power minus 2. ಇದು ಸಬ್ಟ್ರಾಕ್ಷನ್ ಮಾಡೋಣ. 0.2057 minus 0.186 7. 15 minus 6 is 9. 9 minus 8 is 1. That's it. 0.0197. 0.0197 ಅನ್ನು 0.02 ಬರೆಯೋಣ. ಇದನ್ನು 0.06 ಬರೆಯೋಣ. 59 ಅನ್ನು n ಲಾಗ್ 10 ಪವರ್ ಮೈನಸ್ 2 ಅಂದರೆ ಮೈನಸ್ 2. ಈಗ n ವ್ಯಾಲ್ಯೂ ಈಕ್ವಲ್ 0.06 ಇಂಟು 2 ಬೈ 0.02 ಅಂದರೆ 6 ಬರುತ್ತೆ. ನಮಗೆ ಬೇಕಾಗಿದ್ದು n ವ್ಯಾಲ್ಯೂ ಅಲ್ಲ, ಎಕ್ಸ್ ವ್ಯಾಲ್ಯೂ. ಎಕ್ಸ್ ವ್ಯಾಲ್ಯೂ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ನೆಕ್ಸ್ಟ್ ಏನು ಮಾಡಬೇಕಂದ್ರೆ ಈ ಎರಡಕ್ಕೂ ಮಧ್ಯದಲ್ಲಿ ರಿಯಾಕ್ಷನನ್ನು ಯೋಚನೆ ಮಾಡಿ ಒಂದು ಸಲ. Fe ಪ್ಲಸ್ 3 ಆಗ್ತಾ ಇದೆ. ಸೊ ಇಲ್ಲಿ ಡಿಫರೆನ್ಸ್ ಅನ್ನೋದು ಎಷ್ಟು ಬರ್ಬೋದು ನಮಗೆ ಗೊತ್ತಿರೋ ಮಟ್ಟಕ್ಕೆ 0 ಇದೆ ಇಲ್ಲಿ ಎಕ್ಸ್ ವ್ಯಾಲ್ಯೂ. ನನಗೆ 6 ಬರಬೇಕು. ಅಲ್ಲಿ 6 ಬರ್ತಾ ಇದೆ ಅಂದರೆ ಇಲ್ಲಿ 3 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅದಾವಂದರೆ ಇಲ್ಲಿ ಖಂಡಿತ 2 ಇರಬೇಕು. ಆವಾಗ ಈಕ್ವೇಷನ್ ಏನಾಗುತ್ತೆ, m ಪ್ಲಸ್ 2 ಪ್ಲಸ್ Fe ಪ್ಲಸ್ 3 ಗಿವ್ಸ್ ರೈ ಆರ್ m ಪ್ಲಸ್ 2 ಪ್ಲಸ್ Fe. ಆವಾಗ ಇದು 0 2 ಪ್ಲಸ್ 2 ಇದು ಪ್ಲಸ್ 3 ಇದು 3 ಇದು 0 3. ಆವಾಗ ಇದು ಇಂಟು 2 ಅಂಡ್ ಇಂಟು 3. ಆವಾಗ ತಾನೇ ನನಗೆ 6 ಬರೋದು. ಅದಕ್ಕೆ ಇದು 3 ಇದ್ದಾಗ 6 ಬರಬೇಕಂದ್ರೆ ಅದು 2 ಇರಲೇಬೇಕು. ಹಾಗಾಗಿ ಆನ್ಸರ್ ಇಸ್ 2. ಎಕ್ಸ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ 2. ಇನ್ನೊಂದು ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ನಮಗೆ m ಪ್ಲಸ್ ಎಕ್ಸ್ ಸ್ಲ್ಯಾಶ್ ಎಮ್ E naught is 0.15 volt. Fe plus 3 Fe E naught is minus 0.036 volt ಇದೆ. ಈ ಸೆಲ್ಲಿನ ವ್ಯಾಲ್ಯೂ 0.2057 ವೋಲ್ಟ್ ಇದೆ. ಕ್ಯೂ ವ್ಯಾಲ್ಯೂ 10 to the power minus 2 ಇದೆ. ಎಕ್ಸ್ ವ್ಯಾಲ್ಯೂ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಅದಕ್ಕೋಸ್ಕರ ನಾನು ನರ್ನ್ಸ್ಟ್ ಈಕ್ವೇಷನನ್ನು ಈ ತರಹ ಬರೆದಿದ್ದೀನಿ. ನರ್ನ್ಸ್ಟ್ ಈಕ್ವೇಷನಲ್ಲಿ ಇವೆಲ್ಲ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ದೀನಿ. ಮಾಡಿದ ಮೇಲೆ ಇದೆಲ್ಲ ಸಿಂಪ್ಲಿಫೈ ಮಾಡ್ತಾ ನನಗೆ ಎನ್ ವ್ಯಾಲ್ಯೂ 6 ಬಂದಿದೆ. ಎನ್ ವ್ಯಾಲ್ಯೂ 6 ಬರಬೇಕಂದ್ರೆ ಈಕ್ವೇಷನ್ ಹಿಂಗಿರಬೇಕು, ಅಂದರೆ ಎಮ್ ವ್ಯಾಲ್ಯೂ ಖಂಡಿತ 2 ಆಗಿರಬೇಕು. ದೇರ್ಫೋರ್ ದಿ ಆಪ್ಷನ್ ಇಸ್ 2. ಆನ್ಸರ್ ಇಸ್ 2. ಲೆಟ್ಸ್ ಗೋ ಟು ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. $250 milliliter of a waste solution obtained from the workshop of a goldsmith contains 0.1 molar silver nitrate and 0.1 molar gold chloride. Solution in a volume 250 milliliter. ಅದರಲ್ಲಿ 0.1 molar silver nitrate ಇದೆ, 0.1 molar ORS chloride ಇದೆ. The solution was electrolyzed at 2 volt by passing a current of 1 ampere. I value ಕೊಟ್ಟಿದ್ದಾರೆ 1 ampere. ನೆಕ್ಸ್ಟ್ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ, 15 ಮಿನಿಟ್ಸ್ಗೆ ಕಳಿಸಿದ್ದಾರೆ, ಟೈಮ್ 15 ಮಿನಿಟ್ಸ್. ಈಗ ಕ್ವೆಶ್ಚನ್ ಏನಂದರೆ ಆಪ್ಷನ್ಸ್ ಈ ಥರ ಕೊಟ್ಟಿದ್ದಾರೆ, ಯಾವುದು ಸೆಟಲ್ ಆಗತ್ತೆ ಬೇಗ ಅನ್ನೋದು ಕ್ವೆಶ್ಚನ್. ಒಂದು ಸಿಲ್ವರ್ and gold, B in equal proportion. Silver and gold in proportion to their atomic weights. Only gold, only silver. ಇದು ಕ್ವೆಶ್ಚನ್. ಇದಕ್ಕೆ ಸೆಕೆಂಡ್ ಲಾನ್ನು ಅಪ್ಲೈ ಮಾಡಿ ನೋಡಿದಾಗ ನಮಗೆ ಅರ್ಥ ಆಗುವ ವಿಷಯ ಏನು ಅಂತಂದರೆ, ಎರಡೂ ಕೂಡ ಈಕ್ವಲ್ ಪ್ರಪೋರ್ಷನಲ್ಲಿ ಸೆಟಲ್ ಆಗಲ್ಲ. ಬಿಕಾಸ್ ಯಾವುದಾದರೂ ಸೆಟಲ್ ಆಗಬೇಕು ಅಂತಂದರೆ ಡೆಫಿನೆಟ್ಲಿ ಅದರ ಈಕ್ವಿವಲೆಂಟ್ ಮಾಸ್ ಏನಿದೆ ಅದಕ್ಕೆ ಅದರ ಮಾಸ್ ಪ್ರಪೋರ್ಷನಲ್ ಆಗಿರುತ್ತೆ. ಸೊ ಈಕ್ವಲ್ ಪ್ರಪೋರ್ಷನ್ ಅನ್ನೋದು ತಪ್ಪು. ಎಟಾಮಿಕ್ ವೆಯ್ಟ್ಸಿನ ಪ್ರಪೋರ್ಷನ್ ಕೂಡ ತಪ್ಪೆ, ಯಾಕಂದರೆ ಅದು ಪ್ರಪೋರ್ಷನ್ ಆಫ್ ಈಕ್ವಿವಲೆಂಟ್ ವೆಯ್ಟ್ಸ್ ಪ್ರಕಾರ ಇರುತ್ತೆ, ನಾಟ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ಎಟಾಮಿಕ್ ವೆಯ್ಟ್ಸ್. ಈಗ ಎರಡಕ್ಕೂ ಕೂಡ ನಮಗೆ ವ್ಯಾಲ್ಯೂಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. E0 Ag ಪ್ಲಸ್ Ag ಈಸ್ 0.8 ವೋಲ್ಟ್, E0 Au ಪ್ಲಸ್ Au ಈಸ್ 1.69 ವೋಲ್ಟ್. ಎರಡೂರಲ್ಲಿ ಹೈಯರ್ ಪೊಟೆನ್ಷಿಯಲ್ ಇರೋದು ಗೋಲ್ಡ್ ಇರೋದರಿಂದ ಮೊದಲು ಗೋಲ್ಡ್ ಹೋಗುತ್ತೆ ಅನ್ನೋ ವಿಷಯವನ್ನು ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಆದರೆ ನಾವು ಬರೇ ಗೋಲ್ಡ್ ಬರುತ್ತೆ ಅಂತ ಕನ್ಕ್ಲೂಡ್ ಮಾಡಬಾರ್ದು. ಲೆಟ್ ಅಸ್ ಫೈಂಡ್ ಔಟ್ ಹೌ ಮಚ್ ಕರೆಂಟ್ ಈಸ್ ಸೆಂಟ್ ದೇರ್, ಹೌ ಮೆನಿ ಕೂಲೂಮ್ಸ್ ಆಫ್ ಎನರ್ಜಿ ಹ್ಯಾಸ್ ಗಾನ್, ಅದು ಫೈಂಡ್ ಔಟ್ ಮಾಡೋಣ. Q ಈಕ್ವಲ್ಸ್ 1 into 15 I into T into 60 ಅಂದರೆ 900 ಕೂಲೋಮ್ಸ್ ಬಂದಿದೆ. ಆ್ಯಕ್ಚುಲಿ 96,500 ಕೂಲೋಮ್ಸ್ಗೆ ಗೋಲ್ಡ್ ಎಷ್ಟು ಹೋಗುತ್ತೆ ಅಂತಂದರೆ, ಗೋಲ್ಡಿನ ಎಟಾಮಿಕ್ ಮಾಸ್ ನಮಗೆ ಬಂದುಬಿಟ್ಟು 197 ಇದೆ, ಗ್ರಾಮ್ಸ್ ಬರುತ್ತೆ. ಆದರೆ ಕಳಿಸಿದ್ದು ಬರೇ 900 ಕೂಲೋಮ್. ಅಂದರೆ ಎಷ್ಟು ಸೆಟಲ್ ಆಗಲಿಕ್ಕೆ ಅವಕಾಶ ಐತಿ? ಏಟ್ ಟೈಮ್ಸ್ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ. ಸೊ 1.8 ಗ್ರಾಮ್ಸ್ ಬರಲಿಕ್ಕೆ ಅವಕಾಶ ಇದೆ ಅಂತ ಅಂದ್ಕೊಳ್ಳೋಣ. ಇಲ್ಲಿಗೆ ಇಲ್ಲಿ ಇದರಲ್ಲಿ ಎಷ್ಟೈತೆ ಅದು ನೋಡಬೇಕಲ್ವಾ. ಇದರಲ್ಲಿ 250 ಮಿಲಿಲೀಟರ್ 0.1 ಮೋಲ್ಸ್ ಅಂದರೆ W ನಂಬರ್ ಆಫ್ ಮೊಲಾರಿಟಿ ಈಕ್ವಲ್ಸ್, ಇಲ್ಲಿ ಮಾಡೋಣ, ಮೊಲಾರಿಟಿ equals mass by molar mass into 1000 by volume, or number of moles ಕೂಡ ತಗೋಬೋದು ಡೈರೆಕ್ಟಾಗಿ. ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ತಗೋಬೇಕಂದ್ರೆ ಮೊಲಾರಿಟಿ ಇಂಟು ವಾಲ್ಯೂಮ್ ಬೈ 1000 ಮಾಡಬೇಕು. ಮೊಲಾರಿಟಿ 0.1, ವಾಲ್ಯೂಮ್ 250, 1000 ಬಂದ್ಬಿಟ್ಟು 1000 ಇದೆ ಇದರಲ್ಲಿ. ಸೊ ಇದು ಇದರಲ್ಲಿ 4 ಟೈಮ್ಸ್ ಆದರೆ ನಮಗೆ 0.025 ಮೋಲ್ಸ್ ಬರುತ್ತೆ. ಅಂದರೆ 0.2.5 ಇಂಟು 10⁻⁻² ಮೋಲ್ಸ್ ಇಷ್ಟು ಬರುತ್ತೆ. ನಮಗೆ 1.8 ಗ್ರಾಮ್ಸ್ ಬರಲಿಕ್ಕೆ ಅವಕಾಶ ಐತಿ. ಬಟ್ ಇದರಲ್ಲಿ ಎಷ್ಟು ಬರುತ್ತೆ ಅಂತ ನೋಡಿದರೆ 2.5 ಇಂಟು 10⁻⁻² ಇಂಟು 197, which means 4.9 ಗ್ರಾಮ್ಸ್ ಬರಲಿಕ್ಕೆ ಅವಕಾಶ ಇದೆ. ಆದರೆ ಅದರಲ್ಲಿ 1.8 ಗ್ರಾಮ್ಸೇ ಬರಲಿಕ್ಕೆ, ಅಂದರೆ ಟೋಟಲ್ ಅದರಲ್ಲಿ 4.9 ಗ್ರಾಮ್ಸ್ ಇದೆ. ಬಟ್ ನನಗೆ 1.8 ಗ್ರಾಮ್ಸ್ ಬರಲಿಕ್ಕೆ ಅಷ್ಟೇ ಕರೆಂಟ್ ಕಳಿಸಿದ್ದೀನಿ ನಾನು. ಸೊ ಪೂರ್ತಿ ಬರಲ್ಲ, ಗೋಲ್ಡೇ ಪೂರ್ತಿ ಬರಲ್ಲ. ಇನ್ನು ಗೋಲ್ಡ್ ಪೂರ್ತಿ ಬರಲಾರ್ದ ಸಿಲ್ವರ್ ಬರಲಿಕ್ಕೆ ಅವಕಾಶ ಇಲ್ಲ. ಸೊ ದಿ ಆನ್ಸರ್ ಇಸ್ ಓನ್ಲಿ ಗೋಲ್ಡ್, ಬಿಕಾಸ್ ಹೈಯರ್ SRP ಇದ್ದಿದ್ದು ಗೋಲ್ಡ್ಗೆ. ಆ್ಯಕ್ಚುಲಿ ಅದೆಲ್ಲ ಮಾಡುವ ಅವಶ್ಯಕತೆ ಇಲ್ಲ, ಗೋಲ್ಡೇ ಬರುತ್ತೆ ಅಂತ ಡಿಸೈಡ್ ಮಾಡ್ಬೋದು, ಯಾಕಂದರೆ ಹೈಯರ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅದರದೇ ಇದೆ. ಬಟ್ ನಾನು ಎದಕ್ಕೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ತೋರಿಸಿದ್ದೀನಿ ಅಂದರೆ, ಒಂದು ವೇಳೆ ಕೊಟ್ಟಿದ್ದ ಕರೆಂಟ್ ವ್ಯಾಲ್ಯೂಸ್ ಪ್ರಕಾರ ಏನಾದರೂ ಹೆಚ್ಚಿನ ಕರೆಂಟ್ ಕೊಟ್ಟಿದರೆ ಆವಾಗ ಗೋಲ್ಡ್ ಬಂದಿದ ಮೇಲೆ ಇನ್ನೇನಾದರೂ ಸಿಲ್ವರ್ ಉಳಿದಿರುತ್ತಲ್ವ, ಕರೆಂಟ್ ಉಳಿದ್ರೆ ಸಿಲ್ವರ್ ಕೂಡ ಬರುತ್ತೆ. ಅದಕ್ಕೆ ನಾನು ಅದನ್ನು ವೆರಿಫೈ ಮಾಡಲಿಕ್ಕೆ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಎಲ್ಲ ಮಾಡಿ ತೋರಿಸಿದ್ದೀನಿ. ಇನ್ನೊಂದು ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, 250 ml 0.1 ಮೋಲಾರ್ ಸಿಲ್ವರ್ ನೈಟ್ರೇಟ್, 0.1 ಮೋಲಾರ್ ಗೋಲ್ಡ್ ಕ್ಲೋರೈಡ್ ಅನ್ನುವ ಸೊಲ್ಯೂಷನ್ಸನ್ನು ತಗೊಂಡಿದ್ದಾರೆ. ಇದರಲ್ಲಿ ಕರೆಂಟ್ 1 ಆಂಪಿಯರ್ ಮತ್ತು 15 ಮಿನಿಟ್ಸ್ ಕಳಿಸಿದ್ದಾರೆ. ಕಳಿಸಿದ್ದಾಗ ಅಷ್ಟಷ್ಟು SRPs ಅದಾವೆ, ಅವುಗಳಕ್ಕೆ ಯಾವುದು ಸೆಟಲ್ ಆಗತ್ತೆ, ಎಷ್ಟೆಷ್ಟು ಸೆಟಲ್ ಆಗತ್ತೆ ಅನ್ನೋದು ಕ್ವೆಶ್ಚನ್ ಇಲ್ಲಿ. ಅದಕ್ಕೆ ನಾನೇನು ಮಾಡಿದ್ದೀನಿ, ಇಲ್ಲಿ ಆಪ್ಷನ್ಸನ್ನು ವೆರಿಫೈ ಮಾಡ್ತಾ ಸೆಕೆಂಡ್ ಲಾ ಅಪ್ಲೈ ಮಾಡಿದರೆ ಯಾವತ್ತೂ ಕೂಡ ಎಲಿಮೆಂಟ್ಸ್ ಡೆಪಾಸಿಟ್ ಆಗೋದು ತಮ್ಮ ಈಕ್ವಿವಲೆಂಟ್ ವೆಯ್ಟ್ಸ್ಗೆ ಪ್ರಪೋರ್ಷನ್ ಇರುತ್ತೆ ಬಿಟ್ಟು ಈಕ್ವಲ್ ಪ್ರಪೋರ್ಷನ್ಸ್ನಲ್ಲಿ ಯಾವುದೂ ಬರಲ್ಲ. ಸೊ ಫಸ್ಟ್ ಆಪ್ಷನ್ ತಪ್ಪು. ಎರಡನೇ ವಿಷಯದಲ್ಲಿ ನಾವೇನು ನೋಡಬೇಕು ಅಂತಂದರೆ, ಸಿಲ್ವರ್ ಮತ್ತು ಗೋಲ್ಡ್ ಎರಡು ಕೊಟ್ಟಿದ್ದಾಗ ಎಟಾಮಿಕ್ ವೆಯ್ಟ್ಸಿನ ಪ್ರಪೋರ್ಷನಲ್ಲಿ ಬರ್ತವೆ, ಹಂಗೂ ಬರಲ್ಲ, ಯಾಕಂದರೆ ಈಕ್ವಿವಲೆಂಟ್ ವೆಯ್ಟ್ಸಲ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ಲಿ ಬರಬೇಕು, ಅದು ತಪ್ಪೆ. ಇನ್ನೊಂದು ತರಹ ಹೇಳಬೇಕು ಅಂತಂದರೆ, ಇದು ಕೂಡ ಅಂದರೆ ಒಂದೇ ಸಲ ಬರಲ್ಲಲ್ವ, ಅದಕ್ಕೆ ಅದು ತಪ್ಪಾಗತ್ತೆ. ಮೂರನೇದು ಓನ್ಲಿ ಗೋಲ್ಡ್ ಓನ್ಲಿ ಸಿಲ್ವರ್ ಯಾವುದು ಬರುತ್ತೆ ಅಂತ ಅಂದಾಗ ಖಂಡಿತ ಈ ಎರಡು ಆಪ್ಷನ್ಸ್ ತಪ್ಪಿದರೆ ಮತ್ತಿನ್ನು ಉಳಿದ ಎರಡು ಆಪ್ಷನ್ಸ್ನಲ್ಲಿ ಫಸ್ಟ್ ಯಾವುದು ಬರುತ್ತೆ ಅಂತ ನೋಡಿಕೊಂಡ್ರೆ ಅದೇ ಆನ್ಸರ್, ಅಂದರೆ ಫಸ್ಟ್ ಬರೋದು ಗೋಲ್ಡ್. ಬಟ್ ನಾನೇನು ಮಾಡಿದ್ದೀನಿ, ಇಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಮಾಡಿದ್ದೀನಿ. ಏನು ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಮಾಡಿದ್ದೀನಿ ಅಂದರೆ, ಟೋಟಲ್ ಚಾರ್ಜ್ ಕಳಿಸಿದ್ದು 900 ಕೂಲೂಮ್ಸ್, 96,500 ಕೂಲೂಮ್ಸ್ಗೆ 197 ಗ್ರಾಮ್ಸ್, ಅಂದರೆ ಅದು ಮೋಲಾರ್ ಮಾಸ್ ಆಫ್ ಗೋಲ್ಡ್. ಅದು ಅಷ್ಟು ಬಂದರೆ 900ಗೆ ಎಷ್ಟು ಬರುತ್ತೆ? ಈಕ್ವಿವಲೆಂಟ್ ವೆಯ್ಟ್ ಕೂಡ ಈ ಎಕ್ಸಾಂಪಲ್ನಲ್ಲಿ 197, ಯಾಕಂದರೆ ಚಾರ್ಜ್ 1 ಇದೆ ಅಲ್ವಾ AUCLನಲ್ಲಿ, ಅದಕ್ಕೆ ನಾನು 1 ತೊಗೊಂಡಿದ್ದೀನಿ. ದೇರ್ ಫೋರ್ 197/1 ಇಸ್ 197. ಸೊ 96,500ಗೆ 197 ಬಂದರೆ 900ಗೆ ಎಷ್ಟು ಬರುತ್ತೆ ಅನ್ನೋದು ಕ್ವೆಶ್ಚನ್. ಅದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದರೆ 1.8 ಬರಬೇಕು. ನಮಗೆ ಇದ್ದಿದ್ದು ಸೊಲ್ಯೂಷನಲ್ಲಿ ಎಷ್ಟು ಅವೈಲೇಬಲ್ ಇದೆ ಅಂತ ನೋಡಿದ್ದೀನಿ. ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ 2.5 ಇಂಟು 10⁻⁻² ಇಂಟು 197 ಮಾಡಿದರೆ 4.925 ಬರ್ತಾ ಇದೆ. ಅಷ್ಟು ಗ್ರಾಮ್ಸ್ ಇದೆ ಗೋಲ್ಡ್ ಅದರಲ್ಲಿ. ಆವಾಗ ಅಷ್ಟು ಡೆಪಾಸಿಟ್ ಆಗಬೇಕಂದ್ರೆ ನಮ್ಮ ಹತ್ರ 1.8ಗೆ ಕರೆಂಟ್ ಐತಿ, ಅಷ್ಟಕ್ಕಿಂತ ಜಾಸ್ತಿ ಇಲ್ಲ, ಅಂದರೆ ಗೋಲ್ಡೇ ಕಂಪ್ಲೀಟ್ ಬರ್ತಾ ಇಲ್ಲ, ಇನ್ನು ಸಿಲ್ವರ್ ಬರಲಿಕ್ಕೆ ಅವಕಾಶ ಇಲ್ಲ ಅಂತ ಅರ್ಥ. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ಗೆ ಹೋಗೋಣ. ಇದು ಜಿಂಕ್ ರಾಡ್, ಇದು 1 ಮೋಲಾರ್ ಜಿಂಕ್ ಸಲ್ಫೇಟ್ ಸೊಲ್ಯೂಷನ್. ಕಾಪರ್ ರಾಡ್ 1 molar copper sulfate solution. ಇದು external EMF. E naughts ಕೊಟ್ಟಿದ್ದಾರೆ. Identify the incorrect statement ಅನ್ನೋದು question. First option, if external EMF is less than 1.1 volt, zinc dissolves at anode, copper deposits at cathode. B, if external EMF equals 1.1 volt, no flow of electrons occurs. C, if E external is greater than 1.1 volt, electrons flow from copper to zinc. D, if E external is greater than 1.1 volt, dissolves, zinc dissolves at zinc and copper deposits at copper. ಅನ್ನೋದು ಕ್ವೆಶ್ಚನ್. ಈ ಕ್ವೆಶ್ಚನನ್ನು ಆನ್ಸರ್ ಮಾಡಲಿಕ್ಕೆ ನಿಮಗೆ ಕೂಡ ವಿಷಯ ಗೊತ್ತಿದೆ ಆಲ್ರೆಡಿ. ಇದರಲ್ಲಿ ಇನ್ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಈ ತರಹ ಎಕ್ಸ್ಟರ್ನಲ್ ಇ ಎಮ್ ಎಫ್ ಕನೆಕ್ಟ್ ಮಾಡಿದ ಮೇಲೆ ಲೆಸ್ ದ್ಯಾನ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಇ ಎಮ್ ಎಫ್ ಇದ್ದರೆ ಗ್ಯಾಲ್ವಾನಿಕ್ ಸೆಲ್ ಫಂಕ್ಷನ್ಸ್ ಆಸ್ ಗ್ಯಾಲ್ವಾನಿಕ್ ಸೆಲ್ ಓನ್ಲಿ, ದೆನ್ zinc dissolves in zinc sulfate, copper dissolves in copper sulfate, electrons go from zinc to copper, current flows from copper to zinc. ಇಷ್ಟು ವಿಷಯ ಗೊತ್ತು ನಿಮಗೆ. ಇಲ್ಲಿ ಆಲ್ರೆಡಿ ಎಕ್ಸ್ಟರ್ನಲ್ ಇ ಎಮ್ ಎಫ್ ಲೆಸ್ ದ್ಯಾನ್ 1.1 ವೋಲ್ಟ್ ಇದೆ, ದೇರ್ ಫಾರ್ zinc dissolves in zinc and then copper deposits at cathode. ಇದು ಕರೆಕ್ಟ್ ಇದೆ, ಇದರಲ್ಲಿ ಏನು ತೊಂದರೆ ಇಲ್ಲ. ಎರಡನೇದಕ್ಕೆ ಹೋಗೋಣ. ಎಕ್ಸ್ಟರ್ನಲ್ ಇ ಎಮ್ ಎಫ್ 1.1 ವೋಲ್ಟ್ಗೆ ಹೋಗಿದರೆ ಅವಾಗ ಕರೆಂಟ್ ಅನ್ನೋದು ಫ್ಲೋನೇ ಆಗಲ್ಲ, ಬಿಕಾಸ್ ದೇ ಆರ್ ಮ್ಯೂಚುವಲಿ ಸೇಮ್. ಸೊ ವಿ ವಿಲ್ ದ್ಯಾಟ್ ಈಸ್ ಆಲ್ಸೋ ಕರೆಕ್ಟ್. ಎಕ್ಸ್ಟರ್ನಲ್ ಇ ಎಮ್ ಎಫ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 1.1 ವೋಲ್ಟ್ ಇದ್ದರೆ ಆವಾಗ ಇದು ಎಲೆಕ್ಟ್ರೋಲೈಟಿಕ್ ಸೆಲ್ ಆಗುತ್ತೆ. ಆವಾಗ ಜಿಂಕ್ ಡೆಪಾಸಿಟ್ ಆಗುತ್ತೆ, ಕಾಪರ್ ಡಿಸಾಲ್ವ್ ಆಗುತ್ತೆ. ಜಿಂಕ್ ಡೆಪಾಸಿಟ್ ಆಗುತ್ತೆ, ಕಾಪರ್ ಡಿಸಾಲ್ವ್ ಆಗುತ್ತೆ. ಜಿಂಕ್ರಿಂದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಕಾಪರ್ಗೆ ಹೋಗಲ್ಲ, ಕಾಪರ್ದಿಂದ ಜಿಂಕ್ಗೆ ಬರ್ತವೆ. ಕರೆಂಟ್ ಅನ್ನೋದು ಜಿಂಕ್ರಿಂದ ಕಾಪರ್ಗೆ ಹೋಗುತ್ತೆ. ಆವಾಗ ಇದು ಕೂಡ ಕರೆಕ್ಟೇ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಬಂದುಬಿಟ್ಟು ಎಕ್ಸ್ಟರ್ನಲ್ ಇ ಎಮ್ ಎಫ್ ಇಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 1.1 ವೋಲ್ಟ್ ಇದ್ದಾಗ ಜಿಂಕ್ ಡಿಸಾಲ್ವ್ಸ್ ಅಟ್ ಜಿಂಕ್ ಆ್ಯಂಡ್ ಕಾಪರ್ ಡೆಪಾಸಿಟ್ಸ್ ಅಟ್ ಕಾಪರ್ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ದೇರ್ಫೋರ್ that is an incorrect statement. ಗ್ರೇಟರ್ ದ್ಯಾನ್ ಇದ್ದಾಗ ಜಿಂಕ್ ಡಿಸಾಲ್ವ್ಸ್ ಅಲ್ಲ, ಡೆಪಾಸಿಟ್ಸ್. ಕಾಪರ್ ಡೆಪಾಸಿಟ್ಸ್ ಅಲ್ಲ, ಡಿಸಾಲ್ವ್ಸ್. ದೇರ್ಫೋರ್ we need to take fourth option as incorrect statement. Next question ಹೋಗೋಣ. Which of the following graphs between molar conductivity versus root C is correct? ಇದು NaClದು, ಇದು KClದು, ಇದು NaClದು. ಇವು ಎರಡೂ ಕೂಡ ಸ್ಟ್ರಾಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ಸ್ ಆಗಿರುವುದರಿಂದ ಆಲ್ ಆರ್ ಸ್ಟ್ರೈಟ್ ಲೈನ್ಸ್ ಅನ್ನುವ ವಿಷಯ ಸ್ಪಷ್ಟವಾಗಿ ಗೊತ್ತು ನಮಗೆ. ಆದರೆ ಇಲ್ಲಿ ಪ್ರಾಬ್ಲಮ್ ಏನಂದರೆ ಹೈಯರ್ ವ್ಯಾಲ್ಯೂ ಕೆ ಸಿ ಎಲ್ಗೆ ಇರಬೇಕಾ ಎನ್ ಎ ಸಿ ಎಲ್ಗೆ ಇರಬೇಕಾ ಅನ್ನೋದು ಕ್ವೆಶ್ಚನ್. ಈ ಗ್ರಾಫ್ಸ್ನಲ್ಲಿ ಎಲ್ಲಿ ಕೂಡ ನಮಗೆ ಇಂಟರ್ಸೆಕ್ಷನ್ ಬರಲಿಕ್ಕೆ ಅವಕಾಶನೇ ಇಲ್ಲ. ದೇರ್ ಫಾರ್ ಆಪ್ಷನ್ ನಂಬರ್ 3 ಆ್ಯಂಡ್ 4 ತಪ್ಪು ಅಂತ ಅಂದ್ಕೊಂಡ್ರೆ ಎನ್ ಎ ಸಿ ಎಲ್ಗೆ ಜಾಸ್ತಿ ಇರುತ್ತಾ ಕೆ ಸಿ ಎಲ್ಗೆ ಜಾಸ್ತಿ ಇರುತ್ತಾ ಅಂತ ನಾವು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ದಾಗ ಖಂಡಿತ ಕೆ ಪ್ಲಸ್ ಲಾರ್ಜರ್ ದ, ನಿನ್ನೆ ಕೂಡ ಹೇಳಿದ್ದೀನಿ, ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಈಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ಚಾರ್ಜ್ ಆ್ಯಂಡ್ ಸೈಜ್ ಎಕ್ಸೆಪ್ಟ್ ಫಾರ್ H ಪ್ಲಸ್ ಆ್ಯಂಡ್ ಎನ್ ಎ ಪ್ಲಸ್ ಅಂತ, H ಪ್ಲಸ್ ಆ್ಯಂಡ್ OH ಮೈನಸ್ ಅಂತ. ದೇರ್ ಫೋರ್ ಸೈಜ್ ಇಲ್ಲಿ ಕೆಗೆ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಅದಕ್ಕೆ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಕೂಡ ಅದಕ್ಕೆ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಹಾಗಾಗಿ ನಾನು ಗ್ರಾಫನ್ನು ಇದು ಚೂಸ್ ಮಾಡ್ಕೋಬೇಕಾಗತ್ತೆ. ಈ ಆಪ್ಷನ್ ಕರೆಕ್ಟ್ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. A solution of nickel nitrate is electrolyzed between platinum electrodes with 0.1 Faraday of electricity. How many moles of nickel will actually settle? Charge 2 ಇದೆ ಅಲ್ವಾ, ಅಂದರೆ ಚಾರ್ಜ್ 2 ಇದ್ದದಕ್ಕೆ 2 moles of nickel plus 2 plus 2 electrons gives rise to nickel. 1 mole of nickel ಬರಬೇಕಂದ್ರೆ ನಾನು 2 Faradays ಕಳಿಸ್ಬೇಕು. 1 ಮೋಲಿಗೆ 2 Faradays ಕಳಿಸ್ಬೇಕು, ಬಿಕಾಸ್ 2 moles ಇದೆ ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಮತ್ತವಾಗ 0.1 Faraday ಕಳಿಸಿದ್ರೆ ಎಷ್ಟು ಅಂತ ಅಂದರೆ ಇದು 1 into 0.1/2 ವಿಚ್ is 0.05 ಮೋಲ್ಸ್ ಅಷ್ಟು ಸೆಟಲ್ ಆಗುತ್ತೆ ಅನ್ನೋದು ಆನ್ಸರ್. ಸೊ ಐ ವಿಲ್ ಎಕ್ಸ್ಪ್ಲೈನ್ ಇಟ್ ಅಗೇನ್. ನಿಕೆಲ್ ನೈಟ್ರೇಟನ್ನು 0.1 Faradays ಅಷ್ಟು ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಕೊಟ್ಟು ಎಲೆಕ್ಟ್ರೋಲೈಸಿಸ್ ಮಾಡಿದ್ದಾಗ ಎಷ್ಟು ಮೋಲ್ಸ್ ಆಫ್ ನಿಕೆಲ್ ಅನ್ನೋದು ಸೆಟಲ್ ಆಗುತ್ತೆ ಅಂತಂದರೆ, ನಿಕೆಲ್ ಪ್ಲಸ್ 2 ಅನ್ನೋದು ಚಾರ್ಜ್ ಇಲ್ಲಿ, ಅದು ಸೆಟಲ್ ಆಗಬೇಕಂದ್ರೆ 2 moles ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಕಳಿಸ್ಬೇಕು, ಆವಾಗ ನಿಕೆಲ್ ಬರುತ್ತೆ. ಅದಕ್ಕೆ 1 mole ಆಫ್ ನಿಕೆಲ್ ಬರಬೇಕಂದ್ರೆ 2 Faradays ಕಳಿಸ್ಬೇಕು. 2 electrons ಅಲ್ವಾ, 2 moles ಅಂದರೆ 2 Faradays. ಆವಾಗ 0.1 Faradayಗೆ ಬರಲಿಕ್ಕೆ ಎಷ್ಟು ಅಂತ ಅಂದರೆ 0.05 moles ಬರುತ್ತೆ ಅಂತ ನಾವು ತಿಳ್ಕೋಬೇಕು. ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್. ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಫಾರ್ NaCl 126.4, ಫಾರ್ HCl 425.9, ಫಾರ್ NaA ಅಂದರೆ ಎಸೆಟೇಟ್ ಅಯಾನ್ ಅದು 100.5. If conductivity of 0.001 molar HA is, conductivity is 5 into 10 to the power minus 5. Concentration is 10 to the power minus 3. Asking for alpha. Alpha ಬೇಕಂದ್ರೆ ನಮಗೆ ಲ್ಯಾಂಬ್ಡಾ ಎಮ್ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಎರಡೂ ಬೇಕು. ಫಸ್ಟ್ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಕ್ವಿಕ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಣ. ಫಾರ್ HA ವಿಚ್ ಈಕ್ವಲ್ಸ್ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್, H ಪ್ಲಸ್ ಇಲ್ಲಿದೆ ಇದು ಬೇಕು, HCl ಪ್ಲಸ್ ಎ ಇಲ್ಲಿದೆ ಅದು ಕೂಡ ಆ್ಯಡ್ ಮಾಡ್ಕೋಬೇಕು. ಬಟ್ ನನಗೆ HAದಲ್ಲಿ CL ಬೇಡ, NaAದಲ್ಲಿ Na ಬೇಡ, ಅದಕ್ಕೆ NaCl ಸಬ್ಟ್ರ್ಯಾಕ್ಟ್ ಮಾಡ್ಕೋಬೇಕು. ಆವಾಗ HClದು 425.9, NaClದು 126.4, 100.5 ಮೈನಸ್ 126.4 ಸಬ್ಟ್ರ್ಯಾಕ್ಟ್ ಮಾಡಬೇಕು. It is 526.4 minus 126.4, 400. ಆಮೇಲೆ ಲ್ಯಾಂಬ್ಡಾ ಎಮ್ ಕೂಡ ಮಾಡಬೇಕು. By using the formula, concentration is 10 to the power minus 3, so we get 50. ಈಗ ಆಲ್ಫಾ it is 50 by 500, 400, that is 8 times 0.125 is what we get. ಸೊ ಆಲ್ಫಾ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಲ್ಯಾಂಬ್ಡಾ ಎಮ್ ಆ್ಯಂಡ್ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ ಎರಡು ಬೇಕಾಗ್ತವೆ. ಅದರಿಗೋಸ್ಕರ ಲ್ಯಾಂಬ್ಡಾ ಎಮ್ 50, ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ 400 ಬರಬೇಕು. ಅದರಿಗೋಸ್ಕರ ಲ್ಯಾಂಬ್ಡಾ ನಾಟ್ ಎಮ್ಗೆ ನಾನು ಹೆಚ್ ಸಿ ಎಲ್ದನ್ನು ಎನ್ ಎದು ಆ್ಯಡ್ ಮಾಡಿ ಎನ್ ಎ ಸಿ ಎಲ್ ಸಬ್ಟ್ರ್ಯಾಕ್ಟ್ ಮಾಡಿದ್ದೀನಿ, 400 ಬಂತು. ಲ್ಯಾಂಬ್ಡಾ ಎಮ್ ಮೋಲಾರ್ ಕಂಡಕ್ಟಿವಿಟಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿ ಕೆ ಇಂಟು 1000 ಬೈ ಸಿ ಮಾಡಿದ್ದೀನಿ. ಅದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ದಾಗ ನನಗೆ 50 ಬಂತು. 50 ಬೈ 400 ಹಾಕಿದರೆ 0.125 ಡಿಗ್ರಿ ಆಫ್ ಡಿಸೋಸಿಯೇಷನ್ ಬರುತ್ತೆ. ಇಷ್ಟಕ್ಕೆ ಸ್ಟಾಪ್ ಮಾಡೋಣ. ನಮಗೆ ಈ ವಾರ ನನ್ನ ಟ್ರ್ಯಾಕ್ರಿಂದ ಇರುವ ಚಾಪ್ಟರ್ಸ್ ಏನಂತಂದರೆ ಎಲೆಕ್ಟ್ರೋಕೆಮಿಸ್ಟ್ರಿ ಮತ್ತು ಸೊಲ್ಯೂಷನ್ಸ್, ಆಮೇಲೆ ಇಲ್ಲಿವರೆಗೂ ಹೇಳಿದ 3 ಚಾಪ್ಟರ್ಸ್, ಸಮ್ ಬೇಸಿಕ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಆಫ್ ಕೆಮಿಸ್ಟ್ರಿ ಕೂಡ ಬರುತ್ತೆ. ಈ 3 ಚಾಪ್ಟರ್ಸ್ನಲ್ಲಿ ನಾಳೆ ಎಕ್ಸಾಮ್ ಇರುತ್ತೆ, ಪೇಪರ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಕೂಡ ಇರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ವೀಕ್ ಉಳಿದಿದ್ದ ಚಾಪ್ಟರ್ಸ್ ಇನ್ ಮೈ ಟ್ರ್ಯಾಕ್, ಇಲ್ಲಿ ಕೆಮಿಕಲ್ ಕೈನೆಟಿಕ್ಸ್, ಡಿ ಆ್ಯಂಡ್ ಎಫ್ ಆ್ಯಂಡ್ ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್ಸ್, ಈ ಚಾಪ್ಟರ್ಸನ್ನು ನೆಕ್ಸ್ಟ್ ವೀಕ್ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಥ್ಯಾಂಕ್ ಯು.